then we'll just go and dive straight into our heavy session day that we hope that all of you will enjoy. So let me share my screen really quick. Okay, so can you see my screen? Okay, so welcome. So one of the things that I want to tell you is, so we have a Slack channel. You can join us if you go to jnation.pt/Slack. And on Slack, you're going to be able to network and talk with either speakers, other conference attendees, the organization. So it's like the perfect place for you to be able to network, because I mean, of course, we're not in like a physical conference. So please join us over there, and then you can also send your questions to the speakers that will be happily relaying back during the session. So please join us on Slack. This conference we will not be able to do this conference without, of course, all of our sponsors. And we're really grateful and happy that all of these were able to attend and help us this year. So we have a lot of sponsors that are with us since the first year. So a couple of them like Bosch, Mercedes, Red Hat, present, Week, Self Focus, Mindera. So they are with us since our very first edition. But we have, and Louder Roots as well. But we have a few more like JFrog, Deconium, TBLX, XGeeks, Tamana, Talkdesk, Cleva, Volkswagen. So some of them are new, some of them are returning from last year. So thank you so much for all the support. Thank you so much for making these a reality, because without your support, we will not be able to do this as a free event for everyone to watch and see.
Roberto, não estás a fazer screen share, man?
Não?
Não.
Opa, então...
Não fizeste screen share.
Eu pensava que isto estava feito. Ok, sorry.
Não fizeste. Espera, dá-me um segundo, dá-me um segundo que é para a gente recuperar aqui, espera. Ok, vai estar live em... Já está? Não mudaste tudo.
Okay. Yeah, so apparently like these technical difficulties, so this is not starting very well. Anyway, so I was saying that you can join us on Slack. So this is the slide, jnationpeaks.slack. So these are sponsors for today. I hope that you can appreciate what they are doing for us today. And one of the most important thing is Jnation is actually organized by a nonprofit organization. So we took the decision this year to try to help some other organizations that are having a lot of difficulties due to the pandemic and due to COVID, as you know. So we are going to do a donation based on the amount that we got from our sponsors to one association here in Coimbra. That's where Jnation usually happens. It's called the Niño Missão Sorriso. And they want to, or their main purpose is actually to help small children that for some reason they are unprotected, they don't have families, or they need some kind of help. So we are going to help them with some of the donations based on the amount we got from our sponsors. So for us, it's also very important because we want to help the community moving forward, and this is like a way not only to help our local communities, but also to allow other children and to allow like these small kids to have better lives. So thank you again, all of our sponsors. You also made this possible, and hopefully we're going to be able to do this to a few more organizations and institutions with over the years. And I mean that was it. So please enjoy the conference. So we're gonna go like, this was like super quick introduction. We're gonna go for a quick break, and then we're gonna have here our first speaker in a couple of seconds. So thank you so much for joining us, and hope to enjoy the day. Bye bye.
C'est qui Manon? Oh Manon, t'es belle! Oh, je t'aime! Arrête!
Tu multiplies en plus et après t'additionnes.
Allez, bouge là!
Va faire tes devoirs dans ta chambre.
Non, il a pas de bureau.
Manon, t'es belle!
La nuit est passée comme ça.
Ah là.
Maman,
On a
j'ai
marché,
accepté.
la terre a
Dans ta
tourné.
Vas-y, va dans ta chambre.
Moi, j'aime trop ta chambre.
Maman, je
S'il
veux
te
pas
plaît.
bouger ma chambre là.
Do início novo um crescimento, vai ter uma paragem grande durante o susto inicial, que demorou 6 a 8 semanas. Pronto, e depois chegamos ao período de maio a junho, com bom tempo, só que as pessoas não podiam sair e, portanto, quiseram na mesma aproveitar dos espaços que tinham, que acabava por ser o espaço em casa, e, portanto, aí sentimos um crescimento forte a nível de mobiliário, que depois se prolongou com um crescimento a nível de tudo o que é roupa, porque chegou a volta à escola e os filhos crescem, não é? E, portanto, aí não há hipótese, as pessoas têm de comprar roupa. Portanto, e aí nós já tínhamos a visão da plataforma bem estabelecida, a plataforma para as famílias, mas esse posicionamento fez todo o sentido, porque nós tanto ajudamos na parte do mobiliário que de vestir a família nesses períodos mais complicados. E, portanto, aí sentimos um crescimento tanto de clientes existentes que de recrutamentos de novos clientes que não estavam, se calhar, habituados a comprar digital. Portanto, algo que fizemos logo do início foi de reforçar a parte do contato cliente para dar suporte, porque tivemos, de facto,
Hi, everyone. Good morning and welcome to the first session at the Almedina track. For this first session, we will have Anton Rodriguez. He's joining us from Spain. Hi, Anton.
Hi, everybody. Bon dia.
Bon dia. And he will talk to us about schema management, the elephant in the cloud room. Welcome, Anton, and have a nice session.
Thank you very much, Bruno. It's a big pleasure for me to be in Jnation today. In this session, we are going to speak about schema management, also about how to integrate on-prem data centers with cloud or clouds between themselves. So how to move data from one place to another one in a quite good scalable way. Let's introduce myself first. My name is Anton Rodriguez. I am a principal software engineer working in New Relic. Before than that, I was working in other big corporations like Inditex Group, like Vodafone, Orange, and many more, specialized in building internal platforms so developers inside those companies can use those platforms to build their own services and to solve business problems. I started with orchestration, then I moved to build API gateways, API platforms. In the last year, I've become very specialized in data streaming. So working with Kafka, Flink, Kafka Strings, Spark, and in general, the data in motion, moving data from one place to another one in near real time. Because of that, I am running now a community called Streaming Annotated. It started as a newsletter covering the last news about Kafka and the other platforms, and also what the cloud providers are doing in that particular space. So if you have interest in this topic, just go to streamingannotated.substack.com and you can join, receive those news and participate. It's a very welcoming community. I'll also organize the Java user groups in Vigo and Coruña that are in Galicia, very close to Portugal, very active on the community. So let's start what we are going to cover here today. It's how to load data to the cloud. So let's try something here. Let's start with the basis. So we have our producer application, okay? This can be any type of application. It can be a microservice, a monolith. It maybe even can be a database. Most of the databases now have some features called change data capture, which are able to all the changes in the database, expose them so you can move that data to other places. So thinking any application generating data. And what we want to do is to move that data to the cloud. So that may be any cloud and any storage in the cloud. So maybe it's a database, maybe it's an object storage. Things like BigQuery or Snowflake or AWS S3, it doesn't matter, okay? Our application just want to move information to the cloud. So what we can do here is to add or use the SDK provided by that storage. So some libraries in our application, and using them, just upload our data directly to the database or whatever service, so it can be consumed and used by other teams, other developers, or our customers. This is a pretty typical pattern you can see out there, but it also has some problems. The main problem I see is if we have slow connectivity for whatever reason between our producer and the cloud storage, things are going to be complicated. So we may have problems here typically, or here in the cloud. You know, the cloud sometimes fails, sometimes have problems. When that happens, we don't want our producers to be affected. But with this pattern, the only thing the producer can do is start to buffer all that data, maybe in memory, waiting to recover the connectivity, and once it happens, send it to the cloud. If the problem persists for a long time, in some point, our producer is not going to be able to retain that data and is going to have to discard part of that information, or maybe store it in an internal place. So once it has connectivity again, can start to recover and send that information. This is not good. It's quite challenging from the producer point of view, and it's very complicated. So some of the improvements to this I usually propose is to use a service like Kafka. But let me first cover the basics here. I know my drawings are not exactly the best out there, so I have also slides for you, but it's exactly the same thing. We have our producer sending data to our storage. Our producer needs to care about the connectivity, the storage, and the problems it may generate. So let's use Kafka to improve our scenario, right? So what is Kafka? If we see Kafka as a black box, is we have our producer generating data, and it can send it to this black box Kafka. And from here, we are going to have different consumers reading the data. So when I say data, it's wherever you want, maybe strings, maybe JSON files, maybe CSVs. Kafka really doesn't care about the format. So we send the data, and this is one of the benefits of Kafka, is going to be able to send that data to all the different consumers. So all of them are going to receive a copy of our data. If one of those consumers is slow or it has problems, the other consumers are not going to be affected. So the first benefit of Kafka compared with other systems like MQs and so on is the ability to decouple the consumers and the producers, but also the consumers between themselves. So if we have a consumer which is slow, having problems or whatever, the other consumers doesn't care about it because Kafka is able to make them independent. The other particularity or benefit of Kafka is when we send a message or data to Kafka, Kafka is going to store it internally in a log file. And once it's read from the other consumers, Kafka yet keep that file internally. So if we have now a new consumer, that consumer can choose to read from the very beginning and read that data, or can read just the newest, but you have that election. If one of the existing consumers, for whatever reasons, needs to reprocess the data, it can also do it. So it can come to Kafka and say, hey, I processed that message, but it was wrong, my processing, I need to redo it. So please send to me that message again. Okay, so this is called the replayable log. And it's also a very interesting feature of Kafka compared with other systems. The third one is the capacity of Kafka to provide high throughput for the ingestion. So it's really fast persisting data. So our producers can typically send a lot of data and Kafka is able to store it very, very quickly. So our producers don't need to care. They only care to send the data to Kafka, and that's all they care, okay? So this is the Kafka as a black box. It's not a database, it's a place designed for data in motion, and the benefits are high ingestion, consumers which are able to consume, to read in an independent way, and being able to store the information for a configurable period of time, like 1 week, 1 month, or whatever you want. So that information is kept in Kafka to be reused if needed, or to be sent to new consumers if needed. Kafka provides even more features which are interesting. One of them is it's a distributed system. So we have our producer, and Kafka typically is a cluster of nodes. Those nodes are called brokers. So we have broker 1, broker 2, broker 3, and our producers can send data to broker 1. And if broker 1 is down, instead of sending to broker 1, it's going to send it to broker 2, and the system continues working. So we have that high availability. It's not only from the producer point of view. When we send a message to broker 1, we typically also to configure the broker to create a copy of that message, for example, in broker 2, and maybe even in broker 3. So this is the replica of our data. If we lose broker 1 for whatever reason, we lose it forever. It's not a big deal because we have yet a copy of our data in the broker 2 on broker 3. So also Kafka gives us the possibility to don't lose information, to don't lose our data, because it's replicated in different machines and in different places. So this is the Kafka architecture. What we have here is, as I say, the producer sending to different brokers and the information replicated to the other brokers. So we have our consumers reading from the broker 3, a segment, a partition called leader 3. If we lose broker 3 forever, our consumers can go to replica 3 in a different broker, and we are not going to lose that information. And that's a very important feature of Kafka. So let's see how we can use Kafka to upload information to the cloud. What we're going to do here is, again, we have the producer. But now, instead of send directly to the cloud, the producer is going to send the data to Kafka. And now we have here our cloud with a storage. And what we're going to do is, from Kafka, read that data and ingest it in our cloud storage. So we have, for example, we can do it with Kafka Connect. Kafka Connect is a framework, it's part of Kafka. And basically it gives you like default integrations between Kafka and different systems. You can think in every database out there, every object storage, or other brokers and so on. So you don't need to code anything. It's just configuration. You configure what topic you want in Kafka, with what credentials you want to use, and what database you want to put information, what table, for example. And Kafka Connect, it's able to read from Kafka and to send it to the storage. Okay. So it's a really fast setup because it's just configuration. Now, if we have problems here or in the storage engine, our producer doesn't care at all. Our producer only needs to understand how to send data to Kafka. And once the data is in Kafka, he can forget. It can forget because it's safe now in Kafka, and Kafka using Kafka Connect is going to retry until it's able to put that information in the cloud provider. So from the perspective of our applications, this setup, it's much better. There are also other benefits. Let's, for example, think we have different storage in the same cloud. So maybe we have here storage A, and now we have storage B. This is pretty common. For example, if storage A may be something like BigQuery, so it's like a data warehouse where our analysts and business people, it's just doing queries to understand the business. And storage B may be a more long-term storage like S3 or Azure Blob Storage. So our data science are there using Spark, for example, running machine learning models and things like that. Okay, so when that happens, what we can do is to have Kafka Connect reading for exactly the same topic in Kafka and sending the information to the storage B. Okay, that's perfectly possible, and because Kafka is able to make those both consumers, Kafka Connect and first one and the second one independent, it works quite well. But it also has some problems. And the main problem is in big organizations where there are many producers, many teams, and in many cases duplicated data. What we are doing here is to send in that information 2 times to the cloud. And typically the connection between our data center and cloud, it's very expensive. So now we are sending exactly the same information 2 times. So we are paying 2 times for the same thing. And that's something we try usually to avoid. So the ideal thing, it will be sending just 1 time, and from there being able to replicate the data to the different storage we may need. Okay, so let's summarize with the slides and then cover that part. Better approach, we use Kafka Connect to send to the storage. So our producers are the couplet of the cloud services. If there are problems of connectivity, if there are problems in the cloud, our producer really don't care about it. The only problem we have in some cases when we are working in big organization or scaling this a lot is we are duplicating the load, or sometimes it can happen several times. And that's pretty expensive and pretty inefficient. So how we can avoid that? It's with the next pattern, and this is my favorite thing because it enables a lot of things, which is we have the producer. Sorry. We have the producer. It sends the information to Kafka. Now we have again our cloud and Kafka Connect. But now Kafka Connect, instead of sending the information directly to the storage, is going to send it to a broker as Kafka. For example, PubSub. PubSub is the equivalent service in Google Cloud. You may think a Kafka version, but internally in Google Cloud, it provides very similar features. Okay. Of course, we could use Kafka too, but in our case, we prefer to use PubSub because it's integrated with other cloud services. So it makes our life easier. But in other cases, we use Kafka. So that depends a lot of your use case. But as an example, let's use PubSub. So now Kafka Connect has a connector specifically for PubSub. So now we are sending our data to PubSub, and from PubSub, now using data flow, Dataflow is a framework to move data between places in streaming. So it's kind of similar to Kafka Connect, but it's coding. So it's much powerful, and you can do transformations, aggregations, filterings, and so on. And it's provided as a cloud service in Google Cloud. So using that, we can easily send our data to a database or storage. For example, in this case, BigQuery. The other one, which may be an object storage like Google Bucket. So now our communication is just not directly to the cloud. We have brokers in the middle. So we are decoupling all the different pieces, the producers, the consumers, and even the replication of data between clouds. And we try to do this in a centralized way. So we control always that, that connection, and we can make sure it's working properly and is used for all the teams in the company in a responsible way. And that's also a pretty important point. So based in this simple pattern, we start to build a much more complete platform to communicate different clouds and different data centers around the world. So what we have is a specific team looking at this and providing this as a platform to the other teams in the organization, and also looking for improvements to make it much more efficient. One of those improvements are compression. So compression is basically the ability in Kafka, Pulsar, and all those broker systems to compress the data in the producer and decompress the data in the consumer. So if we take a look to our previous scenario, we write another one. What we do is our producer is putting several messages together. So we have all the messages, small messages together. We put them together in something we call a batch, and we compress that batch, making it smaller. Now we send that batch to Kafka or to Pulsar or to whatever service. Our consumers read that batch, decompress it, and now they have access to the original messages. And this is super important because doing this, what we are going to do is to save bandwidth between our producers and Kafka. We are going to save bandwidth and storage in Kafka because those messages are going to be stored together and compressed. So we don't need so much storage in Kafka. And they are going to send to the different, or to the cloud, compressed. So we are also saving bandwidth in our cloud connections. And that's the most important thing because it's super expensive. The not so good thing is our producers and consumers need to spend some time compressing and decompressing the data. But that's a minor thing compared of all the other benefits. And that's why I always or almost always recommend to use compression to move data in streaming. Indeed, this is so important. Kafka, Pulsar, and the other brokers have specific possibilities to choose different algorithms. For example, you can choose set a leaf. This is a very popular algorithm. It's used, for example, in the Apache web server and many other places. The compression ratio is really good, so you are going to have smaller messages. The only problem with set leaf is it also requires a lot of CPU and some memory from the producer and the consumer to do the compression and the decompression. And because of that, we have other alternatives. For example, setstd, this is a compression algorithm from Facebook. It has a similar compression ratio to setlib, but it doesn't require so much performance, so much work in the producer and the consumer side. So it's like a more efficient. And if you really worry about the work in the producer and the consumer, then there are even more alternatives. Snappy, that this is one from Google, it's also very popular. It's more designed to achieve a smaller compression ratio, but it's more optimized for throughput because producers and consumers don't need to do so much work to do the compression and the compression. And there is even another one, LSL4, which is similar to Snappy, but it tends to have a better decompression speed. So it's not easy to recommend one or another one. What I recommend is to use compression. If you need to do this type of tuning, do some benchmarking with each of them to see what works better for your data, because they are highly dependent of your data. Depending on how it's organized, structured, what file format you're using, you may obtain different results. So it's always a good thing if you can spend some time doing a benchmarking with real data or similar to real data to see what is giving you the best performance and compression ratio. The other improvement we're working on is to use schema registry, okay? So what is a schema registry? So basically, we have our producer, once again, sending to Kafka. And we have our consumer. But we have most of the teams out there, most of the developers, I don't know most, but many of them use JSON. So they are sending JSON messages to Kafka. There are good reasons for that, because JSON, probably you already have the data in that format because you are reading from a Mongo database, or because you are receiving that data from a REST API or something like that. But the problem with JSON is it's not very efficient. With JSON you have something like ID, one name, Tom, and you look to this is not efficient because you are sending a lot of extra characters, which a machine really don't need to understand the data. You are even sending the keys, which are always the same in each message. So instead of that, you could send something like one Anton. And this is going to be much more efficient because you are sending less data, right? You're sending the same data, but with less in a smaller message. So there are some formats you can use to do this. The most popular out there are Apache Avro and gRPC. Avro is from the Apache Foundation, gRPC is from the Cloud Native Foundation. They are binary protocols, so when you use them, the message is smaller. But the problem with this is, in order the consumer to be able to read the message, it needs to know in advance the schema, so how the data is organized. The schema is just a text file describing the different fields. This is the first field, it's an integer, the second one is a string. So when you are deserializing the message, the library knows how to do it. Okay, so we could send to Kafka the message, the Avro message, and the schema, but there is a better way. And that better way is using a component, an external component called a schema registry. So a schema registry is just an API, a REST API, which is basically what you're going to do is the producer before to send the message to Kafka, it's going to invoke this API to send the schema. It's going to retrieve an ID. This is just a number, I think 1. And now it's going to send to Kafka the number and the message. Our consumer is going to receive the number and message, is going to request to the schema registry, give me the ID, the schema with the ID 1, is going to return the schema, and now it can deserialize and use the message. So as you can see, it's much more efficient because we are not sending the schema in each message, we are only sending a number, and typically you are going to cache the schema in the consumer and in the producer side, so you don't need to do it for each request. There is also a benefit is in the schema registry, you can have some compatibility rules. So basically, if the consumer wants to evolve the schema, for example, the producer wants to delete some fields, okay, the schema registry can check if our consumers are going to be able to continually working because this is a compatible change. So for example, in this case, delete a field, it's not compatible because with the new schema, the consumer is not going to be, sorry, with the old schema, the consumer is not going to be able to read the old messages because now there is a field name, but it's not informed anymore. Okay, so with the schema registry, you can make sure your producers only make changes in the schema which are not going to break your consumers, and that's a really good thing. But this is exactly the same thing. You can see we have our producers sending to Kafka and registering the schema registry, and the consumers reading from it. Okay, there are different compatibility rules you can use, like a backward compatibility rule. So you are only going to allow to delete fields or add optional fields. You can have a forward compatibility rule, so you can only add fields and delete optional fields. You may even want to have full compatibility rules, so they only can add or delete optional fields, or you may have any, so you allow all the changes. Depending of what you choose, the old schemas may read the new messages, or the new schemas may read the old messages, of both things. Okay, so that this is very important to keep compatibility in big asynchronous architectures and make sure things work well. If someone needs to introduce a breaking change, what they have to do is to create a new topic and inform the consumers to go to that topic and to make the changes they need to avoid problems. Okay, but in general, the schema registry is able to enforce that, and that's a good thing. So with all this together, we built this platform, and the motto of the platform was produce once, consume anywhere. The idea of our platform, it was an internal platform, is every developer in the company can produce information in, it doesn't matter where. So it doesn't matter if it's a particular cloud, it doesn't matter if it's a particular data center, it doesn't matter if it's in a different country, and they can put that information, that data in our platform. So it may be Kafka, Pulsar, Google PubSub, Microsoft Azure Event Hub, or Azure Kinesis, or sorry, AWS Kinesis or AWS MSK. It doesn't matter the technology, whatever is better for them. And we are able to do the governance of that data, to provide discovery in a self-service portal, and also to provide to everyone in the company the possibility to replicate the data to a different place using different technologies so they can read it and use it. And all of that with a self-service portal, so they really don't need to care how the platform is working under the hood, and all the problems and all the connectivity and all the technologies involved. They're just owners of their data, and they have a simple way to discover data from others and to request access to the data to be able to consume it. So this is like the produce once, consume anywhere vision we were working on. In order to do that, going further, we need to be able to replicate information and schemas between different places, different clouds, and different different data centers. Okay, so our first approach was to use something called a single primary architecture. This is basically, we have our Kafka in our data center, in one of our data centers. So let's call it the primary data center. And we have our producer in the data center sending data to Kafka. We have a schema registry. So it's registering the schema in advance and generating ID, for example, 1. Now we have a different data center, also with Kafka. We have now a consumer which wants to read that data. So what we are going to do, as we mentioned before, is send that data to this Kafka using Kafka Connect, but our schema registry doesn't know the ID 1, doesn't know what schema is the ID 1. So what we did initially was, let's replicate our schema registry in the other data center. So now we have ID 1 here. Our consumer can read the message with ID 1 and go to the schema registry and obtain the schema. And that works quite well. The thing is, now this data center is secondary data center because we cannot write, we cannot register schemas in this schema registry. If we do that, the schema registry will give IDG, in this case 2, but now if someone is doing the same thing at the same time in our primary, it will have also an ID 2, and those schemas are going to be different. So we don't allow that. Okay, you can only write to the primary data center. And what we did is, instead of allow our producers to do it, what we do it is with a CI/CD service. So we have like a Git repository with the schemas, and each time you create a schema, it comes to the schema registry and do the registration in advance. This works quite well, but it has some important limitations. The first limitation is this only works if you have Kafka, but if you have different technologies, different services, it doesn't work because you can do the replication between the different schema registries. So for us, this was a quite important problem because we also wanted to work with some cloud technologies like PubSub, Event Hub, Kinesis, MSK. The other thing is, if we have a problem with the primary data center, one of our secondary data centers becomes the primary. So we have high availability. But when that happens, our producers need to know now they have to register the schema in a different data center. And that's kind of tricky to inform all our producers of those changes and make sure that they are like transparent to them, especially when we have producers, we need to evolve the schema dynamically. Things like change data capture, we mentioned it before, need to be able to register a new schema when there is a change in the database, when, for example, you add a new column to a table. So in order to do that, that becomes quite complicated. So we evolved this architecture from the single primary architecture to what we call event mesh. With an event mesh, we have exactly the same thing. We have Kafka in the middle. And now we are sending the data to different places. So things like Confluent Cloud, which is based in Kafka, things like Kafka, Event Hub, or PubSub. But what we do here is instead of trying to replicate those schemas and have the same ID in every cloud, what we are going to do is each time we read a message and we send the message to the cloud, what we do is in advance with using a component called SMT, single message transformation, which allow us to introduce some customizations in Kafka Connect. What we do is we go first to the schema registry in the target cloud. We register the schema. It generates an ID only for that cloud, and we send the message with that ID and not with the source ID. So with this SMT, for every service, we are doing the transformation between the schema IDs in the source cloud and in the target clouds. And it doesn't matter if they are using a different technology or even a different format. For example, in the case of Event Hub and PubSub, they are not using a number, they're using a string as identifier, but we don't care about it because our SMT is able to, in a transparent way, to do the modifications on those things. So this worked much better for us because it allows to produce schemas in every cloud, and it only replicates those schemas or translate those schemas when needed. My conclusions: produce once, consume anywhere. It's a great concept. The event mesh, I think it's the way to go to replicate information between clouds. But it's yet not very mature. It's more for early adopters right now, in my opinion. If you stick to just one single vendor, like initially in our case was Confluent Platform, make things easier because you don't have to manage all those differences. So you can use the single primary architecture and some specific tooling to do it. But if you need to have like different technologies involved and work with all of them, it's yet possible, but some of those things are in preview. There are some tooling we have to develop by ourselves. There are different APIs in every schema registry, and you need to be aware of all the differences in the libraries, in the serializers and the serializers. So there is some complexity there. But it's perfectly possible, and I really think it's the way to go in the near future. That's all from my side. Thank you very much for your time. It has been a huge pleasure. If you have questions now in the QA, I'm more than happy to answer them. And if we don't have too much time, just feel free to ping me in Twitter or to send me a direct message on that network. I'm always happy to speak about this topic. Bruno, there is any question out there, or was just too much information?
It was not too much information, and there's no questions for now. But I have some questions myself. So you mentioned that you were not using JSON to send messages through Kafka. You were using Apache Avro or gRPC. Can you give us an idea on the amount of space that you save with that? So in rough numbers, how much in percentage will you save on size on those messages?
Yeah, that's highly dependent on your data. How you are sending the JSON file. So if you are sending the JSON files compressed, as I explained before, you are already, eliminating a lot of duplicated information. So the savings are not so big. But in some cases, it may be like 2 times smaller using Avro than JSON. That's one of the things. The another one is, another benefit you have is for the producer and the consumer, the serialized Avro is much more efficient than the serialized JSON. So you can have savings of around 30% or even more of CPU in the producers and consumers and some memory too, just switching to Avro. I think that's also an important benefit. The third one is with Avro, you can do all this schema management and have all those rules to make sure people is not breaking compatibility with their consumers. And that's also quite good. It's something you can do also with JSON schema, but in a synchronous architecture, it's yet a bit, not experimental, but pretty new. And it's not so mature as it is with Avro or gRPC. So in many cases for, big corps or big tech, it makes a lot of sense to move to Avro or gRPC. Because the savings can be quite significant.
Anton, we have a question from João Rebelo. He's asking if is the cost saving worth less human readability of all this schema management complexity?
Yeah, well, not an easy answer. That depends a lot of what you're doing. If it's a startup, you really want to iterate fast, you really don't care too much because you don't have a high throughput yet, JSON is perfectly fine. If it's just a big corporation, you're spending a huge amount of money integrating your services and in cloud cost, then in that particular case, go with Avro. It's going to be a very important improvement. Most of the places where I have been working on, thinking in big corporations, all of them use Avro for this type of things. And I really think it's the way to go. Of course, JSON may be good for you, but you are going to pay more in CPU, in bandwidth, and in memory. And if we are speaking here about a big scale, it's significant money. And it's no hard to start to work with Avro. It's true, you cannot open the message, but you can deserialize it. So you can use the typical tools you have, and observability, Kafka tools, and so on to see what is happening. So it's not like something just super complicated to do. And I think the benefits really worth it.
Okay, I think it's a wrap. We have no more questions, and our time has passed. So thanks very much, Anton. It was a pleasure to have you here, and I really enjoyed the presentation. Thanks very much.
Thank you very much, Bruno. See you. Thank you.
Bye.
So Portugal for us represents being close to people with great talent, coming from top universities and with very, very good expertise. It also represents having a good quality of life, right? So having sun, waves, great food, and at the end of the day, it's the merging of these two components, great talent and great quality of life that can be achieved in Portugal. Is a tech company from Daimler Trucks and Buses. We are developing e-mobility and connectivity services for our vehicles. We own our services from product definition, product ownership, all the way to the development and operations of the services. The services that we are building improve the vehicle efficiency and operation costs for our customers, which are the vehicle owners around the world. Vehicle owners can be fleet managers, drivers, logistic operations, and so on. We work on a very international setting. Within our company alone, there are 11 different nationalities, and our business partners are in 3 different regions of the world, in the USA, Europe, and Japan. And being in Lisbon puts us in the center of these 3 regions, helping us to be always in permanent contact with our business partners. One of the main factors driving change into this world right now is sustainability. And in 2022, we do expect to be further developing and operating services that will bring more efficiency, safety, and predictability to our customers' business, thus contributing to a more sustainable world. So efficiency on optimizing, for instance, the amount of energy that is spent consumed by our vehicles, safety on supporting the drivers and fleet managers with data about the vehicle status and the surrounding environment, and predictability for fleet managers with services like charge management or calculating routes. Everything connected into a single ecosystem that can be reliably used by our customers. All this with an amazing tech stack in the cloud, using open source, always challenging the status quo to a more sustainable world. Our tech stack is pretty much based on the cloud and open source in general. So we are based on the Azure cloud system. We build our backend systems on top of the JVM using different languages depending on what we need. We use a lot of Java and Kotlin, but also Scala for big data processing. On the front end, of course, JavaScript, React, and these kind of technologies. And then we use NoSQL databases for big data storage as well. And we use Terraform and infrastructure as code in general to describe our infrastructure and make our deployments.
Mindera, it's first and foremost a tech company, but I would say it's not a very traditional company.
We don't have this pyramid of job descriptions versus one manager that manages another guy and yet so and so and so. To make a quote from the movie Fury, Mindera is to me the best job I ever had.
Hi everyone, welcome again to the Almedina track. The second session, for the second session we will have Antoine Krask and Ivan Sanch. They both come from Leiria, and they are going to talk us about the road to production-ready Kubernetes applications. Hi guys, very nice to have you here.
Hello.
How are you doing?
Yeah. Okay.
So let's see what production-ready Kubernetes applications are like.
Yeah, exactly. And maybe not only application. We'll talk not only about application, in fact, but yeah. Thank you, Bruno.
Okay.
Yeah. So welcome to everyone. Very happy to be there with Ivan for the Jnation. So what we want to share with you today, it's a concrete experience and what we can learn from our experience and what we could apply for other experiences and I would say other organizations that are trying to adopt Kubernetes and more globally changing application to the cloud native paradigm. So three keywords for today is how we approached the topic, what was our experience in the various facets, and we'll see there are various facets and not only a technological one, and what can we learn from this experience. So just a small disclaimer, and I think it's probably one key messages of any changes we want to achieve in organization is that it can start with a very good architectural vision and what we want to solve for the business, and it should start there. But at the end of the day, if we want to reach and implement changes, it's with people, individual, and teams we need to convince and change. So even if today we are sharing with Ivan and me, it's globally a work of a team and not only of some individuals. So just we will pass you some exhaustive bio. We had an approach of just a small hashtag way to describe what we like and what we are about. And I think we are both happy to be there to share and learn with the community globally. And we are all, at least with Ivan, I know we are passionate about engineering, cloud, Kubernetes, DevOps, and all this type of buzzword. We are probably with common interest. So I think this big picture is something we always need to keep in mind what we are trying to do. And a personal conviction I have is the power of capabilities for companies to be really supporting the business transformation and business innovation capability. So a big objective we did some talks in the past of Redoute transforming from a low to a high performer using the DevOps paradigm of culture, organization, process, and tools. And we had another challenges to reach, and we are still inside this transformation today of moving from a high to an elite performer. on these key metrics. And Kubernetes was one of the possibilities and one of the necessary technology and capabilities we have to create to sustain this type of performance for our organization. So basically, anything we want to do normally, and especially with companies, if someone wants to use their money, it's normally to solve a problem. So what was our problem, in fact, is we need to deliver new features for our customers, and we don't even know if they will like it or not. It's all part of the iteration and testing we need to do. So we start with this problem, and at some point, the developer have to develop something. But normally what was happening for us is that we had a lot of troubles and pain points from a developer perspective. So you have some examples here that are quite typical, but they are really a pain point and all slowing down our rhythm of innovation for the team. And we see that all those, I would say, all those phrases and sentences here are not producing value at the end of the day for companies. So our core problem was not necessarily to say we need infinite scaling with cloud and Kubernetes, etc. It was to accelerate the business, and Kubernetes was one of the pieces in the game to change that. And we had a big question to answer each time, and that I was personally very frustrating. So I put 1 million, but it can be maybe 1 billion question for some companies. We have some concrete cases where we just need to change a simple function for the business, but we last days and weeks due to all the organizational problem we have in the middle and technological one. And it's very important for us that we keep this in mind, because if we implement Kubernetes, we can make things quite more complex and in the end slower. And our objective at the end was to be able to ship simple changes, smaller, even more faster than what we are doing. And it was it's very key to keep that in mind through all the implementation. We can very quickly implement very nice and beautiful things, but be slower than initially. So be very counter at the initial objective. So what we share today in terms of Kubernetes and the cloud native application containers, etc., it's inserted into a global architectural and IT transformation we had to do. So we passed a lot of time to move from the monolith to a distributed, first microleaf, then SOA, and then a bit more or distributed microservices architecture, still powered on, I would say, IaaS and VMs infrastructure. Still, we are already using a bit of cloud, and we started to build a much more distributed application with fine-grained functions in a microservice paradigm. And at that time, we didn't, VMs was not supporting the necessary scalability and fast deployment we required. So why we went to Kubernetes, we passed a lot of time evaluating some solution, etc. But the key messages, I think, is we had to leverage Kubernetes for the functions that are there, because in fact the containers by itself does not provide all the benefits an orchestrator can provide. So I think the key one we can see here is the self-service part, self-healing capability, orchestration, and also the portability part for provisioning and deployment was something important for us to don't be locked in with a particular provider. So, and just to share in our context is nowadays we can be old school if we are not using a public cloud. What are you doing? You are very late. But when we started to look at Kubernetes in 2018, and at that time, for a majority of organizations, especially in Europe, that are normally with a bit of lag with US, we were all like, yeah, cloud, but how we will manage cost, and maybe it's very risky, and how we what will impact with our data, etc. So we were at that stage. And a second important point is that there was not already a big shift in the ecosystem towards, okay, it's Kubernetes, the de facto standard, etc. It was quite talked about, but there was still Docker Swarms and other competitors there. And then we started in parallel to have 2019 an emerging maturity in the cloud adoption, etc. And at that time, Kubernetes became de facto adopted, and we also made a choice there in 2019. and we continued this adoption through the way. And the last key message on this context, I think, so I put DevOps investment, but it can be a technological investment or continuous automation, etc. There is no one-shot change we can do in organization for technological. I think we can only invest over mid to long term to create real lasting capabilities. How we approached the Kubernetes adoption. So we followed, I would say, standard maturity approach. So we had the first step of exploration with a limited set of factors involved, a bit in the R&D mode in 2018. But still, we involved stakeholders from the starter, including a CIO, CTO, and other type of role in the company. And we had to answer a key question, starting with the basic: what is Kubernetes? What can it do for us, really? Which type of application can we ship inside? And to the contrary, which application we have makes no sense to try to deploy in Kubernetes. And we had a lot with lacking externalization of configuration and that type of stuff, for example. It was also the opportunity to judge and have a better vision of the effort to learn Kubernetes and everything that gravitate around Kubernetes. And we had to answer at the end, is it the right moment or not to do this type of investment and change? So once we did these phases, we decided to use Kubernetes. And there we moved to the second phase, which is a tactical one. And here we selected key one team, in fact, when we started, involving business, product management, and all conception team, etc. And we take a topic that was sufficiently valuable, but not too risky. So we didn't take a strategic project, and we implement it and show the value. And we had really here to show are we faster or not, what can it provide, etc. And then so we iterated then on specific tactical projects until we reached the implementation of a strategic one last year, with a much more larger scale of implementation.
Okay.
So, and I will let Yvan share a bit, start with the first things first, is before doing something, what is the end result we are aiming for? Yeah, so
Yeah, that's right.
Yeah.
The defining production ready. So what you are trying to achieve, for your goals is a better business applications, a happy developer experience, reliable operation, a better user experience in that case, acceleration of applications, self-service for developers guys, to deliver that guys one application you want to deploy inside Kubernetes, operation with more security and metrics, so that you are your archives. Okay, next, please. Okay, for who? The first thing you define some goals, and for development team, infrastructure teams, and monitor teams, because the first thing you deliver your Kubernetes to develop the team, and you need to get the information input from the development team to improve your service. Okay, so in that case, you see the technical level of each guys you use the Kubernetes, and try to figure out some help that guys use the Kubernetes. The first thing, for developed guys, you create some templates, in that case, the Helm charts, to help that guy to deploy applications inside the Kubernetes. Some continuous integration, continuous delivery process you do deploy as well, and some applications to give more understandable inform your Kubernetes clusters. Okay, and for the operation, the monitor team, you create a step-by-step help maintainability process to give that guys some introduction to Kubernetes, how you can do the things at Kubernetes, and how you can, for example, do some recovery actions or fix some issues, So you create some step-by-step documentation, a basic step-by-step documentation to that guys. And for the infrastructure guys, you create and define some modules and the standards we use in Terraform, to help the deploy the Kubernetes inside the cloud provider. In that case, you are using Google. and to help the infrastructure guys to maintain and give a more security and maintain the stability of your projects. Okay, next slide, please. What's your requirement? So when you decide to accelerate your business transformation with Kubernetes, you question yourself if how you do this, you know. And in that case, you need to understand the business roadmap and develop roadmap, you know. And that after that, you can create some business process for SRE and DevOps guys, you know. And you can, for example, design a monitor process because you already have a monitor infrastructure implemented inside the La Redoute, you know. And for deploying cloud objects, CICD integration, and the Kubernetes support application. When I talk about the Kubernetes support application, I talk about these applications. You help the business application to do the job, okay? Like Prometheus, Monitor, Vault, Elasticsearch, or external of the Kubernetes, for example, use the Kafka or some databases you are using outside the Kubernetes. Integration with ITSM service to do the things when you have some issues or requests inside the Kubernetes, you know. So what you do that things, you know, for what, and what we required for that. So that's the process you use to define what you need to configure your Kubernetes to be a production ready. Next slide, please. Okay. Key design consideration for developer experience. For application, for platform. In that case, the most be able to ship fast and develop productions is controlled environment, the application development. And operation is developed responsibility, you know, and your goals reach 100% self-service integration with high level and SLAs and security. You know, that's your goals, that's your goal of developed experience and what you need to do in your environment and how you do that. You know, for application, for example, focus on backend containerized Java applications, the core of the Kafka, you know, most externalized configuration dependence. And for the platform, in that case, we start a simple limited complex work in the progress, implement what's required step by step, balance infrastructure and application concept. That is what you are doing for the platform and for the monitor, operation, and 24/7 support, recovery action, team backup. Okay. Next slide.
Yeah. Okay.
Okay. Plan the work.
Yeah. So Yvon shared about reaching the state. I think the main messages from the last slide is that we had to define from the start what was the end result and a series of principles, the one we saw just before, that are there to, I would say, align the common objective of the team and make clear that we always need a balance between, okay, developer, operation, quality, testing, etc. And it was very key to have this balance and focus from the start. You saw that we focused first on a back office application, which is already a lot of the perimeter. And it was key to have this step-by-step approach, minimizing the risk and focusing on producing the value of accelerating the developer experience. And in fact, this is what then we put in place in organizing the work in a transversal way. So in terms of order, we had to define the dependencies between the various parts. So first the foundation, then the Kubernetes, and then the support tabs, and we only address monitoring and security just after, and documentation, even if it was done along the way, it was then very complemented once we have covered the various parts, and then to go in operation. And then, yes, you can take the transition, Yvon.
Yes, and the requirements, how you do this, how you start your process to do that. You have a kickoff meeting with the engineers and architects from all the teams, you know. In that case, you give the all the teams the chance to talk, you know, and to a more visible architecture to that guys, you know. You define a core architecture, you know, to start the deployment of Kubernetes, you know, implementation of the core architecture. You use continuous integration to continuous delivery. In that case, in the first thing, you use the cloud objects to create cloud objects with Terraform. With Kubernetes feature, you use the Helm chart to install the supported application, and continue after that. After you create the core base environment, you give the developer team access to the developed environment, to start to do the things. After that, in the parallel tasks, we continue improve your environment. So you start tasks to the monitor, to backup, disaster recovery, to integration with ITSM and external integration if you need, or for your own premise environment, and create some operators to help us to go your production ready. And after that, after you create that improvement, you integrate your environment with your ITSM system, and now you have one process together with the infrastructure team, and now after you integrate with the ITSM, you jump to the production environment change, start the request from the production environment. Next slide, please. Okay, what's your environment architecture? Today you have 7 Kubernetes clusters, 5 Kubernetes clusters for non-production environment, 2 Kubernetes clusters for production environment and in high availability state, 1 cluster for the federation stuffs like Prometheus, Thanos, Vault, Consul, Elasticsearch as well, in the future Visual, Argo CD, and 1 cluster for continuous integration. To do that, the process, all steps for the continuous integration, we create a specific cluster to do that job, with all applications you need in the continuous integration steps. Okay, so your environment have 7 clusters, in the production clusters, we have all clusters in high availability process, okay? And for non-production clusters, in the stage in which you have clusters more equal with the productions, and for the sandbox, you have a cluster for just for the test, The next slide, please. And what application, what about your supported application architecture? How your clusters in the kickoff meeting, you define what you monitor, how you monitor this, how you operation your clusters, how you do the security stuffs inside the Kubernetes, how you monitor and deliver something inside the Kubernetes. So for all your clusters, you define some default applications. In that case, you see applications in the security stuffs, monitor, delivery, tools in operation, service discovery. In that case, you are using, for example, Consul, some Kubernetes operators like the replicator or workload restarted. For example, when you change some secret or config map in your environment, you create some Kubernetes applicator to restart the pod and read the service, the secret again, or config map, you are using OpenFast to trigger some functions to automatize your automation environment, with specific tasks. And Litmus, we are using for cloud engineering to have a good integration and a good customization if you want, And for backup, you are using Velero, so we are using that support application for all your environments, And is the default in the pipeline. You have one pipeline, you trigger all that supported application. You can trigger individually each application if you want, but when you start, for example, Kubernetes clusters, you trigger one pipeline. In that pipeline, you trigger all supported application you want to give a production-ready Kubernetes cluster. Next slide, please. The organized to work. Now, Antonio talk more about how you do the things and how you do the management of all that tasks. Okay, Antoine, go ahead, please.
Yeah. So yes, in terms of organization, so from the start, it was a transversal initiative. So we worked with the various stakeholders. I would say from more. I would say not directors, but head of and external managers, but up to the production people. So what we shared with them and we co-constructed the plan that Ivan was sharing. And we started an incremental and iterative approach collaboratively between, so we have some teams that were really the developer of the end application, some people in between, more platform engineering, and then really the operation team that should host the various application. And from the start, we work in a small sprint of 2 weeks, and with defining a monthly objective that then we started to expand to every 2 months objective. But at the start, it was really, I would say, a very granular approach we had. We started from zero, and we had a big dynamic to set. And we also implemented some key rituals like the standard one, a daily kickoff meeting, a retrospective, a planning, to really align all the resources and validate who will do what at which time, at which level of effort. Yeah.
Yes.
Key point, I think, to say that it was really transversal in the various roles we had. So it goes from the software engineers to security also, and we had involvement of key people like security, infrastructure, and monitoring is very important to secure from the start this type of requirements, and also get their help when we need to do some specific action, like we did security hardening, etc. Before going live, to also reinforce the trust in the platform with the various stakeholders. And we have also to convince the people that at the end of the day own the application and should defend them and align the choice of Kubernetes. So it's mainly the engineering team lead and tech lead that we should not forget in the journey, because they all have a power in this adoption. And if we just have a platform and no one believing in it or not having trust, we just a failure for the organization. So during our journey, we had really to iterate in maturity. So at first time, we focused heavily on the systematic process, on the rituals, but we had low visibility, a lack of estimation. It was really hard to know what will deliver when, etc. Definition of done was okay, a draft, but we had to iterate a lot after to identify the different definition of done for so different type of task we had. And we had really frustration in the start, so a lot of late tasks, and because we were really iterating on the process and finding an organization that work. Then we iterated step by step, but still maintaining a 2 weeks iteration. It allowed us to have an emerging visibility on what are we able to achieve right now, and so in the coming sprint. We started to have a much more robust templates per type of task, and to achieve more on-time delivery. And what we are doing right now to align this better is to improve even more the estimate with the type of poker planning and cards estimation. We are working on aligning even more the epics we are working through to the organization to really be crystal clear and aligning the value, and what we are doing makes sense on the overall picture, and it's still solving concrete business problem, developer experience, etc. So always keep the mind on who we are working for and for which value and which problems. So in terms of working the plan, I shared a bit before the approach on exploration, tactical and strategic. So our first step was always a bit what we call a cold shower. Is we are happy because we reach results, but at the same time we discover a lot of things we still have to do. So at that time we are happy to have some application able to deliver until production with Kubernetes, because Kubernetes is all what is around Kubernetes: integration, externalization, Vault, service, logs, etc. So it was a hard journey to get there, full of surprise and frustration and some nights. We got a lot of surprise with different behavior, even with a set of testing we had with the production traffic. So we had a lot of alerts, but at the same time, a lot recovered by themselves due to the Kubernetes self-healing capabilities. So we had a lot of noise with operation team, etc. So we had to have a continuous improvement process from the start and avoid unnecessary noise there. We started to have some instability in some environment, but then you need to understand why. And then you discover you are lacking logs, or then you say, oh, I need to do command line kubectl to understand what is working. But you say, okay, if I need to debug with command line, there is most probably an issue in my observability. So you start to say, okay, I'm missing things here in maturity, in understanding what is happening. We have some points we forget. Ivan shared with you the architecture with the dev environment. On the start, it was on the scheme, but we didn't focus extensively on it. But we saw it was really a missing piece for people to experiment and for us to also test some other version out of the production line with the other environment up to production. And then you start to have other concrete topics, is that you had your team, your core teams that did the exploration phase and the tactical one. But then you start to communicate to the company what you have done and show result in a tech talk or stuff like that. Or you have a new guy that come in the team and ask you, what is Kubernetes? And so I think I forget probably about some part on the onboarding, training, etc. More broadly in the organization to say, okay, if I want to scale, I really need to address this with a real approach and investment. So I would say our first deployment was a bit with this image. Okay, but so this is why we did it on a limited scope for production. So it's a bit caricaturing this picture because we managed to put in production an application that was working. And in the first slide we shared, it was the first type of application with a microservice type decoupled with Kafka. And we managed to produce real value for the customer in streamlining some specific flow of information that previously was blocked with the batch process and stuff like that. So we are still, even if this image was more the back office part of IT, it still produced value and it was working on a 24/7 fashion. The next iteration, we fixed the first problem we have, alert, noise reduction, etc. We started to implement some standardization for all the application because our idea was not to do 2 or 5 applications, it was to migrate and adopt the platform for all the engineering perimeter. So we're starting to address repeatability of the processes. So we started by dashboard because it's the key to understand and see what is happening. So there was dashboard both for platform teams to know what are the pods, what is happening, etc. But also standard dashboard for application to know the state, the status, and the KPI. We also started to put in place the mechanism to ensure transversal communication, so to have a support and to then have also feedback on what's working, what's clear, what's not clear when using the platform. We set up the famous development cluster. We had also to start to address a point because we started to have much more workload of application and a lot of pods with autoscale, etc. And we had so to start to address capacity planning. So not only say we need to cut cost, but also to say, do I have a real scaling capability? Does the scale down is working properly? Which metric should I use to handle the scaling, etc. So we had a lot of questions there to address and iterate. And we had to address the concrete part of onboarding and scaling the engineering part. So we set up a real training plan with external partners training on Kubernetes. We also did in-company session and training. We allocate time for people on a Friday afternoon, etc., to practice on the tool, on the Kubernetes platform, etc. We allocated a buddy to each new developer to be able to collaborate there. And we started to restructure our development wiki to have a step-by-step recipe for any developers that want to develop with Kubernetes, all the steps involved, each time trying to automate as much as possible, but at least to have a guide for step-by-step for developers to have, again, all the way of repeatability is a key to scale, to have we need strong foundation, in fact. And in terms of trust, and both for us and for the external teams, we did also a security hardening of the Kubernetes platform also, and we had a lot of stuff to be corrected there. But it was also a way to reinforce trust for people, and it's an important part to don't underestimate. What we have work after, and we have still a bit of that working today, is really on application governance, because in fact, we managed to have much more stronger foundation, but then the other part you need to structure is the design and to have repeatable design of application. So we invested there, and also on the bootstrap acceleration of the project, so remove all the boilerplate code generation, etc. As we had much more application that were converging we invested also on a much more distributed tracing capability, so of standard of log, dashboarding, alerting, etc. So this is key to understand what is happening between the various applications, because we were really scaling the number of pods. We also started to support much more better, I would say, visibility, observability of application. And this pass also through much more self-service on the monitoring and alerting part. So our goal and what we implemented is all infrastructure monitoring and dashboarding alerting should be standard and available by default. So if you have some pods that are unavailable, etc., you should have automated alert. No developer should specify new alert for that. And that way, they can focus on what is of more added value. So when we focus a lot on the business metrics and business dashboard for all the application to reinforce the link with business and also to improve the reliability of the application. We are expanding Kubernetes also of other application perimeters than the back office we started with. We have structured the capacity planning, very important with the growth of the perimeter to keep management of what we are doing. And we have more moved now to a repeatable process of onboarding and training of the developer. So hopefully in the coming months, all developers will know natively Kubernetes, I would say. But right now, in the ecosystem, we have a lot of people that know, that have been curious about, but people that really grasp all the bits up to the length chart, the deployment, etc. It's quite complicated. So we are seeing also a level of abstraction that are upcoming in the ecosystem to simplify this onboarding. But for us, it's still require a bit of knowledge. And we also linked with the capacity planning, support the FinOps processes.
Yes.
So here, for example, some concrete deliverables and topic we have addressed. So on the left, it was a wiki we have at some point on all the good practices we have and where are all the standards. In addition to that, there is really a step-by-step recipe for deploying an application. We had also on the design part implemented the concept of whitelist and blacklist. So to say, okay, if the application is following all the whitelist part, you don't have any justification to say, etc. It's good normally, and we enrich it regularly with an internal community of practice. And to the contrary, there is a blacklist. So, and if you want to use something in the blacklist, you have really to explain why, and we discuss. And sometimes we can find a better solution just by sharing and identifying I would say some counterintuitive design. And this is a good part to scale also, because like that you can scale everything that is in the whitelist can scale and go directly to production. And all the rest requires a sanity check, I would say, in terms of design before proceeding with implementation. On the organization, I will let Yvan share briefly what was the core changes on the various persona we had around Kubernetes.
Yes, that's right. So what developers need to learn? The first thing when you start developing the Kubernetes environment, you need to understand why the Kubernetes and how you can use the Kubernetes to do the things, you know. So it's more specific to understand. In our case, for example, by default, you enable the pod security policy will be deployed in the newer versions, but you are always changed to the open policy agent, okay? Using network policy, some objects, so the developer guy needed to understand how the objects works inside the Kubernetes, you know, and for example, how you can create a Docker file or how the containerization works, you know. So for development team to improve your day-by-day Kubernetes stuffs, you know, you need to learn Kubernetes, to learn container. You need to understand how you can configure your application or how you develop your application for the containerization stuffs, you know, how you debug the things, so don't bother the DevOps team guys, you know, you need to understand how you debug and do troubleshoot inside the Kubernetes. So that is your challenge. And the first things when we start that project, your challenge is how you can, for example, give it to the developer team a good experience, you know. So a good experience coming from the developer team and coming from the DevOps team, okay? So that's why we want to develop need to understand, to start to work in the Kubernetes environment. So, and what DevOps guys need to learn to start to work with Kubernetes and the cloud, you know, but more specifically Kubernetes, the DevOps guy need to understand how Kubernetes work in high availability, how you can move the steps from one object to another object, so one cluster to another cluster, for example, develop the cluster to TA cluster or staging cluster to production cluster, how you code the things, how you can, for example, do the infrastructure as a code, or how, for example, the Kubernetes operator works, you know, because today, if you don't understand how the operator works, you know, you always use the simple applications, you know, so you need to understand the operator, administer Kubernetes, so how you can, for example, configure the resources in the cloud, how you improve the resource, or enable or disable some features, you know, how you test and deprecate the things. So to be a good Kubernetes guys, you know, you need to learn, and I think in all the teams you have a senior and the junior guys. So for me, the senior needs to share your knowledge with the junior guys and give the time to that guys study and learn. Okay, so actually, I think the DevOps guy needs to be. And this is transversal stuff. So when you talk about the Kubernetes and all the applications in the container orchestration, when you talk about transversal, you talk more about the business and what the business expects in improvement and lead timing, availability, scalability, posts, application components. You know, this is transversal talk, you know, because the DevOps guys need to talk with the DevOps guys, you know, to talk more about how you can architect it and do the things inside the Kubernetes or in the future, you know, develop some understands the big picture, learn the practical skills, and testers can be more close with DevOps guys, you know, to understand how you can do more tests or cause engineer tests, for example, inside the Kubernetes, you know, and this is a transversal way. So the good things to be a production ready Kubernetes is you talk with the other teams, you know, that's the goal. You talk another teams, work together with another teams, you know, and do the things together. Okay, so this is you need to put in your mind when you talk about the Kubernetes and the 12 factor methodology, for example, you talk about the inter-teams communication.
Yeah. And to wrap up a bit, what did we achieve and some type of learnings for us during this journey? So I think a key messages we could have put a Kubernetes logo is that Kubernetes is only, I think, two messages. It's first, it's a platform we are building, so it must aim to specific persona and solve specific problem. And in our case, the business and developers and the infrastructure team are key stakeholders. And when defining the scope of implementing Kubernetes, I would say the scope is very large in what we should address from organizational topic, culture, skills and training, how to learn, etc. On top of a series of broad topics, non-directly linked to engineering, development and the code only, security, quality assurance, observability. And it's a huge topic when implementing this type of platform. I would say that it's very important to have this in mind when starting this type of initiative, because it's quite structuring investment over time. So I say keeping a big picture around Kubernetes is key. Here it's a bit to share what we have in terms of standard dashboard we were talking about to industrialize what we did in terms. So we invested so standard, I would say, technical alerting, etc. But we also invested much more broadly with business metrics and alerting. And this is possible if we have a robust foundation and replicable standard. So this is what we achieved there with all the dashboard, also visible to all the team with automated alerting. And we implemented some key practices such as the 4 golden signals of the SRE of Google, that type of stuff, very useful to have quickly a good overview of the health of services. And at the end of the day, did we achieve to accelerate and what we still have to do? And I think a key learning is that yes, but Kubernetes helped us to accelerate around in terms of, I would say, the capability we saw in the first part. But we still have a lot of topics to treat that are not directly linked to Kubernetes. So to be able to have first much more stability in our deploy, and also be able to deploy out of a freeze period, because we see that over here we have a lack of opportunities we are missing. So this is a bit the global capability dashboard we are following to measure if really our organization globally is able to deliver better. And there is a lot of topic around communication, organization, etc., in addition to a technical topic and Kubernetes. But I think it's very important to maintain this key picture in mind to verify if our implementation is bringing value at the end of the day to our capability. We have also, on top of the number of deployment, a focus on the cycle time of developer. And this is for us is a key dashboard we are always following on the drill down to measure also the ratio of successful and successful builds and the ratio of funnel, a bit like an e-commerce funnel, how many changes done are go up to production. And then the last important part is what is the cycle time on this. And everything we do should be at the service of improving the cycle time so that people can make sure they are producing value. If not, they will tend to focus on technical things here and trying to improve technical matter. So right now we are able in 3 minutes to go up to production on the streamlined processes. But again, the key is not to do it once, is to do it in very fast feedback loop in different applications. So the key takeaways we can share today, and I think for me it's something to have always in mind. It's not a one-shot project. Is have always the end result and objective in mind we want to do for the business and the users of the platform we are building. It's key. We can quickly get lost in the local KPI technical stuff and trying to do something more and just it will be better like that. But at the end of the day, you just delay using some technologies. So it's quite key to focus on using end-to-end quickly. Adopting Kubernetes, we saw in the map, is providing a platform. So this is where it's important to have the vision of persona, services, self-service. And this is where after we need to have an organizational and change to address. Key part, I think, is, I would say it's a bit buzzword and agile, etc. But start small is very key. And start small until going to goes to production in the start small quickly to validate your hypothesis. And the last point is more to remain, I would say, with hope. Can be useful, but you need to have a stakeholder with you, support, key influencer, and leaders to drive this until completion, because you will have step backs, and we had setback, frustration, difficulties, and we never, I would say, let it go during the 2 years we needed to go to a really strong strategic deployment in production of Kubernetes. So I hope this sharing was interesting to you, and we are up to questions right now. If there are some.
Thanks very much, Ivan and Antoine. We have no questions yet. I hope people will type them, but I have some of my from myself.
Okay.
So I saw that you were using Prometheus to gather metrics and so on. Are you using some kind of framework for Java to collect that, like micrometer? Or how are you collecting those metrics?
Yeah, so we are using standard. Yeah, we evaluated micrometer, but we are always relying on standard of metrics with standard injectors. And then we use also, this is not on the collection part, but then we rely on Thanos for the long time archiving, where we are trying to do some ML to know if there are anomalies and stuff like that, but it's very preliminary. But yes, for the back office engineering parameter, yes, it's based on the open standard. Now we have a bit of challenge because we are opening Kubernetes to other applications, so guys with React and .NET and stuff like that. So we have here a challenge is to have, I would say, this is where standard, in addition to, I would say, the technical connector, in our case in Java code, is very important to be able to have this structure logging transversally. And we have real challenges then is with non-in-house application, because we have some ERPs and external vendors, and when you ask, is there a logging and metrics connector, they tell you, what? No. So then we are a bit blind, if we want the end-to-end perspective on some areas of the business, but it's challenges. So right now in acquisition of vendor, we always look for standard logging and metrics connectors, but sometimes it's not available yet.
And are you using open tracing or open telemetry or planning to do so?
Yeah, we use that, because we are in fact we started without distributed tracing, but we said okay, we'll use standard of open tracing, open API, etc., to at least have the standard from the start, and to then be able, when we add some specific layer afterwards, at least the foundation are there available and we're followed from the start, and we don't have like 100 applications to change, etc., and ask every developer to change everything.
So one last question. So which tool do you use for your deployment pipeline? So to deploy on Kubernetes directly?
So you want to answer, Yvan? We have GitLab, but we have other Helm, etc. involved. But Yvan, I'll let you.
Yes. Today use GitLab CI to do the continuous delivery, but you already have an open project to move this to Argo CD, You do some research about how the best developed continuous developed tools, and for us, is Argo CD is the best for today. So we will start that project, already start in the progress stage, to separate and split the continuous integration with continuous delivery. And today use the some tools, GitLab CI, but in the future I start to use the Argo CD.
Okay. So what our time is up. So Ivan and Antoine, thanks very much for being here at Jnation. I hope we can have you in future editions as well. And thanks very much, and see you soon.
Thanks a lot for the invitation. Yeah.
Thank you for the invitation.
Bye to everyone.
Bye, Bruno. Thank
Bye.
you. Have a good one.
When I started out at Iconium, I was pretty experienced in HTML and CSS, but I would call myself more a templater than a front-end engineer. I talked to my boss and told him that I would like to go a little more in the direction of scripting. I was supported so much by the guys here. They gave me less workload so I can learn on the job. Well, I started out as a templater and now I'm able to write in Angular and in Vue.js, React, everything. And now I can call myself a scripter.
A Jnation é uma empresa focada em todo o processo de transformação digital, portanto somos parte do grupo Volkswagen, apesar de termos também um vasto leque de clientes que trabalham, onde trabalhamos fora do grupo e mercado automóvel, e portanto é uma empresa que trabalha em todo o processo de transformação digital em várias áreas, em Innovation and Strategy, em e-commerce, em soluções tecnológicas, para principalmente construir digital units. Portanto, o nosso main focus, portanto, o nosso valor principal é criar digital champions. Portanto, o ano 2020 foi claramente um ano muito desafiante para nós, apesar de que a Jnation cresceu mais do que nunca. Nós, obviamente, com a situação da pandemia, tivemos a principal preocupação em dar surveys aos nossos colaboradores, portanto, providenciámos um survey aos nossos colaboradores para perceber como é que nós iríamos transformar para um novo normal. E com isto conseguimos implementar o que nós chamamos o Hybrid Workplace, onde estamos focados em garantir a flexibilidade aos nossos colaboradores para conseguirem estar a trabalhar remotamente e também poderem vir ao escritório para socializar, para ter eventos da empresa e para as pessoas que de facto preferem ter este modelo mais flexível. Portanto, foi um ano desafiante a nível de alterações, onde esta pandemia claramente foi uma das minhas preocupações, mas a Jnation, como um grande foco nas pessoas, teve esta principal preocupação em garantir que há um modelo implementado à nossa realidade. Portanto, tivemos que nos adaptar cross-location, portanto, somos uma empresa multinacional onde tivemos que respeitar a legislação da Covid-19 e estamos mais fortes que nunca e este novo modelo claramente veio para ficar. Portanto, Innovation, Mobility, Future. Este podcast veio claramente para conseguir criar aqui uma comunidade e uma rede à volta da mobilidade. O mercado automóvel e o mercado da mobilidade está a transformar-se muito rapidamente e a Jnation, para conseguir alargar a sua rede e criar uma comunidade e um fórum de discussão, lançou este podcast onde claramente queremos garantir que com os vários conhecimentos nesta rede da mobilidade podemos claramente inovar inovar o futuro da mobilidade. Portanto, este primeiro trimestre foi claramente um trimestre onde nós estivemos focados na estratégia da Jnation para 2025. Esta estratégia está claramente assente nos valores principais da Jnation: impacto, courage, mindfulness e collaboration. Esta estratégia teve assente vários pilares, portanto, focada em pessoas, na organização e nos nossos clientes. Nas pessoas, nós claramente estamos muito fortes no recrutamento, estamos a crescer a olhos vistos com muito mais projetos e um leque vasto de clientes e, portanto, queremos claramente reforçar o conhecimento através dos nossos centros de competência que estamos a alavancar durante este ano e ao longo dos próximos anos, portanto 2022 não será uma exceção, e reforçar as nossas parcerias tecnológicas. A nossa rede de parceiros também é um pilar estratégico nesta até 2025 e com isto tudo, obviamente, alavancar toda a nossa estrutura organizacional e, consecutivamente, o nosso portfólio de clientes que será cada vez mais vasto, tanto dentro do grupo Volkswagen como para fora do grupo Volkswagen.
we share the same language?
Why not the same voice?
If we share the same values?
Why not the same goals?
If we share the same commitment?
Why not the same reputation?
If we share the same knowledge, why not the same expertise?
If we share the same technology?
Why not the same innovation?
If we share the same passion?
Why not the same experience?
If we share the same world, why not the same people?
I2S is now part of the Jnation group and becomes Clever, to bring you a complete and global solution in life and non-life software for insurance companies. Clever, Jnation group.
We share.
We share the best.
Hi everyone, so welcome to the third session here at the Almedina track. So right now we are going to have Nathaniel Shuta, is that
you
right?
got it, well done.
Okay. Okay, Nate, so you are going to present responsible microservices. That's going to be, well, interesting to say the least, because everyone is doing microservices, but most of people think microservices are small domain services. So, and sometimes they go for a surprise. So let's see how it goes.
That sounds
Go
good.
for it, Nate.
Awesome, thank you, I appreciate that, and thanks to all of you for joining us here today. Good afternoon, I believe, if I can do math, which is always a little questionable for me, even on the best of terms here. But so I before I jump in, I'll point out I've got a couple of these little report things that I've written over the last couple of years. One more on how I think about architecture. This is kind of where I've lived for the last decade plus. But the one that's probably most relevant to you if you're listening to me here today is this one. So the material, as I was saying in the pre-show, the material here is something that grew out of work with some clients, and I turned that into a blog series, which, well, I thought it was just going to be a blog. And then the person who was kind of my editor on that's like, hey, this is really good. Can we do more? And I'm like, well, I guess. And then I turned that into a presentation. Then I kind of sort of morphed that into this report because I figure it's a lot easier just to get a PDF than it is to try to go, searching through all these different web links. So if you're interested in what I'm talking about today and you missed something I said, or you want to have a repeat of it, you want a prose variant of it, you can just go snag this from us and enjoy. Now, I've lived in this cloud space now for a lot of years, and what you realize pretty quickly is there's a lot of options here. And unfortunately, for better or worse, an awful lot of developers have internalized this, I would say, false notion that, well, the cloud must mean microservices, that if I'm on the cloud, I have to be in microservices. And so we spend a lot of time talking about domain-driven design. People have finally dusted off their copies of Eric's book. It's somewhere on the shelf behind me. We're looking for bounded contexts, and we're trying to form ubiquitous languages, and we're getting everybody together on a two-pizza team. But I feel like we've missed a step. And so, to paraphrase my favorite fictional chaos mathematician, your developers were so preoccupied with whether they could, they didn't stop to think if they should. And undoubtedly, that has led to some pain. If you look at the call structure of a lot of these microservice architectures, it looks a little something like this. And there's a reason why we call this the Death Star architecture. I think this is why Death Stars kept blowing up, right? And so we go down this path, we think it's going to solve all our problems, and then we've run into this big ball of pain, and we're like, oops, maybe this wasn't the best idea. Maybe there's another way. Maybe there's a better way. And it's not that microservices are inherently good or bad. They just are. It's a series of trade-offs. I mean, that's what architecture is in a nutshell, is these trade-offs between this option and that option. I taught a graduate school class last year on architecture, and what I tried to sort of repeat to them again and again and again is it depends. That all of these decisions that we make are by definition hard. If they were easy, they would have already been made. And so it's important to understand that there are good reasons to adopt microservices, But we as technologists have to understand what those trade-offs are and that there are no free lunches here. So if we go down this path, we gain quite a number of things, and we'll talk about several of them here today. But I've also added complexity to the equation. And that might be acceptable if I actually benefit from that. If I'm getting something out of that equation, then that's cool. But software is hard enough. I don't need to make it harder just because. And so one of the soapboxes that I've been on for the last couple of years is trying to get developers to think in terms of when should we use microservices, as opposed to just assuming, well, obviously everything will be a microservice all the time. Now, I refer to this as responsible microservices. I think when it first went up as a blog, it was called Should That Be a Microservice? It's always funny to see how people decide to change your headlines as you write these things. But let's start with a level set of what do we even mean by microservices? There's a lot of I would say, sort of this uncertainty and doubt and FUD that gets thrown around what this means. And I would say first and foremost, a microservice is really just a reaction to the monolith and the pain that the monolith typically brings to the party, as well as these sort of heavyweight SOA things that we've done for a lot of years. And it's also just a reaction to the fact that the cloud lets us do some really interesting things that we couldn't do before. I had a friend on my Twitch stream on Monday, and one of the things I mentioned there is if you would have had the idea for microservices 15 or 20 years ago, and you would have gone to your infrastructure people and said, listen, I want to spin up, I don't know, let's just say 1,000 instances of the app server in every region, their heads would have exploded and they would have said, you're crazy. There's no way we can do that. Now, obviously your app server vendor would have been pretty happy about that because that would have been a lot of extra licenses. The reality is monoliths aren't a lot of fun typically. And then that's not a viable sort of requirement of the monolith. It just tends to be how we structure these things. I've been on a lot of monoliths. Productivity isn't always excellent. It can be fairly plodding along. It's hard to get your head wrapped around these massive code bases. When you join these teams, it can take you weeks, months, years, in some cases, to truly get up to speed. And I've pondered quite a bit about why have we done these traditional quarterly releases. And I think a lot of it boils down to, for most of our software career, changing just one small thing. I still want to deploy everything anyway. And so I might as well wait till I have a big batch of things to deploy together, because if I'm going to go through the pain of deploying, I might as well have enough there to justify doing that. Scaling meant I had to scale the entire application. I couldn't just scale up the part that needed it, which in many instances gives us this single-digit server utilization, which is not awesome. These systems can be really hard to evolve, and we're all familiar with the second law of thermodynamics. This came up at some point in your educational career, otherwise known as a teenager's bedroom. I am the proud owner of a teenager. He is sleeping, I'm sure, very pleasantly below me. He's actually one room over. And at some point during this pandemic, I was taking something out of his room or putting something in his room, and I had a really hard time figuring out where the floor was. And so I suggested to my wife that perhaps we should ask the young lad to clean up his room. And she looked at me and said, "What hill do you want to die on today?" And I recognized not that one. Now, as much as I wish my son's room was more organized, he's just adhering to the second law of thermodynamics. The universe wants to be disordered. Now, I'd love to say that software is somehow immune from these forces, but it's not. We've all started on a new project and uttered some variant of, this time we're going to do it right, only to get 6 months in and the streams have crossed and the package boundaries aren't clean anymore and somebody did something goofy, and now we're just tearing out our hair going, why did we do this to ourselves? Modularity tends to break down over time. It takes longer and longer and longer to add new functionality, and that makes our customers kind of grumpy. And I think it's this whole combination of things that has ultimately given birth to this new architectural style. And I say new because none of these things are really new. We tend to just sort of take something, change the name slightly, dust it off a little bit, give it a slightly different slant, and here you go. And thus was born the microservice. Now, it's important to understand there's no one definition here. There's lots of arguments around that. It really very much is in the eye of the beholder. You'll know it when you see it. And by the way, the important definition is the one that exists within your organization, so that when you are talking amongst your teammates and you say microservice and your teammates says microservice, you're on the same page. Now I know we love to argue in this industry, especially about terms. And this is one of my all-time favorite tweets. This is my old boss, Andrew Clay Schaefer, who wants to argue about the definition of made up words with me? He's absolutely right. We spent a lot of time doing that. Now, I'm rather partial to anything that reminds us these things are supposed to be small. So anything that can be rewritten in 2 weeks or less seems to fit that bucket fairly well. If I make a mistake, I lost an iteration, I can recover from one lost iteration. Now, that does beg a fascinating question. How big should a microservice be? And this is a fantastic video that Sam put out last year. It's short, it's 8 minutes, well worth your time. And Sam makes a fascinating argument. He says, over time, it will be smaller because you will gain the muscle memory, you will get the tooling in place that it is easier to do, and thus you will make them smaller and smaller and smaller. You know, there's also that argument that says, oh, they should be as small as possible and no smaller, you know, which is not always the most easy to understand or most obvious way of doing this. So well worth 8 minutes of your time to watch Sam's video. Some people talk about this in terms of two pizza teams. It's anything that can be rewritten or can be written by a two pizza team. And that's fine. I don't have any issues with the two pizza team concept. However, it doesn't give us any guidance around how many services can that two pizza team handle? Now, this was a real question that a director came to me with my previous organization, said, Nate, we're doing all this microservice stuff, we're forming all these two pizza teams, but how many services can they handle? And I told him, well, it depends. And he didn't like that answer. But of course, it does depend. If these services are very volatile, oh, okay, well, this team can probably only handle a very small number of them, 3, 4, 5. If these services are very stable, very refined, they're not changing a lot, that exact same group of developers might be able to handle 10 or 15 or 20. I think it's more important to look at these in terms of characteristics. These are a suite of small, focused services. They do one thing, they do it well. It's that Linux, Unix concept of let's take simple tools, pipe them together to get complicated results. They should be independently deployable. This gets violated surprisingly often. A friend of mine was telling me that he was in a situation where they had this set of services. There were 7 of them. If you modified any of the 7, you had to deploy all 7 of them in the proper order. Otherwise, the databases wouldn't initialize properly. Oops. They can be independently scalable. They can evolve at different rates. The thing that gets developers really excited is, oh, I can choose the right tech for the job, which unfortunately we tend to morph into, thank goodness I can finally justify using insert esoteric technology here. These are built around business capabilities, and they are a perfect encapsulation of what I refer to as the 0th law of computer science, which is high cohesion, low coupling. And if you think about so many of the things we're trying to do in software, so many of the things that we have inside of the Gang of 4 patterns or other patterns sort of material, it's really about high cohesion, low coupling, often just at different levels of abstraction. And so I would say microservices are high cohesion, low coupling applied to services. At the end of the day, friends, it's a style, it's an approach, it's a pattern. It is not Mjolnir. It will not solve every problem you've ever had. I'm sorry. And I do realize that's the way many of us as developers have phrased it, that, oh, finally, this will solve our issue. This is the silver bullet I've been searching for. I'm going to prove Brooks wrong, as I've heard some people say to me before. The end of the day, they're just tools. And we have to look at them as tools, and we have to know when to use which tool. Now, I'm a software person at heart. I'm not very good at hardware in any sense of the matter. I'm not a particularly handy individual around the house. And so a couple of years ago, when my wife thought, I think we should probably finish our basement, I said, that's a great idea, but I'm certainly not going to do it. It will never get done, and it won't be of sufficient quality. And so we hired some folks to do the work. And the people that worked on my basement, they didn't just have one hammer. They had an entire truck full of hammers. If you've ever gone to a big box sort of home retail kind of store, they have an aisle full of hammers. And some are bigger and some are smaller and some are heavier and some have, kind of a knurled face and some don't. And, some are great for tearing down a wall and some are great for doing finish work, and so you could try to use a sledgehammer to put up some nice maple trim, but it's not going to end well. You're probably going to break a thumb, you're going to dent up your nice trim, and it's just not going to be a pleasant experience. And so the challenge for us is, when do I pick up this tool? When does this make sense? And so it's on us to use them wisely. And it's also important to understand that microservices aren't the only choice we have. I love this quote from Simon Brown: if you can't build a monolith, what makes you think microservices are going to be any easier? And Matt Stein had a great set of tweets here recently. This one really resonated for me, and clearly a number of other people. Large monoliths are unmaintainable. No, they're not. Poorly structured systems are unmaintainable. It doesn't matter how you deploy them. He's absolutely correct. Now, I was having a conversation with Spencer Gibb, and he sort of helped me kind of crystallize this concept. And so I tip the hat to him for this slide. But we have this idea of modularity, and then we have deployability. And so many of us are in this unfortunate scenario where we have the most common of all patterns, the big ball of mud, even though it's probably the most loathed architectural pattern we use. And so we have neither modularity nor distributability. And so we look at the big ball of mud and we say, oh, this isn't a lot of fun. And then we see microservices and we go, whoa, that's nirvana. It is distributable. It is modular. I want to migrate my big ball of mud to microservices. That sounds awesome. Except that's not what happens. We create a distributed big ball of mud. And this, friends, is the worst of all possible worlds. Do not do this. We get all the complexity of trying to make this thing distributable, you know, all that extra jazz that comes along with these highly distributed architectures, but we don't actually get the benefits that come along with the modularity. So it's really in our best interest to migrate this to a modular monolith first and take that effort, do that refactoring. And then from there, if it makes sense, migrate to microservices. By the way, this tends to make it a lot simpler to figure out, well, I wonder where the bounded contexts are. I wonder where those domains switch over. You know, I wonder where the seams are in my architecture. That tends to work better from a modular monolith as opposed to doing that from the big ball of mud in the first place. Now, some people these days will talk about right size services or macro services. And I think this is just us trying to triangulate on what's the right size for this particular situation, for this application, for this team. And that's going to be different from team to team, from scenario to scenario. In some cases, you know, what you might think is too big, I might think is too small, and vice versa. And that's perfectly fine. We need to be ruthlessly pragmatic about these things. And so some teams are taking their modular monolith and making more coarser grained services, or they're taking some of their microservices and maybe refactoring them back together into something coarser grained. And that's, again, perfectly reasonable. You know your domain best, you know your situation best. I love this tweet as well. This is certainly a sentiment that I have put out into the universe multiple times. You don't have to use microservices to be cloud native. There are cloud native monoliths. That is often the right choice. And again, especially early on when we know the least. So don't be afraid to say, you know what, I don't think we're quite ready for microservices. We don't need to jump straight into that. And yes, sometimes these are the right choices. Now, this presentation, though, is going to try to give you some of the keys where microservices make sense, where we actually get some benefit from that. And so one of the first things we look for is multiple rates of change. So almost without exception, when you look at your systems, you're going to find that some parts of the system change all the time, and others, frankly, haven't changed in months or even years. And so if you're in a scenario where some parts need to move at different speeds, microservices can give you some lift here. So if we have this mythical widget.io monolith, you know, typical ordering system where there's a recommendation engine, an account, inventory, cart, etc. Well, let's be honest, as we look at this as technologists, that cart module is probably not changing very often. You know, you add things to the cart, you take things out of the cart. Maybe how we calculate tax has to change as the tax code evolves, but, you know, by and large, the cart itself hasn't evolved very often. And we probably don't have any control over the inventory system because, you know, that's probably some third-party warehouse thing that we don't have any way of tweaking. But you know what? Our customers really want the recommendation engine to be better. And I've never once had a customer tell me, you know what, search is just too darn good, Nate. You know, can you make search suck a little bit? People are finding what they want too easily. Now, the challenge of the monolith is everything had to move at the same rate. And I do believe this is why we traditionally relied on quarterly releases, because, well, you know, releases hurt and we don't want to do it very often. And besides, we want to be able to justify doing that effort. So let's wait until we have a whole bunch of changes together because somehow that's easier. And, you know, I have to push the whole monolith anyway. And, you know, now putting aside the fact that we often then got locked in these wonderful windowless conferences. I don't know who decides conference rooms should be windowless all the time. Trying to figure out which of the many hundreds, if not thousands of changes caused the build break that we're all experiencing. And it's like, well, I don't know, there's a whole bunch of them and who knows how they all weave together. It seems like if we only pushed a couple of changes, it'd be a lot easier to do these root cause analyses. Now, luckily for us today, we have options. Today, we can actually split things apart such that the pieces that iterate or can or need to iterate more quickly can do that. And so we might decide to refactor this and say, well, let's pull the recommendation engine out as its own microservice, and let's pull search out as its own microservice. And now they can go at whatever pace makes sense for them. And more importantly, that means I can get some business value into production more quickly. That's really what this game is all about. You know, we might be very excited about the technology, some new toy that we're playing with, but our customers want features and functionality delivered to production as quickly as possible. So how do I know what changes faster than the rest of our system? Well, trust your gut. There's a pretty good chance that you have an inkling already of what moves more rapidly in your own system. So don't dismiss what your instincts are telling you. But it's also really good to have some data. All right. So we can start with the most basic thing we have, which is our source code management tool. You know, if you look at your source code management tool, you can actually get a heat map just by looking at history. So Git gives you a lot of very powerful ways of seeing what's going on. So you can use a command like this to say, hey, show me what my top 10 list is. So at some point in the past, I ran this against Spring, which to be very clear is not a monolith, but you know, it's an easy code base for me to get my hands on. So that worked out well. And so I was looking at this one day and I'm like, oh, wow, the changelog changes a lot. Like who could have predicted that? Like, what are the odds? Now, I don't know enough about the ins and outs of Spring to tell you whether or not the configuration class parser changing a lot is expected or not. You know, every time I look at this slide, I think I should really run this by someone on the team to say, hey, you know, does this mean much to you? Like, was this worry you at all? And it's probably not. It's probably just what they would expect. But this will give you a place to start. This will give you an initial sort of location to start digging around and practice what many of us spend a lot of our career doing, which is software archaeology. So we can start rooting around in the code base, you know, or as I like to say it, roll up your sleeves, get your hands dirty, and apologies to Sir Isaac Newton, but we're looking for smoother pebbles and prettier shells, or what Michael Feathers refers to as churn. And now Michael looked at this in terms of, well, where should we refactor? And the reality is your code, like so many things in this universe, are going to adhere to a long tail pattern. You're going to have some files that are updated all the time. You know, 3 minutes ago, it was updated. Now, the others, we haven't even looked at this since we put the initial commit out there. Now, Chad Fowler took this concept and matched it with complexity to create this idea of turbulence. Now, there are code forensic tools that we can leverage, and you know, to be very clear, I don't sell any of these. I don't have any dogs in this fight. And so I simply show this to you just as an example of what some of these tools can do. And as I was doing research, I found this thing called CodeScene. Again, I don't work on this. I've never used it in anger, but I use it as an example of things that we can get by pointing some tooling at our code base. I like this one because it's kind of visual and I'm a visual person. But you start to see some hotspots in your code base, and you can start drilling into it, and you can start to say, okay, what's going on in this container.go thing? And you start poking around and you're like, oh, okay, all right, well, 800 lines of code, that seems about right. You know, that's not bad. A lot of commits and a lot of from the same author. That might be something we get a little concerned about. And there's a decent number of defects that have been in here, and it seems like we touch it all the time. Interesting. And we start to get some trend lines. You know, as an architect, I'm always looking at trends. Are we getting better? Are we getting worse? You know, how are things changing over time? And so we can see here that the complexity seems to spike, and I'm guessing there's some refactoring, and then it spikes again and some refactoring, and then it looks like things are kind of getting better, you know, but we also seem to have plateaued a little bit. Now, it's entirely possible that this is just a really hard thing to do, and complexity just is a natural byproduct of that. So I'm not trying to say this is good or bad. It's just something that we might use as a marker to say there's more for us to poke around. I've used cyclomatic complexity since very early on in my career. This is just a fancy way of saying how many paths are there through my code base? How many blocks do I have? Some people would argue that one is the maximum. I think that's probably a little too pedantic to try to do. It's not a bad goal, mind you. I will say that low single digit numbers are your friend. You can see from this particular tool, they decide that once you go from 4 to 5, that's when we have a problem. Now, I would argue that once you get into the double digits, you have a serious problem. And that's where I would definitely click over to orange. I'm not exactly sure where it clicks over to orange. But my opinion, once you start seeing these higher single digit numbers, you need to start doing some serious refactoring work. If you do start seeing double digits, that's when you need to start figuring out, how do I get off this project? The worst I've ever seen in actual production code was 82. And I still to this day have no idea how a developer sat down and created something that was that ugly, but they did. And not surprisingly, that's where we began our refactoring effort. Shocking, I know. We also can see some comparisons here that unsurprisingly, complexity and lines of code do tend to mirror one another. And then I do think it's fascinating. This must be that magic self-documenting code. There's no comments here, what could possibly go wrong. You also start to get a sense of, who's working on what, where is sort of that locus of attention. Do we have any sort of single person dependencies? I like to think of that as a low lottery number. What happens if this individual wins the lottery? Are we in a world of hurt? And so you start to get some really interesting insights into your code base that might help you make some changes. Now, again, I'm not trying to pitch specific tools. That's not what I do for a living. I'm sure there's someone else who'd be happy to give you that information. But we can leverage our source code management tool of choice. I'm sure all of you are familiar with GitHub in one way, shape, or form. And sure enough, GitHub will tell you an awful lot about what's going on in your code. Like, oh, this hasn't been touched in a couple of years. This was touched a couple of days ago. And so if I'm in a situation where, geez, the last time we committed this code was, one of those super blue blood moon eclipse things happened, it's probably not a good candidate for us. We want to look for those parts of the code base that are always be changing. And then that's the spot that we might want to start doing some deeper research. Your bug tracker can help you quite a bit here. Where do the defects tend to live? That's another thing that usually is a pretty good indicator where there's some churn. Look at your backlog. What do your customers keep wanting you to change? What are your analysts telling you need some additional attention? Now that's great. We have some candidates, but what do we do now? I mean, do we just nuke and pave? I mean, that doesn't always work well. We rarely have that luxury, by the way. Well, no, this is where we rely on the strangler fig pattern to help us out here. Now, this is based on some work that Martin has put out into the universe. He was on a trip to Australia and saw this sort of strangler fig moss thing that grows over the tree and subsumes the tree underneath it, as I understand it. And so, of course, that was a perfect metaphor for software. And so this is one of the things that Martin's been talking about. By the way, he's kind of tweaked the name from strangler to strangler fig, trying to be a little less, I guess, aggressive, if you want to say. So this is well known. I'm a big fan of this particular approach to software. But the idea here is that we build the new around the edges of the old. And over time, we gradually replace those heritage bits, which drastically reduces the risk of a big bang cutover. I mean, I've done a few of these big bang cutovers in my career, and it's like doing the high wire act without a net below you. A lot of risk, a lot of concern, a lot of late nights, early mornings. The biggest complaint I have about these, though, at least in my experience, is we spend so many months telling our customers, just be patient. We're almost there. Just be patient. We're 80% there. We're 85% there. Just hang with us another 2 or 3 or 6 or 8 or 9 months. And we don't get a lot of credibility because they're like, well, show me something, show me, put something down on, get something in production. Let me see it. And so the beauty to me of the strangler fig approach is that, well, I can incrementally deliver value. I can show them progress. And more importantly, they can adapt to that. They can say, oh, well, now that I see that, what actually I really want is this. Now, that's great. I love that approach, but we can actually go a step further and apply data to this process. I spent a lot of my career on heritage systems, and we always kind of had this conundrum of what would you say the old system does exactly? And I can't tell you how many times I've started a project and you ask your customer, well, what do you want? And their answer is, it should work just like the old system, only better. And then we sit there and we, pound our head against the table. But then you ask, well, what does the old system do? And their answer is, we're not really sure. It's probably fine. There's a pretty good chance that you don't actually understand all the nuance of how the old system works. That there's all sorts of interesting things that have been patched and fixed over the course of years, in some cases decades. And my wife, who's over my shoulder here, she's a business analyst, and she will tell you that we never update the documentation after we do one of these patches, after we do one of these fixes. And this is just the nature of software. We run into that weird edge case that only happens, once every 7 years. I very distinctly remember at one point in my career, I helped write this system that we sort of handed over to another part of our company. And then, I don't know, maybe a month later, my director wanders over and says, hey, you worked on the Wombat thing, right? And I said, yeah. I said, hey, they had a build break this morning. Could you help them out? I'm like, of course. but they should just look at the last change they made, and that'll probably tell them what the problem is. And he said, well, that's the thing. They actually haven't touched the code base, this week. So they're not sure why the build broke. So, I went and looked at their Jenkins instance, saw that it was a failing test, went and looked at the test and realized very quickly, oh, this test is going to fail every 7 years because there was some weird time thing that only happens, that when a Monday falls on this day or whatever it was. I honestly don't know how I fixed it. I mean, I wrote the test, so it's my own fault, but I may have just really annotated it saying this will pass tomorrow and this will fail in 7 years. And so we do that in code. We put in that patch for when month end falls on a bank holiday or when it lines up with this thing or that thing. And so we go and fix it, and we don't update the documentation. Sorry. So we end up in this scenario where there's a lot of unknowns in our code base. So what if we actually had some real world data about how our system works? And so I don't remember which edition of Spring One this was discussed at, but it's the idea, well, let's apply data to the strangler fig approach. And so what that looks like in practice is we put a proxy layer between our client and the legacy system. And its first job is just record what's going on. Log, here is the request, here's how we respond. And we do that for a couple of days, a couple of weeks, a couple of months, whatever you need to get confident that we've covered, the 90% cases. So this gives us some data. We now know what the old system does, and we can use that to drive tests, because rarely do these systems have tests. And so now we can go ahead and tweak that, refactor that, build new functionality, whatever we need to do. And so the beauty of this approach is I can actually leave that proxy layer around, and I can route traffic to both pieces for a period of time. So I can run the new in parallel with the old, route requests to both modules, and then I look at the results. And if they match, fantastic, everything is good. If they don't, well, let's go with the heritage response. That's still the system of truth for the time being, but that's going to log something out somewhere that a human is going to go investigate later and probably write some new tests. And you know what? There's a decent chance the old system's probably wrong. I mean, it might not be, but there's a pretty good chance the old system's wrong. Now, the next thing we look at is independent life cycles. I've been on a lot of monoliths, and one of the phrases that I hear a lot is, we're a big ship. We don't turn on a dime. I get that, although that does imply we need to start turning sooner. Then we probably shouldn't wait until the last moment. We might need to think ahead a little bit here. If you've ever seen how these massive ships work, they start slowing down, seemingly, weeks in advance of when they actually need to stop. The problem we have today is we have to be more nimble. We have to be able to react more quickly. We need to really embrace that always be changing lifestyle. And so I need to be able to run experiments. I need to be able to do A/B testing. I need to be responsive to the changes that my business partners are seeing. And I think back to the beginning of my career, and seemingly every estimate we gave was 18 months. How long is this going to take? 18 months. And our customers are like, well, all right, then I guess that's what it takes. Yeah, that just doesn't work today. There's too much disruption. There's too many things going on. I need to turn things around in hours, days, maybe weeks, certainly not months, and God forbid, years. First Spring One, I attended as an employee. During the keynote, gentleman got up from Scotiabank and talked about their journey from the traditional, 4 releases a year to thousands of releases a month. And to be very, very clear, this is not something that happens overnight. This is not something that you have a meeting on Tuesday and decide, oh, we're going to do this, and by Thursday, we're doing thousands of deploys. It takes significant engineering discipline. It takes a culture shift, but it can be done. And what was so interesting to me is, at this particular Spring One, some of my former colleagues were there, and we were chatting in the hallway one day, and one of them said, oh, Nate, we can't do that. And I said, why not? He said, you worked with us for years. This isn't going to happen for us. I said, did you catch the part where the guys from Scotiabank? It's a bank. That's a pretty conservative organization for good reasons, by the way. But if a bank can make this change, then so can you. And the reality, whether it's convenient or not for us today, is speed matters. And disruption is affecting every business. There is no industry that's immune from this. And so if we return to this widget.io monolith example, if our business partners come to us and say, oh, we've got this super exciting new opportunity, but we really need it turned around quickly. I need it in days. I need it in weeks. that quarterly release cycle is just not going to do it for me. I can't wait that long. The opportunity will be gone, or a competitor will step into that void. Well, you know what? If we split that out as its own microservice, well, now all of a sudden it can iterate at whatever speed it needs to. It's independent of everything else. It has its own repository, it has its own pipeline, it has its own independent life cycle. Now that's good. And what's really interesting to me is we don't just get speed to market. I mean, that's obviously what our customers are really happy about, but it also improves our developer productivity. So having been on a lot of monoliths, I've never been a fan of these seemingly infinitely sized getting started guides, 87 pages. And there's always some weird manual step where, go talk to Kathy and then she'll do some incantation over your laptop and then magically things work. I've been in situations where your build was measured in phases of the moon. I was on one app where builds routinely took 24 hours, which means you would check code in on Tuesday and you wouldn't discover you broke the build till Thursday, which always puts you in that weird situation of, I wonder what I did on Tuesday. What was I working on? Can I even get my system back into that state? Probably not. I've been in situations where it takes you months to get up to speed as a new developer, which is not a lot of fun, frankly, as either the developer or the person who hired the developer. And so think about what was your longest stretch to get someone to be productive. I was in one situation where it was considered a year was about what it took before you got comfortable in the code base. That wasn't awesome. Smaller scope means there's less for me to get my head wrapped around. Smaller scope means my builds finish quickly, a minute, maybe less, which means when I break something, we're more inclined to fix it quickly. It can be far simpler to test these smaller things with less surface area. I was working on one application and I made a suggestion for a change and my QA lead just stared daggers at me. And like, you have some input. And she said, please don't make that change. And I said, okay, well, why not? She said, if you make that change, I have to spend 80 hours doing a manual regression test and I don't want to do that. I'm like, oh, okay, well, let's find an approach that works a little better for everybody then. I can write a bunch of fine-grained tests that run on every commit. I don't have to do performance as this one-off, which is traditionally what it's been. And for a shocking amount of my career, we do performance tests about 6 weeks before we went to production. And then we just put the results in a drawer because it's too late. We can't do anything about it anyway. We got to go to prod in 6 weeks. So, hopefully they won't notice, or we'll throw more hardware at the problem. That solves every issue, right? It allows us to use the right tools for the job. Now, the unfortunate aspect of shared, life cycles means we can only move as fast as our slowest moving part of the organization. I've been on some currency projects before, and it's amazing to me how we get stuck in this rut where we can't upgrade to the next version of Java because, the Wombat app's not ready. And so we have to stay on this incredibly old, crusty version of Java because I love the fact that with this approach, I don't have to stick to a one size fits nobody kind of thing. If you've ever seen a t-shirt that says one size fits all, you might look at you as like, who's this all person? Because it doesn't look like it fit anybody. Every microservice can use the right mix of tests that make sense for it. You can use the right linting rules, the right code quality scans, can make it so much easier to find your fitness functions. It also means I can actually practice hypothesis-driven development. Now, I love this quote, prediction is very difficult, especially if it's about the future. And just think for a moment, how much time have you spent in the project room debating possible solutions, saying, well, my approach will obviously result in more sales or more signups or more conversions or whatever metric you care about. But how do you know you're right? And this is where it's just like, well, that person sounds really confident, so I think they must be correct. More importantly, what happens if you're wrong? Now, on the monolith, by definition, we had to be conservative. Now, I live in Minnesota, which is in the sort of northern and central part of the states. And that means we have this thing called winter, where it gets very cold and there's lots of snow and ice. And so we're in summer right now. It's beautiful. Yesterday was gorgeous. I have a hard time thinking in Celsius, but it was kind of, I think, in the high 20s. It was gorgeous. Now, in the winter time, though, in the fall, my son, when he was younger in his school, posters would start showing up, reminding the kids to walk like penguins on the ice. Because if you take big, long strides when it's slippery, you are going to fall and you might hurt yourself. Hopefully you land on your butt. Hopefully you don't land on your face. And so you have to remind the kids to walk like a penguin. That's how we typically had to work with a monolith, because if I was wrong, I just blew a whole quarter. This is thousands and thousands of hours of work. So we had to be really conservative. The beauty of microservices, excuse me, is I can actually test my hypothesis. I can do A/B testing for something that for most of our career has been, oh yeah, if you're a big tech company, you can do that, but we can't justify that at, retail store co. And so I can actually do hypothesis-driven development, which looks a little something like this. We believe this change will result in this outcome. We will know we have succeeded when we see this change in this metric. So we believe adding a distributed cache will result in faster startup times. We will know we have succeeded if startup time is less than 15 seconds. Now, this can lead us to some very interesting fitness functions. And as I alluded to before, this used to be the playground of the Amazons, the Googles, et cetera. And it turns out we can actually all do it now. Because let's be fair, what customer doesn't want a constantly improving product? Now, in order for this to work, however, it cannot be a free-for-all. It cannot be let 1,000 flowers bloom. We need to focus on paved roads. And it's important to understand that this is what goes on even at the most developer autonomous organizations. We have this concept of this is how code gets to production. We know how it works. We know how to support it. We have thousands and thousands and thousands of examples of it working well. If you choose to go on the minimum maintenance road, good luck to you. You travel at your own risk. I hope you brought your snow chains. The other side of this coin is you build it, you own it. This is the piece that a lot of folks miss when they say, oh, but the best part about microservices, I can choose whatever tech I want. Yes, along with that autonomy comes accountability. The other piece of this that you have to remember is, how do you get good at something? Well, you do it. Repetition is your friend. How do you possibly get good at releases if you only do them every few months? How can you possibly get expertise there? What I've seen happen a lot is you come out of that release weekend and you're like, oh gosh, I don't ever want to do that again. Yeah, right. No, let's never do that again. But you don't have an incentive to go fix anything because, well, I'm exhausted from this weekend, and we'll work on it, but I need a break. And then the next thing you know, you're at your next quarterly release and you're like, wow, we didn't fix anything, did we? This is one of these things I've actually had a discussion with my son about, not about software per se, but he's trying to play golf, and I keep reminding him that if you want to get better at golf, you need to hit a lot of golf balls. This is not a sport that works particularly well if you only play once or twice a month. And so we need to get in this mindset of, well, I'm going to deploy early, I'm going to deploy often, and if I deploy dozens of times a day, I will by definition get better at it. I will start buffing off the rough edges. I'll start to develop some muscle memory. The other piece of this is you will develop some trust in the process. That's vital. Again, if you only go to production periodically, does it work? Well, maybe not. If I've gone to production 5 times today, I got a pretty good idea that this thing works. Now, it's really vital that we have robust pipelines for this. And there's a ton of great tools out there. The vast majority of them now are cloud-based, which is good. If you don't know how to create a pipeline, my Spring colleagues have some thoughts here. And by the way, we're not trying to own your build. It's just an opinionated build, test stage, prod flow, and it's just a place to start. You can go ahead and modify it to your heart's content. Now, I am very much of the opinion that independent life cycles are one of the most underappreciated benefits of adopting this particular architectural approach. The most dangerous phrase that I hear, and I hear it a lot, is that's how we've always done it. That just doesn't work anymore. A couple of years ago, I was helping out a client, and they brought me in because they're having a performance problem. And I'm not a performance guru, but I agreed to help look at their architecture. And so they're walking me through their approach, and basically what it boils down to is, for each one of their clients, they get buckets of widgets and they process the widgets, and then they move on to the next bucket and they do some more processing. And so as they're explaining this to me, I said, well, and their problem ultimately was that, they were getting really successful and they had lots and lots of customers with really big boxes of widgets. And so their overnight batch run wasn't finishing overnight anymore. And so I said, well, does the processing of widget A have anything to do with the processing widget be? Nope, they're totally independent. At the end, we do some aggregation. I said, could you process them in parallel? Could you have a set of workers that just grab the next widget, and then maybe write that out to a queue or something? And there's kind of this like pregnant pause, and then like ding, the light bulb went off, and it was clear like, well, but that's how we've always done it. And as much as I'd like to say that I had some magic insight, I just wasn't constrained by that's how we've always done it mindset. I was able to look at that and say, well, could you do it a different way? All right, well, let's wrap up with the reason so many of us are excited about microservices, and that's polyglot tech stacks. The monolith forced us down this one size fits nobody sort of approach. I've been a lot of companies where we describe themselves completely by our stack. We're a Java shop, we're a Ruby shop, we're a .NET shop, which is really just another way of saying, I have a big hammer, please somebody bring me a problem. And there are pluses to this approach. You get some expertise. If you spend a decade on a platform, you usually get pretty good at it. Makes it easier to move teams around, cross-pollinate, et cetera. It can make it easier to simplify hiring or training. It does help our operators. They only have to focus on one kind of environment, but one size doesn't fit all. Again, if you've ever seen that t-shirt that says one size fits all, I really want to meet who this all person is, because it doesn't look so great on me typically. Now, there are some downsides to this. As I said earlier, currency is almost always constrained by whatever that slowest moving app is. And so I'm sorry, you don't get to have nice things because the Wombat app's just not ready for that. And by the way, when we do an upgrade, it's going to take us months to do it. And by the time we actually get it done, that new version we're updating to, it's outdated already. Oops. And of course, the reality is very few organizations are truly homogenous, and all it takes is a merger or an acquisition and you're not homogenous anymore. We never get involved in the M&A process until it's already been decided, and the senior people of the senior managers have already kind of divvied up their bonuses and everything, and it's okay, techie guys, make this work. Now, cloud computing does remove this huge constraint of one stack to rule them all, because I actually can spin up multiple stacks if I want to. So Polyglot's not this pipe dream anymore. It does let me use my full toolkit. It does allow me to pick the right tool for the job. So I don't have to take the square peg, get my big hammer out and pound it into the round hole. However, there's always a but. We have to avoid technical sprawl. Now, a lot of people realize pretty quickly, they're like, oh, this is awesome. Everybody can use the right tool for the job, except what that means is everybody has their own favorite tool, own favorite language, their own pipeline preference, their own metrics. And now you don't have 2 or 3 ways of doing it. You've got hundreds of ways of doing it. And where's this unicorn developer that knows Go and Haskell and Java and Ruby and Python and JavaScript? And by the way, how many libraries do I need to support all that? And can I stay current on all that? We've all seen the instances of these bugs leaking and having, hundreds of millions of people's information spread all over the interwebs. I mean, it's just a guarantee. So we need to have some guardrails in place. It can't be a free-for-all. There needs to be some guidance here. Now, it could be very broad. It could be use anything you want as long as it runs on the JVM. It could be more constrained. For most of my career as an architect, my job was to tell you, here are one of the 3 languages you can use. If you don't like that, you're wrong. Again, the focus here has to be on paved roads. This is what goes on even at the most developer autonomous organizations. Here's a well-worn path. We know how it works. We know how to support it. We have lots of examples of success. If you choose to do something that's out of the norm, that's fine. You're able to, but build it, you own it. You are accountable for the outcome. So sprawl does exacerbate our accumulation of technical debt, which again is why micro is the key word. They should be small. Now we can debate what small means until the proverbial cows come home. Again, I like anything we can rewrite in 2 weeks or less, because if I chose poorly, I lost an iteration, that's recoverable. The other piece of this is the longer I've spent on something, the more invested I become. I'm quite certain this is why teenagers actually live through their teenage years, because we have so much time invested in them. And we remember when they were cute, cuddly 7-year-olds, and we realize, okay, well, they'll become normal again at some point, right? I hope. So it can be challenging then to try to change course, even if we really should. So yes, microservices do give us the ability to choose the right tech for the job, but we have to weigh the pros and cons of this and understand that with great power comes great responsibility. You build it, you run it, you own it. So be very, very careful that you are not engaging in resume-driven design. This happens to the best of us. we must use this technology. Why? Because I want to put it on my resume. So yes, microservices do give us some very impressive benefits. They do come at a price. Please do not pay that complexity tax unless you get something in return. So no, not everything needs to be a microservice. We should use them where they make sense. We should use them where they add value. So if you need one or more of these principles, and I didn't get to all of them, I apologize, go forth and prosper. And if not, don't worry, there's always serverless, so that probably will work too. I wish you luck. Thank you so much. If you want to see me go deeper on this, I do a series for O'Reilly occasionally around this microservice approach. So, if you're interested in that, feel free to hang out with me there. I think I've got one coming up soon for some value of soon, but I tend to not look too far out of my calendar because life changes rapidly these days. And if you want to see more with me, I do a Twitch stream on Mondays if you want to hang out as I interview interesting people in industry. And so with that, I will hop out of here and see if there are any questions or comments. Although I guess we only have about 30 seconds.
Yes. So. Don't worry, Nate. Thanks very much.
My pleasure.
So we have a question from Narmin on YouTube. So he asks, he would like to have your opinion about microservices that have shared databases.
That's an excellent question. So why did we decide, or why does sort of the platonic ideal say, let's not have shared databases? Because integrating at the database hurts, and when I need to make a change, now I break you, and you need to make a change and you break me. So integrating at the database level is painful. So let's not do that. So every service has its own database. Well, there's a consequence to that, which says, these three services are all working on the same data. And so they each have their own data store. Now I've got to try to, mute that together. And I got to have a service that runs and copies things over or whatever. And so that has consequences too. There's nothing wrong with sharing data if I control all of the services. Where it becomes problematic is if I control two services and Bruno controls the other one. And now we're right back where we were, now we got to negotiate and stuff. So some people call this a service-based architecture. That's usually Mark talks about it, but we can't afford to be dogmatic in this industry. We need to be ruthlessly pragmatic. So if the right choice for you, and you control all three of these services, to have them use the same data store, then that's okay. It's not like there's, the microservice police are going to come and give you a demerit or something. You do what's right for you, and your situation best. So if the easiest, or I should say, if the simplest approach is have them work together, then have them work together.
Okay. Thanks, Nate. We need to wrap.
My pleasure.
Our time is up. And thanks very much for being here at Jnation. I hope we can see you again in future editions as well.
I need to come visit you guys in the real world. I'm very excited for that. So fingers crossed for 2022. I get to come visit you.
Fingers crossed. Thanks. Bye-bye.
Thanks, everybody. Cheers.
Olá, eu sou o Luís, sou o Head of Engineering da XGeeks. O meu trabalho toca um bocadinho de negócio, de projeto e pessoas. Acima de tudo, pessoas, é o maior foco do meu trabalho, em que a ideia é o Head of Engineering poder ajudar todas estas pessoas, todos estes engenheiros que fazem parte da XGeeks a crescer, tanto do ponto de vista pessoal como profissional, e eu diria que isso resume um bocadinho aquilo que é o meu trabalho. A XGeeks em si é uma empresa que não se classifica como uma típica empresa de consultoria, primeiro porque queremos e estamos a dar, durante este ano de 2021, um grande foco à comunidade. Queremos apostar muito em projetos de comunidade, em projetos tal como a Jnation, em contribuições open source, e eu acho que isto por si só já nos diferencia um pouco das outras empresas. Em segundo lugar, porque gostamos muito de trabalhar produto e temos um foco muito grande em produto, sentimos-nos engenheiros de produto, e depois porque queremos ainda dar mais ênfase à parte da engenharia e queremos que os nossos engenheiros se possam especializar enquanto individual contributors em tecnologias que achem que façam sentido para a sua carreira. Ou seja, nós damos esta possibilidade de um engenheiro ir muito fundo numa tecnologia específica e até conhecer os internals dessa tecnologia, e nós gostamos desse tipo de approach. Isto diria que resume um pouco aquilo que é a XGeeks. 2021 tem sido um ano incrível para a XGeeks. Aliás, já 2020 tinha sido. A pandemia foi boa para nós, por assim dizer, ou seja, conseguimos, e também acho que a empresa foi boa neste contexto de pandemia, porque abriu as portas a muitos projetos e a muitos colaboradores. E como eu dizia, 2021 trouxe-nos imensos projetos, e eu aqui salientaria dois, talvez a Cloud Mobility e a Tamana. A Cloud Mobility, que é uma cloud verticalizada, em que nós estamos a ajudar na construção desse produto, em que, se calhar aqui para os nossos ouvintes, o mais interessante é a tecnologia, em que estamos a usar Java, Spring Boot, React, Go também, e acima de tudo, toda a Cloud Mobility assenta em Kubernetes. E depois a Tamana, que é um marketplace no Médio Oriente, que nós também ajudamos a construir, que está feito em Java, Spring Boot e em Next. Este ano estamos a focar essencialmente Java, JavaScript, Python e DevOps, são as tecnologias que nós queremos apostar mais e que temos mais espaço na equipa para crescer. E por isso, se houver alguém que queira juntar-se à nossa equipa, candidatem-se. Bem, o nosso tech stack é muito difícil de definir, até porque é muito vasto. Ou seja, nós, aliás, estamos neste ano de 2021 a trabalhar no nosso Tech Radar para também ser mais fácil dar visibilidade a todas as pessoas que querem conhecer um bocadinho mais da XGeeks, aquilo que nós fazemos em termos de tecnologia. Mas diria que desde o Java, como eu disse, Java Spring Boot, desde o Python, tanto Fast API como Django, React, ou seja, React Vue e Angular, usamos as três em diferentes projetos. E depois toda a parte de DevOps, por assim dizer, faz parte do nosso tech stack. Eu acho que quando lançarmos o nosso Tech Radar vai ser muito mais fácil, e acho que aí as pessoas também que tiverem curiosidade para ver, basta seguirem-nos no nosso Twitter e no YouTube, onde temos estado a fazer também algumas live streams sobre neste caso, Java, e poderão depois, com mais facilidade, encontrar estas novidades.
We're pulling into the party and we're shaking off the dust. It's been a damn long week and all we wanna be is way too drunk. Wanna feel a warm body, wanna dance until we're numb. We're drowning out the world tonight with plastic bottle rum. All pretending pretending we know what we're doing, but we know that we're still just young. Love, heartbreak, kids acting like we're somehow.
Welcome back, everyone, to the Almedina track. We now have a session presented by Meet, which is joining us from the UK. He's a developer advocate at Google, especially for Google Cloud, if I'm not mistaken. And Guillaume, which joins us from France, and also a developer advocate at Google, and also for Google Cloud, I think.
Yes.
So they'll be presenting on choreography versus orchestration in serverless microservices. So the path from monolith to microservices, pros, cons, challenges, and how to overcome them. And I guess it's gonna be a pretty rich session on this experience. So guys, without further delays, I'll give you the stage, or actually in this case, I'll give you the stream.
Yes.
Not the stage.
Thank you very much. So hello, everybody. We're happy to be there, if only virtually, with you. So we'll be talking about choreography and orchestration in serverless microservices. So we're not going to speak about that kind of choreography or orchestration. So there's no, ballet dancing or musical instruments involved. Instead, we'll be speaking about microservices, how to orchestrate them or make them collaborate together, and the different approaches. So for example, let's think about a simple e-commerce kind of transaction where we would have a web front end that talks to a payment processor. Then the order is going to be shipped when the parts are ready, and then we are going to notify the customer. One way to do it would be to have each service call each other in a kind of a chain. So front end calling the payment processor saying, "Oh, I'm ready. Hey, shipper, please ship this order," and notification, etc. There are pros and cons to that kind of simple approach. So first, it's better than a monolith in the sense that we already split in different services the overall transaction, the overall process. And also it's easy to implement because it's usually fairly straightforward to have service that calls another service. But on the downside, there's really too much coupling between all the services, because what happens if there's one in the chain that fails, it's not ideal, and the whole transaction is going to fail. How do we ensure that this transaction is successful in the end if it broke like in the middle? Also, another concern is the fact that if you want to apply some retry, timeout logic, etc., you'd have to do that at each service, calling the next service. So it would also add, some bloat into the code of the service to know perhaps too much about how the next service in the chain is going to work or not work, actually. So it's not ideal. Instead, if you use a choreography approach, which is, let's say, a synonym of an event-driven approach, where you use a message broker instead of having services talk to each other directly. So here in this case, you are just exchanging some kind of messages, like messages on a pub sub topic, for example, on some kind of broker, whether it's Google Cloud Pub Sub or let's say Apache Kafka, etc. Here, instead, we exchange messages. So the front end is going to send a message asking, okay, I've got an order, and then the payment processor is going to pick that message. Oh yeah, I can treat that. I'm going to authorize and charge the credit card, etc. And we use that message broker to pass information between the services. So there's no direct coupling between the services, and the services can stay independent. This is great, although when you have a more complex transaction, more complex process, when it's not, one after the other, each service being called, being, activated in a way. In a more complex situation where you have to ask the inventory database about what's left in stock or not, you have to potentially contact a supplier's API, a third-party API to replenish the stock. You're going to update your own inventory and order database, perhaps use a third-party service again, like SendGrid to send emails, or a Slack API if you want to notify, for example, the sales rep. Then the flow of messages that actually make the business transaction are quite complicated to follow, and it's hard to understand the actual flow charts that we have drawn here on screen. So the pros: services are loosely coupled, which is great because there's not a tight coupling, which means services can be changed, evolved, developed, deployed, and scaled independently of each other. We also don't have a single point of failure because a service fails, but at some point it will be back up. But the messages will still be there in the message broker, in the queue or topic to be picked up once the service is back on. And also what's great with a choreography, an event-driven approach, is that events are really easy to extend or add a new event, a new message in the system, or add new subscribers to an existing message and topic. It's fairly easy to extend and expand an existing system. In the cons, I would list the fact that it's difficult to monitor the whole system because, well, there are messages going in each and every direction. How do you ensure that you follow the flow chart of the business transaction? Also, things like error, retries, timeouts are complicated. You might have to put that logic perhaps at the topic level. You can configure the topic with such settings, but that means that it's at the topic level and not necessarily per transaction. Perhaps different transactions, different business processes might have different needs in terms of errors, retries, etc. So yeah, the business flow, the business process is not captured explicitly. So there's no way to version that in Git, for example. And also, again, like in the previous approach, who ensures that the whole transaction is successful? You might have messages waiting in a queue. Perhaps we need another service that tracks the status of all these messages still left in the queue. But it's more logic to get that in a good shape. I let Mete talk about orchestration.
Cool. Thanks, Guillaume, for that introduction. So before I forget, let me share my, if you can, yeah, okay, you stopped, and I will share my screen. Okay, hopefully you can see my screen.
The Earth.
Oh, is it still the Earth?
Yeah,
you don't see the...
Yeah, the Earth.
We see Earth,
It's a nice view.
Yeah, we can't complain.
That's
jealous.
odd.
I'd love to see such a view someday.
Sorry, I will try to stop and share screen again. 1 sec. Unfortunately, the Zoom.
Perhaps you want me to keep sharing the slides while...
Yeah, just 1 sec. Well, let me try it one more time.
Yes.
There we go.
Okay, sorry about that. So hopefully you can see my slides now, right?
Yes.
Yeah.
Okay, cool. Thanks, Guillaume, for the introduction to choreography. And so as you've seen, one approach we could have taken is just services calling each other, and that works, and it's simple to implement, but it has some drawbacks. Then we can use an event-driven kind of system, but the pros and cons are also, as you see here, the biggest con for event-driven system is that things become really complicated to monitor and kind of make sure everything works as expected. So what else can you do? Well, what you can do is that there's this new approach called orchestration. And the idea with orchestration is that, when an when a request comes into your front end, instead of your front end calling the services, or instead of the front end sending a message to a message broker, what it can do is that it can start an orchestration. And this orchestration is usually done with an orchestrator, an external service that has a definition of what should happen. And then the orchestrator is the one making sure that the services are called in the order that they're supposed to be called. So in this case, the order comes to the front end, then that kicks off the orchestration, that goes to the orchestrator, and the orchestrator will call the payment processor, make sure that that completes, get the results, then it will call the shipper, and it will call the notifier, right? Now, in this model, the pros and cons is that, first of all, you have this orchestrator capturing the business flow centrally. And this is really important. Having this business logic captured centrally, it allows you, first of all, to have a single place where you can look at the business logic, but also it allows you to source control that. So you can have different versions of your business flow, right? And that has a lot of benefits. Secondly, your orchestrator has these steps that they call services. So each step can be individually monitored. You can have a centralized error, retry, and timeout logic, right? Because for each service, you want to be able to do certain error handling and certain retries and timeouts, right? You can do this individually in each service, but usually that's not what you want. You probably want to be able to apply global error, retry, and timeout logic, and orchestrator helps for that because you can define these in orchestrator and they can be applied to each service globally instead of individual services implementing them. And then in the orchestration, you can use simple REST. One of the problems with event-driven systems is that, with events, you usually have multiple event formats. And with that, you probably need to have multiple event parsing logic, right? So pretty quickly, things get quite complicated. Whereas in orchestration, you can make your services understand just plain HTTP and make your orchestrator call those services with plain HTTP. So that tends to simplify things a little bit. And the good news is that, when you're orchestrating, your services are still independent. They're still deployed independently. They can be upgraded independently. They can be scaled independently. But they're part of an orchestration. So in a way, you're creating a monolith where your services are kind of still independent, and that has benefits. So you're kind of getting the best of both worlds. So you're the independence of the services, but at the same time, the tight coupling that you need in your orchestration. Now, on the other hand, orchestrator is another service that you need to worry about. You need to learn. So that's given. Orchestrator could be a single point of failure because at the end of the day, it's just another service in your system. So you need to make sure that you're using an orchestrator service that's resilient and redundant and all that kind of stuff. Because if orchestrator doesn't work, then nothing will work in your system. And the fact that you will be relying on REST with orchestration means that your system will be more tightly coupled. It's not going to be like eventing where you can just add a service and just, have your service just show up in your system with minimal hassle. In orchestration, you need to deploy your service, but you need to also change your orchestrator and your orchestration definition to take that service into your orchestration. So you have more tight coupling, but that's kind of the point of orchestration. You want that tight coupling a little bit more than eventing, right? And then at this point, you might be wondering, okay, we learned about choreography, we learned about orchestration. Which one is better? Which one should I use? And the answer is, as in every software engineering question, is it depends, right? It really depends on what you're trying to do and what is more important to you. But as a general rule of thumb, if your services are not closely related, so let's say in our example, we had a payment processor, and we also had a notifier. I mean, these services, they don't really need to know about each other. They don't really need to worry about each other. So if you have that kind of services, usually it's better to use choreography or event-driven kind of architecture to put them together, because they don't need to really know about each other. And also, in cases where your services can exist in different contexts. For example, again, the notification service can be part of a checkout process, but at the same time, maybe it's also part of some other kind of process where you need to notify at the end, right? So it can exist in different contexts. For those kind of use cases, then if you use eventing, it will be easier because you will be able to plug in your services in a much easier and flexible way. Now, if you have a business logic where you can describe it as a flowchart, like the flowchart that Guillaume showed you, where you can see that, you know, depending on certain states, you want to take certain branches, and then at certain steps, you want to be able to call external services, so you can easily visualize your business flow, then maybe it makes sense to capture that in orchestration. Because if that business flow is set and you want to be able to trace through the business flow in your system, then orchestration usually is the answer. If your services are closely related, so for example, if you have a payment processor and a shipper that always go together, right? Because before you ship, you need to charge, and after you charge, you need to ship, right? So if that's always the case, it is good to put that in orchestration and still keep their independence, because these services should be independent because they're doing in like different things, right? And finally, if you don't want to deal with the complexity of event parsing and different eventing formats, and if you want to just stay in plain REST, then orchestration is probably a good solution as well. And then you can also take a hybrid approach, right? You don't really need to choose one or the other. Instead, what you can do is that for things that make sense to be orchestrated, you can put them in orchestration. And then once that orchestration is done, you can notify other orchestrations with events. So you can see that here we have a few orchestrations, and then each one, when they're done, they can send a message that can be picked by other orchestrations. So this is a hybrid approach as well, where you combine both orchestration and choreography. And usually this could work. I mean, because in your system, depending on how complicated your system is, sometimes you want things to be orchestrated and sometimes you don't. And you can kind of pick and choose what parts of your architecture should be orchestrated. And if for other parts, you can just use simple eventing to notify others. All right, so hopefully this gives you a good idea on choreography and orchestration. Now Guillaume will take over and let you know about the landscape in both of these approaches. So I'll stop sharing right now.
Thank you. So you should be seeing my screen now, I guess. All right. So yeah, let's talk a little bit about the landscape. In terms of choreography and event-driven solutions, all the cloud providers provide different solutions, different products, whether it's AWS with SQS, SNS, EventBridge, Azure with EventGrid, Event Hubs and Service Bus, not the other way around. With Google Cloud, you have PubSub, which provides topics, subscriptions, etc. But you also have another fairly recent product, which is EventArc, which is a great way to link sources and syncs together using cloud audit logs. You can send events to Cloud Run services, which run containers in a serverless fashion. But there are also many other really great solutions, especially in the open source space. For example, Apache Kafka, or Pulsar, or RabbitMQ, NATS in the Go world. So you've got plenty of options for message-driven approaches, basically. In terms of orchestration, so there are good old, I often get that remark, good old orchestrators or that are part of ESBs, things like that. In the cloud, you also have step functions for AWS, which works with Amazon Lambda. You've got logic apps in Azure. On Google Cloud, you also have different options. Cloud Composer, for example, it's based on Apache Airflow. It's more for data-driven kind of pipelines and workflows. You are also able to run things like Kubeflow machine learning pipelines on Kubernetes clusters. But the one we're going to look into in a little bit more detail, it's workflows, Google Cloud Workflows, which is an orchestrator and which works great for any kind of API, including Google Cloud APIs, your own business logic running on Google Cloud resources, as well as third-party APIs or APIs, REST services that are available anywhere else. Another thing you should keep an eye on, that's the serverless workflow specification. So it's part of the, currently it's just a sandbox level project at the CNCF Foundation. It's a specification and it tries to define, well, on the screen, declarative and domain specific workflow language to really describe your workflow in a portable way. So portable, yes and no, because all those workflow products or solutions that we mentioned will have to implement that specification in order for that specification to be portable. But I'm seeing this kind of like a Venn diagram where you have what the serverless workflow specification supports in terms of features, and the features that are supported by the tool that you want to use, the orchestrator that you want to use. And if you want something portable, it should be the intersection of those two bubbles, basically. Another aspect, the fact is that, let's say there's a special built-in function, which is part of the product that you really rely on in your workflow definition. Perhaps it's not standardized as part of the specification, so making your workflow definition essentially not portable. The other thing I'd like to mention is the fact that you may be using REST indeed for your services, but perhaps you're not using OpenAPI specifications to describe your services. And the fact is that the serverless workflow specification relies on OpenAPI. So you would have to go the extra mile and define the whole API contract in the shape of an OpenAPI document for your service contract. Now let's introduce you to Google Cloud Workflows. So Google Cloud Workflows is a way to orchestrate and integrate any kind of APIs. As I said, it can be APIs or services that are hosted on Google Cloud, for example, serverless products like Cloud Run, Cloud Functions, Google App Engine. You can also call APIs, any Google and Google Cloud APIs, because all those services, all those products expose some REST API. But you can also call external APIs on other cloud providers, on premises, as long as it's reachable through the internet. Any API can be orchestrated. How it works is, so let's come back to our example where you have a process with a payment processor, a shipper service, a notifier service. That's three steps, three sequential steps here. And you would define that with those three steps, those three lines: process payment, ship items, notify user, in the YAML definition file. You can use YAML or JSON syntax. And then this first step would call, for example, here it would be a Cloud Run service, but could be any URL. You can also pass some data. So for example, here I have some payment details coming from perhaps the argument of the workflow of some other variable in the workflow. Then this service is going to return a response. So you can put the response into this variable here. Then in the next service that is also called with the HTTP post, the URL, etc. In input, you can reuse the output of the previous service. So for example, perhaps I need process result.body.order.customer.address, for example. Here I just use the body, the full body, but it could be just specific parts. There's a syntax for accessing parts of the body of another service, and so on. Then you sequence, those steps are going to be called. But they are, so step sequencing, that's really what I've just explained. What else can you do in your workflow definition? You can introduce some poses. For example, you know that some service may take some time Perhaps you're going to introduce a 1 minute pause because you want to wait a little bit to ensure that the shipper has really finished getting the order ready for shipping. Variable parsing and JSON passing and JSON parsing, that's what I explained. You can really pass data between different API calls. And let's say the payment processor sometimes fails or you have to retry. So you could specify at the workflow definition level and on a per workflow basis. So different workflows may have different requirements or configuration for retry, back off, logic, etc. So for example, I know that sometimes it fails. So perhaps I'm ready to retry 5 times before abandoning. I can define a backup strategy. For example, I'm going to retry in 1 second, in 2 seconds, 4 seconds. Can define a multiplier, for example. Also, you can take care of exception handling or error handling. So for example, if the shipper service fails and returns some 4 or something or 500 status code, perhaps you're going to go into an error branch of your workflow, and then you're going to call the pager of the support team or the SREs working on your system. If it works great, if it's successful, then you're going to call the notifier service, which notifies the customer that they are going to receive their order. And beyond just the error exception handling and such, you can also have branches, I would say normal branches, a bit like if then else kind of blocks or switch instructions. So you can, for example, call the inventory database and say and ask if the product is still in stock or not. If it's not out of stock, then you can ship the order. If it's out of stock, then I'm going to branch into another step, another branch of my workflow to request from the supplier some new parts for my order. Then I'm going to update the inventory, etc. So you can really have some business logic with if then else that checks what's what's returned by previous service calls. For example, a read inventory would return, okay, a number of items, 0 out, then I need to call the supplier API. So you check from, with some rich expressions, what's inside the responses of the previous API calls. Other useful features I'd like to mention, sub-workflows. For example, when you have parts of your workflow definitions that are common, that you reuse several times, instead of jumping back to them or something like this, you can define sub-workflows, which is pretty much like a function call, a procedure call, a method call. You would just reuse and put that in a sub-workflow. That's the name of the feature, but that's a good name. You would reuse and call that sub-workflow at different parts of your main workflow definition. The other thing I'd like to mention briefly in passing, it's still in beta right now, it's connectors. I mentioned that you can call any Google API or Google Cloud API with their REST interfaces. But for some of those APIs, some of those services, there are dedicated connectors that exist. And what's nice with that, so it simplifies the call syntax a little bit, but what's more interesting is how it handles retry or waiting for the execution of an operation, a particular operation, a long-running operation in particular of that API. Let me take an example. If you want to use workflows to automate your IT infrastructure, your cloud resources, for example, starting or stopping a VM, a compute engine virtual machine, for example, it can take quite a bit of time. And in order to ensure that you wait for the VM to be stopped, instead of polling and checking, so is the VM stopped? Wait 5 seconds. Is the VM stopped? No, wait 5 seconds, etc. Instead of implementing that polling logic yourself, all those long-running operations are handled automatically by the connectors. So they actually take care of waiting for long-running operations. So other examples could be database imports or things like that, which are operations that take a while. So connectors are a useful feature. What else? If you use the command line on the gcloud SDK, you can use the gcloud workflows commands with the deploy, execute, and describe subcommands to deploy a particular definition file and check for the particular execution ID of a running workflow execution. And you also have at your disposal in the Cloud Console this UI. So you write your YAML definition on the left, but there's also a nice visualization on the right, which shows the various branches and steps in a visual fashion, which is great because sometimes for authoring workflow definitions, it's a YAML file, so it's not necessarily easy to see where you're going to go next in the workflow. So having a visual representation can be pretty handy. So I thought that was me, but or perhaps I went too far.
Maybe I'll take over this.
Yeah, okay, let's do this.
So let me see if I can share my screen this time.
Sorry, it took a bit of your slides.
Sorry. Hopefully you can see my slides.
Yes.
Okay.
Yeah, it's fine now.
Cool. So I learned how to share a screen in places, so that's good.
That's
cool.
The session right there.
All right. So after seeing all the theory behind choreography and orchestration and pros and cons, and talking about Google Cloud workflows, now let's actually finish off the presentation by looking at a case study about an application that me and Guillaume, we actually wrote initially using an event-driven architecture. And then later, when workflows became available, we rewrote that in an orchestrated kind of approach. And the things that we kind of learned along the way. So that's what I want to cover here. And then, so I will show you the app and I will talk about the different approaches. And then I think Guillaume can take over and just talk about what we learned in the end through this app. So this application, we called it Piccadilly. It's a picture sharing application. That's why it's Piccadilly. And the reason why we also called it Piccadilly is because it was for a customer in London. So we wanted to play with the name of Piccadilly Circus in London. But in this application, it's actually part of a workshop now. So if you go to this link here, there are 6 labs where you can actually build this application, and the code is also on GitHub. So all the code is open source, so you can take a look if you like. But the main things about this application is that users upload some pictures to this app. And then once users upload the pictures, we do a little bit of analysis on these pictures, and we figure out what the picture is about using machine learning. So we extract what's called labels from these pictures. And we also extract the dominant colors of the picture, and then we use it as a border around the picture. So you can see that each picture has a border with the dominant color, and each picture also has some labels about what the picture is about. So this is mainly the app, and then there's a collage section where we also display a collage of pictures from the 4 most recent pictures. It's a very simple app, but the point is to show, the serverless technologies of Google Cloud to our customers and people who want to use Google Cloud. Now, initially, when we designed this application, we took an event-driven approach. And just to go through the architecture quickly, we have users uploading pictures through a front end. And for the front end, we are using App Engine, which is Google's basically solution for web applications. So the users use App Engine to upload the picture. This goes to Google Cloud Storage, which is an object storage of Google Cloud. And then once the picture is saved, that triggers a number of events. The first event goes to a Cloud function. And in this Cloud function, we analyze the picture using Vision API, and then we save the analysis to Firestore, which is a NoSQL database. The second event goes to a Cloud Run service. Cloud Run, it's a container service. So it runs containers as a serverless, almost like a serverless function, but it's for containers. So the second event goes to that. But the difference in this case is that there's no direct native event integration between Cloud Storage and Cloud Run. So we had to go through PubSub. So it's a different event type. And then the Cloud Run service, thumbnail service, will look at the image, usually big image size, and then it will try to create a smaller version of that image. It will create a thumbnail. So it does that, and it saves the thumbnail image back, and it also stores that information to Firestore. Then we have another service called collage service. It's a cloud run service, so it's running a container again that gets triggered on a schedule. And then on this schedule, it will go and ask the NoSQL database, what are my 4 most recent pictures? It will determine that, and it will download these pictures, and it will create a collage and save the collage back to our storage. And finally, we have a last service called garbage collector service. This gets triggered when an image is deleted. So when an image is deleted, this service will be called, and it will delete the thumbnail, and it will delete the metadata of this service. And again, this service gets triggered by event arc, yet another eventing service. The reason why we use event arc here is that at the time we implemented this service, there was no event arc, so we had to go through PubSub. But then when we implemented this service, event arc came along and made things easier, so we used that. But that also introduced another format in our architecture. So as you can see, this is all event-driven. All these services, they exist on their own. They don't know about each other. They don't care about each other. And that's it, really. And it works, and it's great. But even though this is a very simple architecture and very simple app, we were already running into problems with this architecture. We were already, for example, when someone uploads a picture and something doesn't work, we were already kind of lost, like where this failed. So what we would normally do is that we would basically start looking at the logs one by one and see, okay, did image analysis work? Yes, it worked, great. Then did thumbnail service work? No. So we had to kind of basically guess where things might not work and then look into that service. Similarly, these eventing formats, we had 3 different kinds of events. We had the native Cloud Function events, PubSub events, and Cloud Run events. We had to handle these in our code. So you can see these 3 different event formats and how we handle them in this Node.js code. In Cloud Function, it's a straight event that you get, which is great. In PubSub, you get a PubSub message that has the actual cloud storage event that's wrapped into base64, right? So what you need to do is you need to look at the PubSub message. You need to get the message data of the PubSub message. Then you need to base64 decode it, and then you will actually get the file event. And then with the event arc events, you get a cloud event, which is another block. So that's a different format that you had to deal with, right? So you can see that this was getting quite complicated. That's when we started looking into orchestration. And at the beginning of the year, workflows became GA. And we said, okay, why don't we take this app and convert into a workflow, basically, in an orchestrated kind of approach. And in the end, we came up with this architecture. So when you look at this, you might be thinking, oh, this looks even more complicated. It does look like that, but actually, in reality, it's simpler. The reason is all this flowchart that I'm showing here, it's actually one service. It's Google Cloud Workflows. So Google Cloud Workflows is doing all this work, but we are just giving you the detail here with the flowchart. So you can think of all of this as one service. So in this approach, the way it works is that the users still upload the image to App Engine frontend that triggers the event just like before, and that event gets to a cloud function. So this event is either file creation event or file deletion event. And this cloud function, it will basically start the orchestration. So it will make a call to workflows. And now we're in workflows, then workflows will decide what kind of event this is. So if it's a deletion event, then it will do the image garbage collection and also the Firestore garbage collection. So all this is done within workflows without having to write the code. It's just the YAML that we define. Then if it's an object finalize, meaning a new image, then workflows makes a call to Vision API. Again, we don't need a cloud function for this. Workflows will do that directly. Then we need to transform that a little bit, what we receive from Vision API. So for that, we use a cloud function. Then workflows will determine whether the picture is safe or not. And if it's safe, it will save it to Google Cloud Firestore. And if it's not safe, if it's safe also, it will do the thumbnail call and the collage call. So it will make the calls to Cloud Run services. So as you can see in this approach, we are kind of doing a little bit of, some of the work is being done in workflows. like, for example, image garbage collection, vision API call, things like that is done within workflows. But then some of the work we delegate to other things, like, for example, for thumbnail call, we just call the thumbnail service, and for collage call, we call the collage service. So you can kind of pick and choose some things you do within your workflows, and some things you can delegate. So this is it. And I actually, before we get into the lessons learned, I think we still have 10 minutes. So I want to maybe show you the app. So this is the app. And if I want to just upload a picture, I'll just upload a quick picture and just see how it looks like. So let's say I am uploading this picture, submit. Then this picture is being processed. And then if I refresh, pretty hopefully, if things work, this should update the image. But we can actually take a look. So I can go to my Google Cloud Console. I can look at workflows. And you see that I have my workflow definition here. And you can see that there's this execution that's active, that's running, that triggered our workflow. And if I look at the source, you can see the source of my workflow. It's all YAML driven. And then you can also get a visualization of our workflow, how things work. So this really helps to understand what's happening. And if you go back to executions, it's still active. But if you look at a successful execution, you can see what the input is, and you can see what the output is. And you determine what this output should be. So here, what we are using is that we are basically calling each service and getting the HTTP status code and combine it together into an output. So you can see how everything is like very nice, and you can see the executions. And if something goes wrong, you can click on the execution. You can see the steps where things failed. So this really made things much easier and clear for us. So I'll just stop here for now, and I'll let Guillaume explain to us in more detail about the lessons learned in the last 10 minutes of our presentation. So I'll stop sharing.
Thank you. So let me share again. All right. So yeah, in terms of lessons learned,
Guillaume,
we're seeing
yeah.
The chat. Sorry, wrong. So let me stop. Where is it? Stop share, wrong share. Okay, and share again. That should be this one.
Yeah.
Thank you. So yeah, lessons learned. So what was great was that we were back to using RESTful services, and the handling of REST APIs. It's quite refreshing compared to the various eventing formats that we had to use. Although, I mean, there were some good reasons for each of those eventing formats. But still, that was nice to have just one way of handling that. Also, what was pretty cool is that we had less code ultimately. So as Mete explained when he was showing the diagram with the architecture and the workflow underneath, some of the, for example, the garbage collection service vanished away because it only contained actually declarative calls, API declarative calls. So we got rid of just those bits of code which were calling those APIs directly, and instead we just encoded them in the YAML definition file. Basically, we didn't have to do even parsing. We were just fetching the body of the API call response and just parse that as JSON document. Basically, there was also less setup. So just the setup for cloud workflows, but otherwise no need to set up the pub/sub, the topics, the subscriptions, etc. No need for scheduler. One of the service, the one that was creating collage of the recent pictures, it was being invoked on a scheduler at a regular interval of time. Here we didn't need to use that because once there was a new picture available, we would create the new collage. No event arc either. So overall, much less setup to get ready and do our job, our business processes. We also had easier error handling because, so first of all, error handling was handled at the level of the workflow definition instead of at potentially each service or on the topic configuration, things like that. Also, what was great is that when there was an error in that business process, the whole chain would stop on error, and we could look at the UI or from the command line, etc., to see at which step that failed and what triggered the failure. For example, looking at the logs, etc., instead of the event-driven approach where sometimes you see potentially in the logs or in error reporting, etc., that there was a problem, but you are not quite sure what really triggered that problem, which of the parallel executions potentially led to that. So in order to do correlation between different service executions, it could be complicated with a choreography approach. Whereas here, we just have to look at this particular execution to know the chain of calls or sequence of calls, how they actually worked. The downsides, well, when we started with Cloud Workflows, Google Cloud Workflows, it was a brand new product. So there were some quirks or documentation that wasn't yet, great. So we had to fight a little bit with that. But now, obviously, 6 months in or so, things have evolved nicely, and it's much nicer to read through the documentation to figure out new things. The other thing to keep in mind is that don't try to put too much in the YAML definition file. What is really programming logic needs to be in a service. It shouldn't be in a YAML file. Okay, YAML is not a programming language, although you can do loops and whatever in the YAML and the workflow definition. Please don't do that. So be sure to make declarative calls to API in the YAML. That's fine, but it's really complicated business logic. It's probably not. It's really, I mean, the orchestrator is for orchestrating services, but it's not to removing business logic from services, right? The other aspect that is sometimes complicated, it's debugging, testing, logging, etc. When you're used to just programming, your ID is there to help with code completion, those little bubbles of help saying, okay, this parameter is doing this, etc. So it's less convenient to describe things in a YAML file compared to writing code, basically. So although you have some facilities for logging, for things like that, it's not as convenient as a programming language. Perhaps a bit of lost parallelism. For example, in the first approach with choreography, we used to have, for example, the thumbnail service and the image analysis service launched at the same time in parallel. So the first one that would finish, instead of doing a sequence and waiting for each to finish, both would be ready more or less at the same time. On the other hand, we were actually calling those two services in parallel, even if potentially the image wasn't safe to display, so we wouldn't need to create a thumbnail. We wouldn't need to store the metadata about the picture in the database. So perhaps less parallelism, but on the other hand, we also saved a bit on CPU resources. Also, potentially some loss of eventing flexibility. We mentioned when we spoke about choreography that one of the pros is the fact that it's easy to extend event-driven system, just add new events, new messages on a message broker, or subscribe to existing topics and existing types of messages. Here, you would have to revalidate your business process in the workflow definition as soon as you want to expand it a little bit. But overall, that was a really nice experience for us. And when we rewrote that application, the Piccadilly application, that was really much more straightforward to figure out when something was going wrong, seeing the visualization of the flow chart of our business process, having the ability to also version that in Git, etc. That was really refreshing for us. And well, we encourage you to actually have a look at the code of this application, since it's available on GitHub as open source, and also have a look at some of these links, which will give you some extra information about workflows, about some tips on using workflows, and also some quick starts and code labs if you want to, sorry, if you want to get your hands on those projects and products. And that's about it for this presentation. Do we have?
Thank you guys. Thanks for the great presentation, and thank you for sharing the actual experience you had, which makes the presentation a lot richer. We have a couple of questions. I'm going to try to be quick on them. We only have 2 minutes, so we have 2 questions on transactions. So one for the part where Guillaume was presenting the orchestration tool, which is how do you manage global transaction? You need to write specific compensation mechanisms on error. And the second question on transactions is, then this is for the actual project that you were presenting. So how is a transaction handled if it is failed in thumbnail or collage? How is it rolled back?
Yeah, so when I say transaction, it's not necessarily XTAted kind of transactions. And indeed, if you have written something to the database at some point at the beginning of the workflow, and then something failed later on, yes, indeed, you might have to write compensation transaction or operations to compensate some of the stuff. So it's not part of, let's say, the product itself, but it's how you define your workflow definitions that potentially, so since you can specify error handling, the various cases, how it can fail, instead of letting the workflow fail, be sure to, so we have try, except kind of blocks around API code that you can specify. So at that point, you could say, okay, so this failed, then I'm going to do the compensation as part of the workflow definition. Yeah.
Sorry, guys. We really need to wrap up.
Okay.
Thanks a lot we had another question, but I'm going to suggest the guys to contact you on Twitter if possible, or so they can get their questions answered. So thanks a lot, guys, for the great presentation. We'll be back in 10 minutes with Brian Premier with a session on Docker. So see you in 10.
Thank you. Bye-bye. Thanks for your attention.
How do you move from here to there, to that world of cloud-native architecture? I like to talk about DevOps, the concepts of DevOps, the principles, practices, tools, and techniques that you apply, and when you learn DevOps, make a fundamental difference in the way you build software and the way you deliver software faster. Red Hat fundamentally loves Linux, and that's absolutely true, but we also love Kubernetes, and we love Java.
Em 2020 e 2021 nós tivemos aí essa pandemia mundial. É claro que foi difícil para todo mundo, houve esse processo de adaptação, mas eu acredito que para a Red Hat esse processo foi até um pouco mais natural, porque os nossos processos de trabalho não foram alterados. A Red Hat já era uma empresa quase que 100% remota, ou seja, nós continuamos fazendo a mesma coisa que nós fazíamos antes, enquanto boa parte do mundo ainda estava se adaptando. E isso permitiu que a gente conseguisse expandir ainda mais a nossa área de atuação. Então, a gente trabalha muito com nuvem, a gente trabalha muito com Linux, trabalha muito com OpenShift, e com essa nossa proposta de poder ajudar empresas do mundo inteiro a fazer essa migração para a nuvem, de uma forma que seja aberta, de uma forma que seja híbrida, de modo que você possa ter a mesma experiência de desenvolvimento, a mesma experiência de operação, não importa onde você esteja rodando as suas aplicações. Eu acho que isso, acho que o fato da gente conseguir fazer isso muito bem permitiu que esses últimos 2 anos, 2020 e 2021, fossem muito bons para a Red Hat, e eu acredito, aliás, que essa tendência vai continuar aí nos próximos anos. Para 2022 e para os anos seguintes, a Red Hat está tentando algo novo. Então, a maioria das pessoas conhece a Red Hat ali pelo middleware, pelo Linux, pelo OpenShift. E em 2021, nós lançamos pela primeira vez na história da Red Hat um serviço gerenciado. Então, agora você pode ter Kafka gerenciado, você pode ter Data Science gerenciado. E eu acredito que em 2022 e nos anos seguintes, nós estaremos expandindo ainda mais o portfólio de produtos gerenciados da empresa. Então, da mesma forma que hoje você pode ter um OpenShift gerenciado na Amazon, um OpenShift gerenciado no Azure, um OpenShift gerenciado onde quer que esteja através da Red Hat, agora com esse software como serviço de Kafka e Data Science, eu acredito que esse leque vai abrir ainda mais para que você possa contar aí com a confiabilidade, com a praticidade do serviço da Red Hat em outras áreas do desenvolvimento de software. Durante muitos anos, eu tive o sonho de poder ter esse chapéu vermelho que vocês vão estar tendo aqui no fundo. E eu tentei entrar, eu participei de processos seletivos durante 2 vezes, e na segunda vez eu tive a graça de poder conseguir uma posição dentro da Red Hat. A Red Hat, como sendo a maior empresa de software open source do mundo, eu acho que a maior chance que você tem de conseguir trabalhar na Red Hat é participar ativamente dessas comunidades de open source. Então, se você olha um projeto interessante, um projeto que seja mantido, ou que a Red Hat apoia, se você puder colaborar com esses projetos open source já antes mesmo de tentar alguma coisa no Red Hat, abrindo por request, ou ajudando na documentação, ou fazendo algumas apresentações sobre o assunto, trabalhando tanto quanto usuário, como, quem sabe, até poder contribuir código com esses projetos, acho que é isso que ajuda a maior parte dos engenheiros a fazer parte da Red Hat. Porque quando um time de engenharia tem alguma vaga para trabalhar num projeto, quem que você conecta primeiro? Primeiro você pergunta para os seus amigos. E depois que você consultou todos os seus amigos dos amigos, os próximos são as pessoas que já estão trabalhando com você no dia a dia, na comunidade, só que do outro lado, não como dentro da empresa, como fora da empresa. Então, eu acho que participar de projetos open source que o Red Hat contribui, eu acho que é a melhor forma de você poder conseguir essa vaga. Que o mundo agora, quando a gente fala de nuvem, o mundo adotou Kubernetes como plataforma. E é muito legal a gente poder ver que o OpenShift, que é a plataforma de Kubernetes que a Red Hat oferta, é líder do mercado. A grande maioria das empresas que estão trabalhando aí nas grandes empresas estão utilizando o OpenShift como uma distribuição de Kubernetes. Mas não é só a plataforma que está rodando, eu acho que a ferramenta de trabalho, eu digo, o framework que você tem que estar utilizando para rodar em cima de Kubernetes, também tem que ser algo otimizado para esse mundo novo de Kubernetes e de nuvem. E é por isso que eu fico muito contente de ver o Quarkus, que é o novo framework Java que a Red Hat lançou aí há alguns anos, está atingindo um nível de maturidade e adoção bastante significativo. Então, se você é um desenvolvedor Java do passado, que está acostumado ali com consumir um monte de memória, demorar um tempão para iniciar, demorar um tempão para recompilar, fazer o build, isso aí é tudo coisa do passado, porque nesse novo mundo do Java, no Kubernetes, na computação em nuvem, graças ao Quarkus, a gente vai continuar a poder sendo desenvolvedor Java nos próximos 25 anos. Eu acho que eu vou poder me aposentar como um desenvolvedor Java e eu acho que é graças ao Quarkus.
In general, the engineering team is here to use technology to our advantage to create a great product, but also to do so in the fastest way possible and launch new features as fast as we can.
Talkdesk is an enterprise-grade contact center platform.
We help building a more comprehensive view of the customer, use that data, make the right decisions, and get great interactions between customers and people.
Building a great product and using great engineering best practices is the core of the business and not something that comes at the end.
The product is being built here in Portugal with amazing engineering team we have.
We strive for our teams to be multidisciplinary with all needed skills for the team to develop their product end-to-end on a truly open source environment.
Welcome back, everyone, to the Almedina track. We now have a new speaker, and it's the only speaker that actually spoke at multiple Jnations, but never on site in Coimbra. So, Brian, we need you there next year, man.
Yeah,
I'm
absolutely.
really hoping for that. So we have Brian Vermeer, is a developer advocate at SNIC, Java champion, and jug leader of the Virtual Jug and Netherlands Jug, if I'm not mistaken. Correct me if I'm wrong, Brian. That's a very long curriculum, man.
You're absolutely correct.
It's going to be presenting a session on Docker and security. So I really hope next year I can tell you the stage is yours, but for now, the stream is yours, Brian. Go ahead.
Thank you so much. And yes, I hope to be back next year in real life, to be at the third time. This is my second time, hope to be the third time we'll be on site again. And I can see all your lovely faces again, because doing this virtually is cool, but doing this in real life with real people and having conversations after that, that's the most valuable thing ever. But before I'm going into my presentation, I have to talk to you about this, a container. I mean, what is a container, right? If we think of a container in the real world, a container is something that holds goods or is a receptacle that holds freight or something like that, right? It is a abstraction, and there's something in it that you need to protect from the outside world. That's basically what a container is from the real world. So a container can be anything from your soda can or your beer can to the airtight container that you put your food in to store it and save it for the other day or the other week. However, if we think about containers and you see all the graphics when people talk about containers, we most of the time think about these shipping containers. And these shipping containers, of course, you can use to transport your goods from point A to point B. But every one of these containers is there for a reason. For instance, the soda container or the beer container is there specifically to get your liquids in and to preserve the flavors and make sure that the bubbles are in. And the same holds for the airtight container. The airtight container is there to have that protective barrier from the outside world, so your food stays good, healthy, and tasteful. For the shipping container, it's pretty much a bit different, but again, you put your freight in there, you put your goods in there to get transported from one side of the world to the other side of the world and make sure that it doesn't damage and it comes there in a good condition. So we can say, again, it's a protective barrier to make sure that whatever is there on the outside world cannot interfere or cannot connect with the inside of the container. So naturally, there is a misconception about containers because people see these software concepts like containers and they translate them to things in the real world. But it's not really true, because the point is, well, some things are true. For instance, you have to pick the right container. Think about it. If I put my beer in the airtight container, that kind of makes sense. It might work. But if I put my beer like without the can in the shipping container, that doesn't make sense at all, right? So you have to pick the right container for the right purpose. But there is another thing. People have that misconception that if I put something in a container, by default, it is safe, or because of that layer of abstraction, we are safer or something like that. And that is absolutely not true. Say we have a container containing a Java program. And yeah, of course, I put the airtight container in. But you know, if I put Duke in there, he will not survive because it's airtight. However, if we look at this from a perspective from a computer science container, we need to have interaction with that container from the outside world to the inside and the other way around. So instead of having only the protective barrier, it's basically a container with holes in it. We need to connect from your program to, for instance, a UI to a user, but also connect to a database and have that data back in your container. So that means there are holes in there. So it's not the same as the container in real life. And putting something in a container doesn't by default make you safe. And I will help you with that today. But first, this is me. And you see this picture is before COVID. I grew a beard. I have longer hair. And I am dying to get outside again and hopefully get some tan that it's not from these lights over here. You see, I'm a developer advocate and engineer for Sneak, and I do a bunch of stuff in the community. I'm a Java champion. Already mentioned, do some stuff for virtual jugs or for jugs. Do something on DevSecOn, which is coming up next week. This is pitching. I know. Anyhow. Let's get into the containers, because let's specify this in Docker containers, because containers is more than just Docker, but Docker is by default basically the de facto standard nowadays. You agree? Well, if you look at how many Docker containers are downloaded on a weekly basis, it is tremendous. It's amazing how many Docker containers are used, and they are just loaded from Docker container and used to create your own container. And that is good. I mean, it's a good resource, but there are some pitfalls, and I'm going to help you with that. And basically what I'm going to show you is 5 basic tips not to fail your security on creating Docker containers specifically for Java developers. First, of course, I already told you, like with the real life container, you have to think of what container do you pick for what purpose. Getting your beer into that shipping container doesn't make sense, remember? So choose the right Docker base image, because the base image is what you build your stuff on top of. Because if you look at a Docker file, if you build a Docker file, the first line is something like this: from Ubuntu, or from Debian, or maybe even from Node, or from OpenJDK. What happens is you download that image from Docker Hub, or any other resource, of course, but yeah, let's say Docker Hub, and you use that as your foundation to build your stuff on top of. And that's absolutely fine. But do you have any clue what you're getting into? Do you have any clue what you're pulling into your system? I did a research in 2019, and that's called, that report is still on the Sneak website. It's called Shifting Docker Security Left. And what we did was we downloaded the top 10 Docker images from Docker Hub, and we scanned them for vulnerabilities to see if they come with issues. Well, this was the result at that point in time. And of course, that was like somewhere 2019. But the point is, I wasn't aware of this before I did this research. You get me? I mean, you see all these 10 images, and all these 10 images have vulnerabilities. But if you look at these images quite closely, first of all, what I did was I downloaded a Docker container, just the latest. No special tags, no special hashes, just the latest at that point in time. So if you do that again today, the numbers will be different. Absolutely. But what we can see is if you look into these images, that most of the mistakes or most of the security issues come because this image, like the Node image or like the HTTPD image, is based upon another image itself. And that is most of the time a full-blown operating system like Debian. And if you have a full-blown operating system like Debian, it brings a lot of binaries into your system. Then you have to think of, do I actually need them? Do I actually need all of these executables and all of these libraries that come with a full-blown operating system if you're just running a microservice or a small program inside a container? Probably not. And if you look at the node image for this instance, it says 500 something, and these 500 something problems were not so much to Node, but at that point it was based on Debian Jessie. And the Debian Jessie was already a kind of bit outdated, but it was still the latest image of Node. And you inherit it like in a second level. So if we look at vulnerabilities on operating system images, we see that it makes a lot of sense to pick an operating system or to pick a base image that is based upon an operating system that is suitable for your needs. I'm not saying that you always have to go with Fedora or Alpine, because they are very slim, tiny operating system layers. Maybe you do need something more, but we have to take care of that. Like, what do you need to pick? What do you want to pick? And what are the consequences of that? But just because you saw something on Stack Overflow and it says, hey, just from latest image of OpenJDK, that doesn't always make sense. So if we translate this and you see that, for instance, if I took a full-blown Debian system and translate that or switch that same image out for basically the same image for instance, OpenJDK to one that is based on Ubuntu or to Debian Stretch Slim, it already reduces the amount of risk that I have. Because although we're not sure that these binaries can be hit or can be directly hit, most of the security issues are not so much a direct hit. They are a chain. So somebody gets in, finds something, connects that issue to another issue, to another issue, to another issue, and then it explodes. You get me? So it's not, most of the times it's not a direct attack. It's indirect, just like these problems are. If we translate all of this to, for instance, the stuff from our dear friends of Adopt OpenJDK. And spoiler alert, the JVM report is coming out in a few days, maybe next week. And Adopt OpenJDK is one of the major JDK builds that is out there, used by a lot of people. And so are the Docker images. And if you see that, the latest image by default is built on top of Ubuntu. But if you want to, you can choose a Debian image. But if you don't need to, maybe it's wiser to choose an Alpine image. And then you say, yeah, all these things that are there, what can possibly go wrong, right? I'm having my Java application is steady. What can possibly go wrong? Well, I will show you in a minute because I'm going to talk about this vulnerability. It is an improper input validation vulnerability in a package called ImageMagick. And ImageMagick is part of the Debian distribution. But this is, of course, an old thing. But if your application is connected in some way to something that is there on the operating system, either a program or a library, then things can go sideways because they are connected. And this one is connected, and in such a way, this one was so heavy that they called it Image Tragic, which I think is funny because of the name. So let's get into that problem. I have let's go over here. I have a Docker image, and my Docker image, it's running here on the background. You don't need to see that. I just did a Docker compose up, and it's there. And let me enlarge this one. Let's go into this Docker image and see what is there. So I connected to this Docker image, and if I just see what is there, you see it's a very, very small Node.js application. Now, why did I do that? Because it's fun to make. Well, no, because this is a Java and JavaScript conference and not just Java. But you see it's a small Node.js application. There's nothing really going on here. And that run is running in this browser. And what it does is quite easy. I can choose a file, I can choose an image, and it will resize that image to an image that is a good size for a Twitter picture, because Twitter resizes it already. So I can't do that before. And what I do, you see, I picked my picture from DevSecCon London and I reduced it to a perfect image size for Twitter. Nothing more, nothing less. And I'm using ImageMagick in the back to do this. But there is a problem with ImageMagick, and it's not so much my application, but I'm relying on this, well, executable or application that is part of my operating system. If I go back and I do this again, and I will upload another image, but let me show you what that image is. So let me go. Am I in the right one? Yes, I'm in the right one. So what if my image looks like this? Let me enlarge this one. And you see what's happening. It's not your typical JPEG image, but this is possible in ImageMagick. I'm just can describe a few things, like similarly like I do that with an SVG image. And I can create a view box. And in that view box, I can relate to a JPEG in another URL. This is perfectly valid. The only problem is, because ImageMagick doesn't do proper validation, I can break out of this by this pipe and say touch RCE1. So basically what I'm trying to do is I'm trying to upload this image, break out of the searching for this JPEG, and try to create a file in my Docker image. Just to be sure, this was the thing, and RCE1 is not available here. You got me, right? You see that. So going back to the thing, getting RCE1.jpg, it's there. I resize, and no image is there because we broke out of it. But it did execute the statement that is there in that application. So if I do an ls-l over here, you see that I created a file in my Docker image, RCE1. And that is because I based my stuff on top of an image that is quite old. If I reduce that to, for instance, an image that is newer, or maybe I don't even need ImageMagick, then I would not have this problem. Moreover, now I forgot what I wanted to say. The point is, make sure that you have the least amount of resources in your base image that you pull in, because it's not only making your image bigger, it also gives you a lot of new attack factors in your Docker application, in your Docker-based application. And this is not specifically Java, but it's very keen to. It's something you have to be keen on while you're programming for Java anyway. All right, let's continue. Yes, we had image tragic. That's interesting. So basically what I'm saying is that we only need to use what we only want to use what we need, right? Don't get more stuff in because it will pile up. The image will get bigger. But if you look at for instance, Stack Overflow, you read images about how to start with Docker. Basically what you see is kind of this. Like, I have a project, maybe this is based on a Spring Boot project, and this is my Spring Boot project, and I want to Dockerize this. If you look at a bunch of blog posts, you will see this. And this perfectly works, right? I'm basing my image on top of a Maven 3 OpenJDK 11 image. I copy all the source files that I have. I create a work there that I will put as my base directory. I will Maven package, and I will skip the test, and I will just use the Spring Boot plugin in Maven to start my application. Oh, it must be Spring-boot and not Spring /. But you get me. However, this image for my thing I did was a very small Spring Boot application that was 800 something megabyte. And I know Spring Boot already brings in a lot of stuff, but most of it was because I'm having a lot of stuff in that I don't need. Do I need, in my production image that I want to put on my production server, do I need Maven? Do I need source code? Do I need the JDK? Like, getting back to old school Java, what do you need? Like, we're building a JDK, or we're building a Java application based on a JDK. There comes an executable out of that. And either if you run on a web service or within a Docker container, if you're running Pajara or whatever kind of web server, or maybe old-fashioned JBoss, you're just putting in the jar or the var or the ir, the artifact that you build. So you don't need all the crap around that. That's just for building the stuff. But say I want to build in a Docker image, I can just separate the two. I can build an image and compile and do all setups in a Docker container if I want to. But then I want to transfer it to a production image that only has the necessary stuff that I need. Luckily, within Docker, there is this multi-stage build thing. And it looks a little bit like this. So instead of the first 5 lines, I refer to that for the first few lines as an image, and I call it as build. In the second part, as you can see, I refer to that build. So what I'm doing, line by line, I'm getting that Maven image. I'm doing the same thing as I did before, but I'm running Maven package, because then I have the artifact. That's all I need. Then I create a new image, and I base that one on an OpenJDK Alpine Java runtime environment, because that is all I need. And yes, if you want to have more tooling in, then you should be adding that as well. but don't put a full JDK in because most of the time you don't need that. But pick an image that is appropriate to you. Alpine JRE was perfectly for my thing. So I create a file. I just copy the stuff from the target directory. Basically, I'm only copying my jar because that's the only one I need. It's a Spring Boot application. It works out of the box. And what I do then, I just call that Spring Boot application by a simple Java -jar, and it runs there. The build image is separated from the production image. That means that only the production image will go into production. First, it was 800, almost 900 megabytes, and now it's about 198 megabytes. So that's already saves me time when uploading the stuff, when putting the stuff over the wire to maybe another pod, to spin it up. You got me. Moreover, it also helps me prevent unnecessary binaries in my application. The other point is, if we need to insert secrets in a container, you want to separate that because that's the build stage. And I made a small application over here where I say I need to connect to a repository and I'm using command line separators to get a username and a password in. I can perfectly do that in my build image because that build image will stay behind. Only the production image I will put into my production image, into my production environment. So if I need secrets or other things, I can do that perfectly in that build image because there is not a trace in the production image that links back to these secrets. If you don't do that, we can look at the history of a Docker file and we can actually retract these things because they're part of the cache and how you build up that image. So using multi-stage builds, only what you need. So in this case, a Java runtime environment is only what I need in production. This already separates the stuff a lot and will get me a lot safer. Next one. The least privileged user. Well, let's get into the least privileged principle. What is it? Basically, what I'm saying with the least privileged principle is we only get access to what we need, nothing more, nothing less. So we only get access to what we need because we need to use it. If you don't need it, you don't have access to that. Think about it. If you go to a hospital and you have some sort of rare disease, you only probably want the nurse and the doctor that is treating you to know that, right? Not the other nurses, other doctors, every patient in the hospital, and maybe even your insurance, because if your insurance knows what kind of things you have, it might increases your fee that you have to pay monthly. Same holds with privileges for users. Because what happens is, if I have a Docker image like this, I have the least amount of resources in it, but by default, a Docker image runs as root. So the point is, I don't want to have this in. I don't need to run my application as root. Because if I can run as root, I might be able to connect with that with an SSH tunnel and do all sorts of other stuff with binaries that might be there or might not be there, or install new stuff and do all sorts of weird things. So let's get to that second part, that production image. That's what we need. For the production image, I just add a few lines. Just do it, like bam, adding a few lines. Like, okay, what did you do? Well, let me light them out for you. These are the lines I did. And remember, this is an Alpine-based image, so it might be different if you're doing this on a Ubuntu-based image or a Debian-based image. But what I'm doing is I am creating a system user. I'm creating a system user with no home directory and no shell access, and I'm adding that in basically the third line of my build image, or of my production image. Then I copy all the stuff, and then I give that new user that I created, I give it ownership of that project folder that I need. It only needs that folder. It doesn't need to go in or out of there. It just needs to go into the project folder and might be able to create new folders over there because I need to upload things, for instance. So creating a new user that has less privileges is key over here. But then the third line is, I think, the most important one, because just creating a user doesn't make sense. You have to call it as well. And that's what a lot of people forget. Because of the third yellow line, user Brian Vermeer, I'm calling that, and single thing I do afterwards is run by that specific user. But think about it. if you're using, for instance, an image like OpenJDK, and I know for sure, for instance, the node images by default already have a user that has less privileges than the root. It might be suitable for you to run that, to use that. Only you have to make sure that you call it before you actually execute your program. So calling that user is essential, or else it will still be running as root. But you get it. Now I'm not root. I can do less harm. I can basically not go into certain things I don't need to, only the stuff I need for my application. And that is something that is just as essential as not having all these things in. All right. I told you about the base image, right? I told you already about the base image, and in the meantime, I did on the background, I did a scan just to make it interesting. Let me check over here. It was this one or this one. Yes. What I did over here was let me scroll all the way up, and what I did was I used our tooling, our Sneak tooling, to do a test on the Adopt OpenJDK base image. That was one of the first images I called you. And what it does, it just gets the image from the internet, and we can scan that image and see if there are vulnerabilities there and what are the vulnerabilities. So for instance, what we see is that this one has 26 issues. And this is the latest one, is based on Ubuntu. If I do, for instance, the Alpine one, it will be less or more, of course. But now you have a good insight if I want to use this image in the first place. I can do this with my image, with my own images as well. So if I do a Docker image ls, I will have, let me see what I have over here. SG1 is one of the images I created today. So I can create images. I'm not sure what's in that image. SG1 or C container test SG1. Let me just do this so you actually see it. And it scans my custom container. And it can scan for the operating system, but also for extra binaries that I add. And what it sees, it looks at the image, and I can also connect the Docker file if I have it, so it can give me remediation advice. But that's super helpful for building your image from the get-go to make sure that it's safe and sound. Well, this is going on. I already did the other one in the background, but there is tooling available, and I'm using my tooling, of course, but there's more tooling. But there's tooling available to know this on forehand. For instance, if you go to Docker Hub, and you do the Docker, you have a Docker Hub Pro account, you already got some of this information from the get-go because Docker implement that already. Sleek trick, that information comes from us. Anyhow, you see that I'm using critical severity vulnerabilities on GC. Well, you got it. And then you have to make sure, like, is this the base image that I actually want? Because it's based on Debian 10. I don't need Python. You get me? So this all you don't need. Get rid of it. All right, but scanning your application is one thing, or scanning your Docker container is one thing. We also have to scan our Java applications because most of the time the application is the entry service. But let's get to the Docker container first. If we ask people, and we did this research in 2019 again in the States of Open Source Security, and we ask people, when do you scan your Docker images for operating system vulnerabilities? Unfortunately, half of the people don't. Well, which is on the bright side, half of the people do, but you get me. It's something that is not one thing that is straight on our mind. And I already showed you that I can pull a Docker image like this, a Docker pull, in this case, latest, and I can just scan it, and I just showed you that we have some kind of result like this. I can do it with my own image, like I showed you, and I can attach the Docker file or the place where the Docker file is, and it gives me already the information in my screen. If I do a Docker monitor, like on the second line, it will take a snapshot of that point in time, and it will bring it to, in this case, RUI, and it scans it over and over again on a daily basis. Because if that thing is in production, there might not be a vulnerability now, but that might occur like tomorrow or the day after. So you want to know, you want to stay on touch of that, you want to repeat that ever again, and you don't want to do that by hand. So Monitor is a solution for that. But then you come to your own application. And if this is your application, think about it. How much of this application is the code you wrote yourself? Think about it. It's probably this. Because, hey, we depend our stuff on frameworks like Spring Boot or Quarkus or whatever you're using. And these frameworks containing, well, libraries, and these libraries containing more libraries underneath and more libraries these depend on. So it's several layers deep. We include stuff from the internet, or basically open source stuff, that we do to make our life easier. We do not want to do yet again another REST endpoint, or yet we do not want to create yet another CRUD repository. That heavy lifting needs to be done by libraries, because we want to focus on business logic. But think about it. Your code, we probably have some things in place, like code reviews and maybe some automatic QA, maybe pair programming. So we take a lot of pride in that. And no code goes into production before actually, say, 3 or 4 people saw it. But what about all the other stuff that you include? How do you handle these? Did you just blindly include them because Stack Overflow told you so? Or did you include them like a year ago? How do you update them? How do you stay keen on that? Because most of the problems, if you look from a security perspective, are not so much in the top level dependencies, so the purple parts. If you look at Maven Central and NPM, it's most of the time in the indirect dependencies, because, hey, bringing in a Spring Boot parent and your Spring Boot web or something like that, or MVC, gives you a dozen or even hundreds of packages that are there and are available in your class path. So what can go possibly wrong with my application? Well, yet again, I will show you. I have a Spring Boot application over here, another Spring Boot application, and this application is a very, very simple one. It is a grocery list containing beans for 50 cents, milk for $1.09, and bread for $1.50 and more. This is not really important. This is the domain entity. It's an item, and it contains an ID, a name, and a cost. Super interesting, and some getters and setters. But the interesting part is in this part. This is the repository. And what I can do with my repository, you see that I'm using Spring Data. And with Spring Data, I can extend to CRUD repository. And most of the Java developers know this is super easy, because now by naming conventions, like find by name, and just say a name will be inserted, I can do a bunch of stuff that I don't need to implement. Spring will handle this for me. Like, generically, magically, it is there. I can do custom queries like this, but the point is, with Spring Data REST, I just have to implement an interface, or Spring Data like that, and with the CRUD repository, I just have to implement an interface. And I already have CRUD functionality. With Spring Data REST, what I'm using here as well, I can add this annotation on top of my application, and my CRUD repository will automatically be transformed into REST endpoints, which is super convenient, because now I can do prototyping. My prototype is already done, and people can talk against it. Let me run this one, because I run a couple of demos already, and I just hope that this one works, that we don't have any overlap, any port conflicts. And I think it's there. Yeah, it looks like it. Cool. So let's go into the application that I just showed you, and saying localhost 8080. It will bring me to my Hell browser. My Hell browser is just there to show you what kind of REST endpoints I can call. Like, I can call item/1, and item/1 will give me the beans in my grocery list. Of course, item/2 will give me, you guessed it, the milk for $1.09. What I can do as well, I can do a search and a find by name, which was my CRUD functionality, and give it a name as a parameter, beer. So my CRUD and my CRUD functionality is now a REST endpoint. Oh, don't put a %20 behind it. Just do it like this. And you see, marvelous, it works. So this is all cool and stuff, but we're depending on a framework. And I'm not depending on a very stable version of this framework. Trust me, we wrote it. The point is, there is an issue with this framework, with specifically Spring Data REST, specifically this version, and hopefully you're not on this version again, or you're not on this version. And I will show you what the problem is. So say I'm going into this application, and let me just enlarge it a bit. Going to the exploit folder, and I prepared something for you. So what I can do is I can call some endpoints with a curl request and curl patch request, and I can give it a certain body. Because if I do a curl patch request, I'm allowed to supply a JSON body. But what if the JSON is this? And I will enlarge, I will enlarge it for you so you can actually see what's going on. And what you see is in this JSON body, I am doing a weird stuff. I am utilizing SPEL, the Spring Expression Language. And with that Spring Expression Language, I am allowed to interfere with objects that are there in my memory. And what I do over here, you see a little bit, it's get runtime. And what I do with that runtime, I execute an arbitrary command. So if I'm able to get the runtime and execute an arbitrary command, I can do vicious stuff in there. Let's try this. So let's get into the PassWD folder file, because why not? So what I'm doing here is, let me just get this, clear my screen and show it again. I'm doing a curl patch request and I'm saying, hey, it's application JSON patch. Fair enough. And I'm giving it this body. And instead of saying command, I now go to the /etc folder in my root and go to the PassWD file. However, I call this on this endpoint, and this item/1 endpoint was just there to get my first item out of my grocery list, which I assumed was just a get endpoint. But by doing this, you see that I now have the containment of my PassWD file. And if I have the containment of my PassWD file, that's not really important, but it's the start of a journey of exploring what can be done as more. I can also get the environment variables, but if I can get the environment variables, I'm also able to create files, delete files, create a file and put some scripting in it, create a file, or actually execute anything that is there in my Docker container. And there you have your entry point, because I'm using a library and I wasn't aware of it, that this library had this exploit, because I didn't test around it, because I didn't know. And again, we can get rid of this by doing something either in your terminal or in your IDE, whichever IDE you prefer. There are plugins for there to do a test also on your application. So your application service is just as important as your container service. Of course, we can go further and further and go into Kubernetes problems and that kind of stuff. But this is quite connected to each other, because in that container, you already brought a bunch of stuff that you didn't need. And now I have an attack surface. And as you can see, we can already show you what kind of problems there are. It's not really important, but we can also say like, hey, you see, I'm using 1.5.5 build snapshot. Don't use until build snapshot. 1.5.17 release will fix all these things. But you get me, if you're on the wrong version and you didn't upgrade for a while, you might be in trouble. All right, let's get back to the thing. So the point is that we need to test both our containers over and over and over again during development, but also when it's in production already. But the same holds for our application. And if we're aware of these things, and we can automate all these things. If I can do that with a command line tool, you can do that, and you can automate it in your CI pipeline. And again, not saying that you have to use my tool, I'm just using it as an example. Last thing we need to do is we need to build to rebuild. And that's a weird one. I mean, build to rebuild, what do you mean by that? Well, for instance, this is a Docker container we have, right? The Docker container containing your Java applications. And probably it's not just one container. You might have scaled it up, and you might have a cluster and multiple pods with this Java application like this. Like we have 3 or maybe 300 applications. Say you have everything in place, like logging is in place and you can actively monitor, and then you see in the third pod there's somebody actively doing something weird, or there's something weird going on. What is the first thing you want to do? The first thing you want to do is that specific pod. You want to just blow it up. You want to make sure that it's not there. And then you want to spin up a new one, preferably with a newer version of either the container or your Java application, or both. But that means that you have to start with the architecture already. If you build a Java application, you have to make sure that you just can blow it up and that you're not like missing transactions, missing data, that your customer data is now gone, for instance. That is not what you want. So things like this, like databases, and in one of my demos, I do things with an in-memory database, but that's because of a demo. But databases, things in memory, but also log files, don't put that inside the container. For a monolith, that might be fine because you're not blowing things up. You might just do it granularly. But you want to easily replace one pod with another one. You need to be aware that these kind of things need to live outside of your container. And that's, again, if you come back to the first image I showed you, we need to have connection with the outside world, and the outside world has to have connection with our application. But you need to build it in such a way. So don't do databases inside your container. Don't do caching inside your container unless you have an in-memory data grid that has automatic healing. Things like Hazelcast can be used for that. I have no stock options for them, but you get what I'm saying. Use your stuff wisely. And did you know that 44% of Docker image vulnerabilities can be fixed with a newer base image? That means that although my application doesn't have any specific vulnerabilities, by just switching out to a newer base image, we can already remediate a bunch of stuff that we already have. So deploying this, even if your application didn't do anything, didn't change, it is wise to deploy or to rebuild your application with a newer base image every now and then to make sure that you're up to date. We ask people, like, how do you find out about vulnerabilities in your deployed containers? And a lot of people, unfortunately, don't. But also, did you know that 20% of the Docker vulnerabilities can be fixed by just rebuilding the same Docker file? Using the same Docker file, rebuilding it. And why is that? Because we do a lot of this. Ubuntu latest. And you already get me, right? What is latest now is not the latest tomorrow. So by, again, rebuilding and then I'm just inserting, in this case, Python or whatever binary I have. Don't just do that. Or, well, you can do that, but then you have to rebuild this often. Even though your application binary didn't change, this can be a tremendous difference in the amount of vulnerability vectors you have. If you do rebuild, because the latest now can be different from the latest tomorrow and the latest week after that, just make sure that if you build it, that you use the -- no cache flag, just to be aware that you are absolutely sure there's no cache hit. You get me? Normally that wouldn't be an issue, but hey, do we trust machines? I'm not trusting machines that much. And then people say, like, yeah, but you can use a specific tag for a Docker image that you're basing your stuff upon. That's absolutely true. But then you have to still manually be aware of that there's newer versions out. So whatever approach you choose, it means that we have to maintain the Docker image and the Docker file in the same way as we need to maintain our application, the same way as we need to maintain our technical debt, the same way as we need to be aware of security issues in our application, we need to be aware of security issues in our Docker containers. So I gave you a bunch of stuff already that can help you building safer Docker containers, and just small things, but small things matter. Let me recap that for you. First of all, we need to choose the right base image. Picking your base image is not only sizing down your container or your image that you finally built, but also prevent stuff that you don't need. And if it's not in your container, it cannot harm you. Secondly, use only what you need. For instance, you don't need a JDK, you don't need Maven, and you probably don't need your source code. Well, get me this. Just thinking out loud. If I have Maven, the JDK, and my source code in a container, and that container is alive, and for some reason I can't get in, I can change the source code, I can recompile, I can execute, and while that container is still online, I can create a bug in it, or I could create an exploit in it. That's fun. If it's already built, of course I can decompile it, but there's no JDK there to rebuild it. There's no Maven there. So don't do that. Make it smaller, only what you need. And again, you can prevent getting secrets in. Third one, don't ever run as root. Don't do that. And a lot of other systems that run with different or do containers already have that figured out. For Docker, you by default run as root, and don't do that. It's easy just to create a new user. It's just you have to be keen on that. Then scan your applications and images on a regular basis. Not only when you're going to production, not only when you're developing, but preferably both, and also when you are in production. When you're in production, just make a snapshot of it and monitor it. I showed you the Sneak Monitor, the tools already that you can use for that. But basically what we do is you create a snapshot of that point in time, because at that point it's static, and you can just scan it over again and just connect to the sources that give you information if there are vulnerabilities known. And then build to rebuild. You want to absolutely be sure that at any moment in time, you can demolish one of your pods and spin up a new one. That will make you vibrant. You can connect, it will make you scalable, but it also, if something happens, you can shut it down and you can prevent worse. You can prevent, like if you see that someone is in and you can demolish that container, you can just get rid of it. That hacker needs to start over again, or you just prevent more harm to your system. If you can prevent that an attacker can do more harm, you actually save probably the data of your customers. These are just 5. We have more. And we did it in a 10 best practice container Java for Java application cheat sheet, which is available on our blog post. But I'm at the 45-minute mark, I see. So if there are any questions, first of all, I want to thank you for your attention. I hope you find it interesting. I hope you find it useful, at least one of these tips. Then I'm already a happy camper. If you have any questions, please feel free to ask them now, or ping me later on Twitter if you come to a question like, say, tonight, tomorrow, when you're showering, when you're in the toilet. It's all fine by me. Ping me on Twitter. That would be the best way, or ask them now. Thank you for your attention, and enjoy Jnation.
Thank you, Brian. Awesome talk as always. There's one thing that happens to me on all Sneak talks, which is, man, I always end up the sessions thinking I need to get back to my code. And I think the rest of the guys are feeling the same way, because we don't have questions. So I guess everyone is busy now trying to get to their Docker images and fixing potential issues. I really like these kinds of talks where you just do not only talk about problems, but actual solutions for problems that we all have. So kudos for that. And since we still have 4 minutes, I'm going to give you time to do the shameless plug about DevSecCon 24.
well, in a week, next week, we have DevSecCon 24, which is basically a conference that we, I wouldn't say that we own, but that we do to promote application security. And that's not specifically for Java or JavaScript or for architects, or it's a crossover. So if you care about security in general, like it can be from threat modeling to application security to Kubernetes misconfiguration, these kind of things that are all needs to be part of your tool set as a developer, I believe, then hop on. I mean, go to just Google DevSecCon 24 and you will get there. Go to the Sneak site and you probably find lots of links over there. It's free. Just hop on. Even if you have just 1 talk or 2 talks, just hop on and do that. And I hope it's useful for you. That's the only thing I hope. So that's it.
There we go. Thanks a lot once again, Brian. Really hope to have you on board next year to actually experience what Jnation is all about, and not just the virtual part. So hopefully we'll have that opportunity next year.
I hope
so.
Really hope so. I hope so too. I will do my best to create a new topic, a new talk, and so that the program committee will pick me. That is what I can do, and I hope that the gods and the governments are with us, that we can open up again next year. I am confident that we can. So I will make you this promise. I will do my utmost best to be in Portugal next year at Jnation.
Yeah, thanks a lot, Brian. So guys, if you want to contact Brian, you have his Twitter on the website. So I'm giving the guys your Twitter. I hope you don't mind.
Sure.
And
more followers, the better.
Yeah, the more followers, the better. Yeah, just influencer style. I see your reaction over there.
No. I'm not making TikTok movies and that kind of stuff. I'm just doing Twitter
Man, that's
with information
disappointing.
stuff.
That's disappointing, man. So that's a wrap. Thank you very much, Brian, for the awesome talk. So in 10 minutes, we'll have a new talk on Almedina Room. And it will be a hidden secrets about instrumenting JVMs for open telemetry by Ricardo Ferreira. So join us in about 10 minutes and hope to see you all back here. Thank you very, very much, everyone. Thank you once again, Brian.
Bye-bye.
Bye.
Comfortable? Let's start the interview. Use the flute and play a song. Why should we hire you?
You have no idea! I want to work
Experiências digitais, nós fazemos tudo o que é o digital da Mercedes-Benz Carros. Ou seja, a partir do momento em que um utilizador entra num site até o momento em que se torna cliente e, na verdade, depois de ser cliente temos que prestar serviços, todas essas serviços, toda essa experiência digital, quer seja na app, quer seja nos websites, é desenvolvida por nós aqui em Portugal. É algo que está ainda em discussão. Antes da pandemia nós já tínhamos alguma liberdade para as pessoas fazerem home office. Obviamente agora o futuro vai ser muito mais híbrido e com bastante mais liberdade. Exatamente como vai funcionar ainda temos que ter algumas discussões. O que sabemos é que não queremos ser uma empresa 100% remote, nem 100% presencial. Vai ser algo semelhante, porque para manter a cultura da empresa acreditamos que é importante as pessoas reunirem-se de vez em quando. O que vamos querer ter é um escritório bastante mais preparado para que esses eventos ocorram, ou seja, não é tanto para trabalhar no dia-a-dia à secretária, mas tanto para que as pessoas se juntem, colaborem e criem um espírito tão forte como temos hoje em dia. A nível de back-end, nós quando começámos usávamos muito o Java 8 e o Java 11. Desde o último ano para cá passámos para Kotlin e mantivemos o Spring Boot como o framework de eleição. A nível de front-end, estamos nesta altura a tentar haver uma maior standardização. Passamos de JavaScript para TypeScript e o framework de eleição vai ser Vue.js a partir de agora. Em 2022, primeiro ambicionamos voltar ao normal o máximo possível. Acho que é a primeira grande ambição. Mas 2022 vai continuar a ser um ano de grande crescimento. Vamos ter que crescer bastante mais o número de pessoas, de colaboradores que temos hoje em dia. Vamos continuar a querer cada vez mais desenvolver as plataformas futuras da Mercedes-Benz, porque todo o nosso modelo é cada vez mais digital. E, na verdade, em 2022 queremos estar no novo escritório, que vai ser no Hub Criativo do Beato. Vai ser o primeiro ano inteiro em que vamos ter um escritório verdadeiramente nosso e não estarmos no coworking. Por isso, para nós, vai ser um grande passo e uma grande mudança. Olha, 3 coisas importantes em todas as pessoas que recrutamos. Primeiro é o conhecimento que têm, pode ser um back-end, um front-end, pode ser um UX, pode ser um product owner, que tenha conhecimento na sua área-chave, na sua área base, seja adequado à sua experiência. A segunda componente muito importante é que seja uma pessoa que goste de aprender e crescer connosco. O que nós sabemos é que nesta área a tecnologia muda muito rapidamente e o que é necessário hoje em dia pode ser totalmente diferente daqui a 2 anos, daqui a 4 anos. Por isso queremos pessoas que tenham esta sede de aprender e crescer, porque a própria empresa quer que as pessoas cresçam com a empresa. E terceiro, tão importante quanto as outras duas, são pessoas que se enquadrem bem culturalmente, que tenham um fit com a empresa, que gostem de trabalhar em equipa, que gostem de ajudar os outros, que queiram fazer mais e melhor pela empresa e por si próprios. Isto são 3 componentes muito diferentes que nós tentamos avaliar ao longo do processo de entrevistas, mas que na verdade todos eles são importantes e todos eles são críticos para alguém poder entrar dentro da Mercedes-Benz I/O. Quer seja alguém acabado de sair da faculdade, por exemplo, quer seja alguém com 20 anos de experiência, estas 3 componentes têm que estar lá.
Hi, everyone. Welcome to a new session for the Almedina track here at Jnation. Now we are going to have Ricardo Ferreira presenting hidden secrets about instrumenting the JVM for OpenTelemetry. So Ricardo works for Elastic, the company that does Elasticsearch and so on. And go for it, Ricardo.
All right, I appreciate it, Bruno. Thanks for the introduction. So welcome everybody to the session. I appreciate everybody that could join us here at the Jnation conference. That's arguably one of the best Java conferences out there. And today we're going to be talking about how you can leverage some of the, well, first of all, we're going to be talking about instrumentation using OpenTelemetry. Right? So that's the first. So for those of you that are thinking of starting a project that has to do with instrumentation, I think that's going to be like some useful knowledge that you're going to get from here. But more importantly, we're going to uncover some of the, at least in my perception, some of the kind of hidden knobs that most people are unaware that they exist, right? And in my experience, they have a huge impact in how you are actually not only instrumenting, but showing your application, your JVM applications to the world via some observability platforms, right? So I think the best way for us to start, I was thinking about how I would start this presentation. And then I thought, all right, OpenTelemetry is relatively a new technology, right? It's a new project, has been around like for 1.5 years, give or take, but it is not mainstream yet, right? So it is fundamentally created, it was fundamentally created to replace Open Tracing and Open Census. And therefore, most developers are not aware of that they even exist. So what I'm going to do right now is to give you kind of a crash course, right, into OpenTelemetry. And for this, I brought you a demo that I'm going to show here right now and show you the code, show a little bit about which I activated manually, what was done automatically, so we can all be on the same page when I actually start discussing the theme of this presentation, which is the hidden knobs. After all, I have to make sure that everybody is on the same page regarding how they see OpenTelemetry. So long story short, OpenTelemetry is this observability framework that is purposes and targeted to cloud native applications, right? It has support for different programming languages, although we are going to be focusing today here on Java and JVM applications, right? And when you instrument your applications using OpenTelemetry, you're going to have probably two approaches, right? And they're not necessarily mutually exclusively. You might have project where you are using the both of them, or ultimately you're going to have to pick and choose one of those approaches. The first approach is if you consider this as your backends, the backends is how we call the observability platforms that you're going to use to watch your application, right? So the first approach is that you're going to use some libraries within your application. So in case of Java applications, you're going to put a bunch of jar files in your class path, and then you are basically going to embed this concept of an agent, right? Which can be created either automatically or programmatically. We're going to discuss this later. And then the agent is going to be responsible to write directly into the backend the telemetry data. And what we call telemetry data, it can be either metrics or traces, right? The project itself, it's supposed to support logs, right? But this is not done yet. This is something that's being discussed and developed in the community. So for the sake of what exists today, we're going to be focused on traces and metrics, right? So when you are actually going to use this approach, well, first of all, you're going to use this approach when the backend itself supports the native protocol for OpenTelemetry, right? So that's the first, right? If your backend does not support the OpenTelemetry support natively, you're going to have to create some translation layer in the architecture which is the case of using the collector, right? So in this case, you're going to have an application that is being instrumented, use some libraries, and then all the telemetry data is going to be sent to this, let's call collector. Well, his name is actually a collector, so you can call it. And the collector is going to be responsible to be this man in the middle, a broker per se, that's going to do this translation of protocols. So it's going to receive OpenTelemetry protocol and it's going to send the protocol that the backend observability platform supports. In our example today, I'm going to be using Elastic APM, right, which is an observability platform that does support the OpenTelemetry protocol natively. So we're not going to be using here a collector, right? But in the code that I brought you to here today, and this is the link of the code, I'm going to provide this link after the presentation on the Slack channel. So keep in mind that, keep your eyes on that as well. And our friends on the backstage are going to help also to share in the YouTube channel if possible. In the code that is on GitHub, there is 2 Docker Compose files. One that does use the collector, and another one that does not use the collector. So you will have examples of using the 2 approaches. So keep that in mind, right? So let's go for a quick demo so you can have a first feeling about how OpenTelemetry works, so we can start discussing OpenTelemetry hidden secrets, right? Which is the reason why we are here. So what you're actually looking here, let me filter for the last 5 minutes because I don't want to bore you down with too much noise. But what we have here is what we call, let me actually increase the font size because I'm pretty sure it's too small, right? Probably is going to be better now. What we have here is what we call Elastic Observability. It's an observability platform that is created by Elastic. And what we have here is a session called APM, which is the Center for Application Performance Monitoring, in which is shown here one microservice written in Java. Specifically, it has been written in Spring Boot. I'm going to show the code in a minute. And if we click on this microservice here, you're going to see that there's one transaction here called hello, right? So the /hello represents the transaction that we have here. If you click on this transaction, you're going to see some high-level metrics like about throughput, latency, error rate, and time spent with spend time. And more importantly, you're going to have this, what we call a timeline of the transaction. So each time, this is a simple hello world. Like if I call it, let me call it right here. You're going to see that basically what this microservice does is expose it on the port 8080/hello. It basically says hello world, right? Of course, this is hello world. And then, but each time this endpoint is executed, this whole transaction is executed. And as you can see here, it's very, the word here is observable, right? It's very descriptive, right? Because you can see that, all right, this is the entry point of the transaction. And then after this, this is the endpoint of the method on the Spring Boot application that I've created that was called controller. The class was controller, and then the method was hello. And then after that, within that context, I created 2 span child spans, right? One of them was created kind of automatically. I'm going to show him. And the other one was created manually. So let's discuss this now, right? So how do I create this build response here span somehow automatically? So let me show the code for a second. So this is the code of my controller. As I said, this is Spring Boot application, plain simple Spring Boot application. And this is the entry point of my hello method, right? So I've annotated here using the @request mapping annotation /hello. And then every time it needs to produce a response, it called this method here called build response. So let's take a look on this method over here, right? So how do I create this child annotation here? Because I've used this annotation called @with_span. So every time, we're going to discuss this later, but every time you want to explicitly represent a method that is part of the transaction using Java, you can just decorate the method with that annotation. Very simple, right? Why is that annotation exist? Because sometimes you might want to actually create things manually. So this my span over here is an example of a span that was created manually. So if we look how I created this span, let's go back to the hello method, which is the entry point, right, of the endpoint. You're going to see that, right? Given the tracer, I used the span builder to create a my span, right? And then I started the span over here that I've called span, right? And then I basically executed a portion of my code that ultimately you would do something interesting for the microservices, basically just checking if the response is valid, which is kind of a dummy, but for demonstration purposes works. And then I've ended the span, right? So why is it important every time you create a span, you end the span? Because this is what's going to actually dictate the duration of that span, right? So if we look at here, we're going to see that this span specifically took 165 microseconds. So that estimate was only possible because I've created a span and finished the span, right? The other one, the build response that was created using the annotation, I didn't have to use this because the whole duration is dictated by the execution of the method. So somehow behind scenes, there is some interceptors, just like the typical Spring Boot word, that basically do some callbacks and then monitor the execution of the method and then publish this to the trace. So that's how it's done, right? And more importantly, as you can see here, I create the span here from the tracer. And how do you retrieve a tracer and the Java word? Just call this, like, let's call singleton, right? Class called global open telemetry, and then you can create as many tracers as you want it, right? The class itself is singleton, but the tracers itself are not. So every tracer, they have a state, and you can usually keep them in a very scope on your applications to be reused across the code, right? So all of this, okay, just to wrap up, all of this was only possible because, and this is all running on Docker, right? So in my Docker file that creates the image for this microservice, I basically, what I do is to grab the source code of the microservice, and then I put into the Docker image. I run a Maven build very quickly, and then here's the magic, right? I download here this OpenTelemetry agent, which is a Java agent. For those of you that know Java, there's the concept of an agent in the Java word. And then the agent is actually used to execute the jar file that represents a microservice. So that's how it is so simple for you to actually create a tracer from this global OpenTelemetry singleton object, right? If I didn't have used the agent as I've used it right now, this call over here wouldn't work. So we're going to discuss this because this itself is one of the hidden secrets, right? But just keep that in mind that in this example, for both using the collector or without the collector, I am using an agent, right? So that's what makes the magic possible, okay? Also, I am also creating some what we call metrics, right? So this is an example of a matrix. So just like I create a tracer, I can create a meter, right? And the meter, from the meter, you can create what we call stateful counters. And those counters, they're stateful because they're actually stored on the backend platform, in my case, Elastic APM. And the reason why they're stateful is that by the time you send some calls to increment or decrement the values of those counters, this increment and decrement happens on the backend, not in your application. So there's no actual state being held in your JVM heap, right? So this is how I create a counter, and I'm actually using right here. So every time the reload method executes, I'm increment and +1 the number of executions, which is the metric, right? So if we look into the observability platform, this is Kibana. So this is what is behind Elastic APM. So for those of you that are familiar with the Elastic Stack, it's plain old Kibana, right? And then if I refresh it here, and here's the metric, I'm going to filter to only show documents that contains that metric. You're going to see an example of a document that has been indexed on Elasticsearch that represent that metric. So the name of the metric is count the number of execution, and presumably where's the count? Here we go. So the current count is 357, right? So because the Hello World app microservice is being called every 5 seconds, if I remember, on a Docker Compose. Let's double check. The Docker Compose is here. Yeah, every 5 seconds, the Hello World endpoint is called, right? So point is, everything is running on the agents that makes possible for you to not only create traces, but metrics, right? So let's wrap it out over here and start discussing what actually matters, which is the hidden secret. What I have shown here, presumably, none of this is hidden. If you go to opentelemetry.io, you're going to see all the instructions for do everything that I've done here. So it is no secret, all right? So let me know later if you have any questions about what I'm showing here at this point, and I will gladly explain. So let's go back to the presentation after the quick demo, because woo, now we are all caught up. No, we can start discussing the actual hidden secret. So first of all, right, my name is Ricardo Ferreira, and I'm a developer advocate with Elastic, right? In Elastic, I'm part of the community team, and my job is basically, although not only speak about Elastic, of course, but I'd also, I'm very engaged with some other technologies that I like to talk about, like observability, distributed systems, streaming systems, and databases in general, right? So this is what I call, this is my gem, right? And in here, you can see my emails. If you want to get in touch later, my email from Elastic, my email, my personal email, right? And if you happen to use Twitter, @RifeArray is how you can get in touch, right? So with that said, let's start discussing the hidden secrets. And the first one is actually a bummer, right? Specifically for us Java developers, because if you understood the concept of the agent, right, you're going to have this perception that, yeah, it's so simple, right? I'm just download the agent, run my application with the agent, and everything else, the injection of the tracers and the meters is going to happen automatically. So I just go ahead and use them, right? Yeah, exactly. So I would say that the usage of the agent represent 80% of all Java developers going to use, right? Because it's handy, it's simple, right? And it provides you a very seamless experience in how do you work with OpenTelemetry. And the agent itself is open source, so just grab it, use it, right? You don't have to do anything else. However, and this is what I've discovered after talking with some developers in the community, you might have heard that there is this trend of Java developers building native applications, right? You name it. Either if you are using GraalVM, Quarkus, or Spring Native, those technologies, fundamentally, what they do is to kind of create a native version of the code. So ultimately, it's going to execute faster. Yay! This is what ultimately everybody wants. However, there's one catch, right? In order for those technologies to actually create the native version, they have to know upfront all the code, right? And if you recall, the concept of an agent in Java is basically to do dynamic instrumentation. So this is code that wouldn't exist by the time you actually compile your application, right? So I would say that there is a 20% of cases that you would have to leverage not only agent, but on the API, SDK, and some of the extensions from the OpenTelemetry project, right? So because of this, if this is your case, you were planning to use Quarkus from Red Hat, for example, which is amazing, but you want to instrument using OpenTelemetry, you might need to give up your agent, the simplicity of the agent, and write your code way out to build and instantiate everything that the agent does, right? Which is not so complicated. Here's an example of, you basically have to create a tracer provider or a meter provider if you want to work with metrics. And then you have to come up with something called the OpenTelemetry. Everything else in between this and this is going to be customizations that you would do, such as, oh, I'm not going to use the sample span processor. I'm going to discuss this later, but I'm going to use the batch span processor because it provides high performance, right? So the coding of this customization can take time. It is somehow boring. And if you would like to skip this whole boring, you have the option to write them manually, right? There's nothing wrong with this if you writing code. But first hidden secret is that there is this module called OpenTelemetry SDK extension. So as the name implies, it's part of the SDK extensions for OpenTelemetry that provide this auto configuration. So how this works, all the customization can be done using environment variables or Java properties, right, that you pass to the JVM. And then you simply call this one line here called OpenTelemetry SDK auto configuration .initialize. So everything else is going to kind of transverse all the environment variables or Java properties that you have passed it to the JVM, and it's going to build up the OpenTelemetry object, which is going to be a global single object that from there, you can create tracers and meters, right? So it's quite simple. So there are strategies that you can use to overcome the limitation of, all right, I'm going to run Java native applications, but I don't necessarily want to write a bunch of code in order to do instrumentation with OpenTelemetry, right? So keep that in mind. We've mentioned this before. So if you want to actually not, because this is simple when you create a span and then you can simply use the span, decorate the span, and end the span. It's not a very complicated programming, but it can be kind of a boring if you have to do for every single piece of code that you want to highlight in your transaction in the observability platform. So one of the ways is to use this @span with span annotation. So I've just shown you how this works. So at this point, just keep in mind that you have to actually explicitly introduce this dependency in your project, either if you're using Gradle or Maven. This is not part of the core or API project from OpenTelemetry. This is an extension, right? So if you don't include it, it wouldn't work. You would end up with a no class that found here. So keep that in mind, right? Also, this is kind of a more like a best practice. There will be situations where, let me put it this way, the our instrumentation is very good, right? So all the libraries and framework that are kind of compatible with OpenTelemetry will be automatically discovered by the agent, or if you manually instrumented your JVM. But sometimes there will be too much noise going on, right? Because everything was automatically instrumented. And if you happen to have an application that has hundreds of dependencies, and those dependencies, you might be like, okay, some of them might be kind of breaking the application because I've enabled the instrumentation. You have this flag over here that you can temporarily disable only the auto instrumentation, right? So what that means that all the instrumentation that you have written manually, or if you use the at with a span annotation, it would still work, right? So it's only going to disable what has been instrumented automatically. So this is kind of handy for troubleshooting purposes, right? And same goes if you want to do the inverse, right? I want to kind of eliminate all the everything that I've done manually, and I'm going to make available only what is kind of been automatic instrument. So in here, you're going to disable everything that has been generate all the spans that has been generated from the with at span annotation, right? So this is a way for you to troubleshoot things, because this happens, right? You might, specifically in your first OpenTelemetry implementation, you might see cases where, all right, after I've introduced an OpenTelemetry something or some frameworks are, because compatibility, versioning, or something else, stop from working. So you might have to have ways to troubleshoot this, right? Observability is all about making things observable, right? So how do you do this, pragmatically speaking? You have to start off by giving proper names to things, right? So in this example over here, right, when I show you the, let me go back to my observability platform and go to my APM session. So as you can see here, I have this very handy name called Hello App, right? So when this name was actually generated, because I've actually exported an environment variable that you can use called OpenTelemetry.resource.attributes. So as the name implies, you can attach attributes, and there are some conventions that the OpenTelemetry project created. For example, service.name. This is whatever you set here is going to be how your microservice is going to be shown in the backend platform, no matter what the backend platform is, right? So keep that in mind. And you can use environment variables or Java properties. It doesn't matter, right? Same goes, right? Same goes. If you are manually creating spans, as like we are doing over here, the span itself can have extra information. Making sure you are adding extra information in the span is useful, because you want to make sure that whoever is reading the code, right? Because think about this, right? Not all the time you are actually going to be the same person that wrote the code is going to be the person that actually is observing and monitoring the application. So they have no idea about what the application does and how they do, right? So as a developer, you want to make sure that you provide as much information as possible. And you can do this by using what we call the labels and decoration process. So you got to be thoughtful on that, right? So as I mentioned before, pretty much when you were talking about tracing is mapping an end-to-end execution of a given transaction, right? And for some technologies, it's quite simple to implement, right? And it's almost kind of a automatic. If you're dealing with, let's say, HTTP protocols or gRPC protocols or something that is synchronous by nature, right? So OpenTelemetry has great support for this, but there will be some situations for frameworks or technologies such as messaging brokers or things like Kafka or Pulsar. You won't necessarily have this kind of a out-of-the-box end-to-end instrumentation, because now your producers and consumers are running on separate threads or processes, right? Or even different layers of your architecture. So you got to have actually find a way to tie those services together to make sure that you're going to still see the transaction end-to-end. And the OpenTelemetry project provides this, what we call a text map propagators, right? So let's see in an example like we see here, that within this method over here, I publish a message to Pulsar, and then there will be another consumer who happens to be written in Go, right? Forget about, it's just an example, but this Go microservice is going to pull the message out from Pulsar and continue the processing. What is important here is that the producer is written in Java and the consumer is written in Go. So they're obviously running on different processes. So in the Java part, you can come up with what we call a setter, right? This is a abstract class that you basically have to provide an implementation of this callback method called set, right? So the set method basically is going to teach, right, OpenTelemetry about how to include the context that has been created in one layer into what we call a carrier, right? A carrier, as the name implies, is going to be this component that's going to carry the context from one place to another. And in case of Apache Pulsar, is going to be the actual message, right? So your set callback is going to somehow ensure that some piece of information is introduced and added to the message. Once you provide the implementation of the setter, you can simply call global OpenTelemetry get propagators, get text map propagators. This is the future that we're talking about. And then you can simply call the method inject. There are three parameters that are expected here. The context itself, right? Which is all the baggage that was created in one layer. The carrier, which in this case is the message, and the setter, right? Which is how you're teaching about how to introduce the context into the message, right? So very simple. TLDR, you just need to come up with this abstract implementation of a setter, right? In the other side, even if you had a Java implementation, you would have to come up with a getter, not a setter, but a getter implementation. Or in case of Go, you can simply do this, which is creating an implementation of the kind of a similar, like you create a implementation of a carrier, and then you have to provide callback for get, set, and keys, right? Ultimately, what we are doing here is extracting the context from the existing message. So this is how it works, right? This is very useful. So this, I have used this before, and it's quite handy when you need to use it. So as you can see, for all of us that have been using JDBC for long years right now, or JPA, you know that by default, all the parameters that are sent to SQL statements, they are actually encapsulated and keep it hidden, right, for security purposes. And this is a best practice. This is good, right? But there are situations where you want to see the parameters, and OpenTelemetry does this as well, because it is a best practice. By default, everything is encapsulated. But if you want to uncover all the values for SQL statements, just set this property here, right, to false. Oh, by the way, don't need to keep in notes about all these properties that I'm showing here. I'm going to make this presentation available. It is already. I'm just going to provide a link later. So just make sure to understand, and then you have copies of this presentation later. So you will be able to remember all these little parameters here, right? By default, this parameter is true. If you want to do this, just set it to false, right? Another one, and this is kind of a, I don't know if this is a good thing or a bad thing, right? We can discuss this later on the Slack channel, but by default, right, OpenTelemetry does not create a span every time your code create a JDBC connection, right? The reason for this, I think this is a good thing, but you tell me later. If you think about it, the probability of frameworks such as JPA or Hibernate or IBEX or whatever frameworks that you are dealing with persistency to create a JDBC connection is going to be very frequent, and it's going to be very noisy if you have to create a span. So that diagram that I've shown before in the observable front, you have lots of child lags, and it will be a little shady to see. So by default, this is disabled. But if you want to enable, right, just set this property here. Kind of, this is another hidden property. You set to true, and then voila. So if you are worried about none of the JDBC connections are being shown in your observability platform, this is the reason. This is kind of a hidden trick that you can uncover. All right. The same goes if you are dealing with frameworks that are too much noisy or shady, right? So what you can do, for example, let's say, this is not true, but let's say, this is just an example, right? The Netty framework is extremely noisy because it creates lots of spans given the out instrumentation. But what you can do is to specify some of the Java classes or packages that you want to exclude from the actual instrumentation. So you can minimize a little bit of the noise by doing this. You can specify this in a package level or in a class level, which is pretty handy, right? Another thing, let's talk about performance, right? everything in the tracing world for OpenTelemetry has to do with spans, right? So if you got the idea at this point, everything when you were instrumenting a end-to-end transaction, all this transaction is going to be broken down into an entity called a span, right? So in order for a span to end up in the observability platform or someplace else, it has to be processed. So there's this concept of span processor, right? There are, by default, there's a bunch of span processors available out there. Some of them are not part of the OpenTelemetry project, but what is default from the OpenTelemetry project is the simple span processor and the batch span processor. I would highly recommend you to prefer using the batch span processor, because the simple span processor, for every span created, it creates a network call to transmit that span to the backend, right? Not very efficient, right? What you can do is use the batch span processor, or DSP as we call it. So the batch span processor gives you ways to configure, and this setting is what I consider a little hidden because it's not so trivial, right? Most of the time you are simply using the BSP, but you are not aware that you can configure the size of the buffer, the delay that you were going to wait until you flush them to the network connection. So there's a bunch of knobs that you can turn to improve efficiency, right? And you can use this either if you're using a collector or if you are not using the collector, right? Which is in the case of a demo that I've shown before, right? The other thing also related to performance is the concept of sampling, right? So let me take some time to explain this sampling concept, right? Because this is very important, right? When you were instrumenting an application, right? From time to time, OpenTelemetry capture samples of the traces, right? Which is, if you don't configure your sample strategy correctly, you might end up with a one-on-one relationship about traces and samples, right? You don't want this. This is not very efficient because that will create too much chat in the network, in the outbound channels of your network connection that's going to be sent the telemetry data, right? Unless you want it, right? The only situation where I have seen this working is when you are actually testing the limits of your network exhaustion, right? If you want to check that, right? Otherwise, what you want to do is to create configure samples of your traces. So, because here's the thing, in order for you to come up with the idea that the average latency of a given microservice is 300 milliseconds for any interval of time, you don't necessarily to calculate the average of every single call that you have been executed. You can calculate this using samples, right? Unless you want to really make sure that you are not missing a single trace or execution from your application, right? And then you can create things like, okay, always on. So basically, this is create the one-on-one relationship that I've mentioned before, right? Let me just set up something here. Or you can simply create a parent-based or a parent-based trace ratio where you can turn the ratio of the samples that is going to be created, right? So this is something, in my experience, this is something that you often discover the worst way, right? It is not very uncommon for people to start using OpenTelemetry and find out situations like, yeah, but after I started introducing OpenTelemetry in my application, the application start to get slow, or the backend platform is not keeping up with the amount of data being generated. So this has to do with the sampling strategy. So be aware that there are ways and knobs for you to change this, right? And they are specified right here, okay? Same goes, right? Not everything, I'm a huge fan of the OpenTelemetry project and the implementation. So you probably, if you follow me on Twitter, you're gonna see that recently for the last 6 months that I've been talking a lot about OpenTelemetry. But at the same time, I am aware that OpenTelemetry is not like a 100% stable and 100% ready, and arguably it's not even 1.0, right? Although some of the releases says that 1.0, the general project's not 1.0 yet, right? So there are moving parts being discussed and refactored as we talk over here. Because of this, right, you might end up with situations where you want to debug your application, right? Because perhaps the code have changed. I have seen the situation a lot as a Java developer. Like, for example, I wrote a code, like last week, I follow an example on GitHub about how to instrument using the current state of the API. And then 1 week later, when I tried to execute the application, my logs was saying, all right, no class that found error, or method not found error. So what's happening in the application? So because of this, you might want to use flags like enable debugging, right? Because if you look the logs generated by default, the info logs from OpenTelemetry, they don't tell you much. But if you enable this, boy, you gotta hold yourself into something, because you're gonna see a bunch of code being shown in your logs, and it's extremely verbose, extremely useful for troubleshooting purposes, not very useful in production, right? So remember to disable that when you go to production. But this can be quite helpful if you are unsure about what's actually going on behind the scenes, right? Specifically because pretty much in OpenTelemetry for Java is about dynamically instrumentation, right? So there's a bunch of things that kind of happens magically behind the scenes, interceptors. For those of you that remember aspect-oriented programming, there's a bunch of aspect-oriented programming going on behind the scenes in the JVM. There's a bunch of waving and injections of code dynamically happen. So all of this can make the understanding about the actual flow of the code a bit blurry. So this is going to uncover certain secrets for you, right? And, right, this is another trick that it's pretty handy sometimes. Maybe you want to simply disable the agent, right? And you don't necessarily have to kind of manually remove the jar file of the agent of your entry point, because maybe you're using Docker or Kubernetes and you don't want to change your Docker image, right? The entry point that you set on the Docker image is already is using the jar file, and you don't want to change that because that image is supposed to be immutable, right? Supposed to. It's not necessarily conceptually, it can be mutable, but it's supposed to be immutable if you follow the best practice, right? But sometimes what you can do, you can disable the agent using this flag over here, right? So this flag allows you to completely disable either the automatic and manual instrumentation for your application. So you can see things like, okay, let me see how my application behaves or performs without OpenTelemetry, right? And there are a thing called observable metrics, and there's no pun intended here because of the word observable, right? Because we're talking about observability, right? This is a resource, a feature that it is available, right, with OpenTelemetry. And this is quite handy because if you remember, I'm going to show the code one more time, but if you remember the example of the metric that we've created right before, you would see that, all right, it was a counter, right, that I've created and stored it into a private static field of a Java class, right? And then in different parts of the code, I can simply call that counter an increment. So, but that call itself needs to be explicitly done. I have to write down the call itself myself, right? Just like I did before. With observable metrics, you can create metrics that they execute by themselves in a frequency that you can specify here, either in the configuration or in the code, right? So this is an example of how the application can proactively calculate its own heap memory, right? So in here, you provide simply an updater, an implementation of what they call an updater. Everything else is just a metric, plain old metric. But if you associate this meter with an updater, this updater will be periodically executed and it's going to come up with some logic that you are going to provide, right? In here, I'm just calculating the total amount of memory used for the JVM, right? I'm not sure if this code actually makes sense in container technologies, but you got the gist here, right? Let me show you actually how this code works, how this code is actually behaving in my code. We have some time, so I think we are good.
Yeah, we are good.
Yeah, we have about, just to see if my counting is correct, we have about 20 minutes per se, right?
We have 7 minutes.
Oh, my counting is terrible then. But still, still we have some room for finish this thought here and then wrap up the presentation. So 7 minutes is okay. So in the code that I was shown before, right? So this is a Docker Compose that I was using, right? So this is the reload application, right? And then as you can see here, I have exported that my traces and metrics are going to use this protocol called OTLP, which stands for Open Telemetry Protocol, right? Oh, by the way, there are different protocols that you can use to transmit the Open Telemetry data, right? OTLP is the default, arguably what pretty much everybody's going to use, but you don't have to settle down for this, right? There, you can use Zipkin protocols or Jaeger or even Kafka, right, to transmit the data for you. So you can tweak this using these properties over here. And then you have to set here the endpoint, which is where the telemetry data is going to be sent, right? And then this is currently pointing to my Elastic APM server, but let's say you don't want to use Elastic APM, you want to switch to Jaeger, right? And then you can simply point here to your Jaeger endpoint and everything else would work, right? This is the beauty actually of the OpenTelemetry, because you can code your whole logic of instrumentation and tracing and metrics, and everything else would work like flawlessly just because you're changing the backend, right? But I'm derailing a little bit. What I would like to say here is that there's this property here that says that every 5 seconds, the matrix that has been accumulated on your JVM heap is going to be flushed into the backend, right? So I've set here for 5 seconds, and in the code itself, right? Where is the metric? So here we go. So I created my meter here. I call it meter, right, for simplicity. And then I created 2 metrics here, the number of executions, or this is what we call a static metric, right? Because this one, I have to manually code how to mutate the value of it, either to increment or decrement. But this one over here, what I call the heap memory, is what we call a long value observer, right? It always starts with a data type because you can have an observer for long values, for float, doubles, int, right? So there are different data types that you can use. Maybe in my case over here, I've used it long because it represents well what the data structure that I want to create here, which is the amount of bytes, right, being used by the application. So as you can see here, I create a set updater. So this is my callback implementation of how to set the value. And this callback here is going to be in the background. There is a bunch of IO background threads that from time to time, given the time that you specify via parameters, execute this logic over here, which is pretty handy, right? So now you have a metric that simply is executing and flushing the data for you automatically, right? So if we take a look on this heap memory over here, let me just remember the name of that I gave. I call custom.metric.heap.memory. All right, so let's take a look on the last KPM, this metric. Discover. Okay, this is what I want to see. It's filtering for the last 5 minutes, and then we should have, oh, here we go, custom.metric.heap.memory. So let me filter only documents that has to do with this value, and let me pick up an example of a document here, right? So this is the metric. Where's the name of the metric? It's somewhere over here. I'm not wearing my glasses right now, so it's kind of hard to see. Oh, here we go. So let me highlight it for you. So this is the name of the metric, right? Here we go. And this is the current value of it, right? So which is set in bytes. So all of this, as you can see here, has been continuously calculated for you automatically, right? So observable metrics are handy ways for you to build up metrics, and you don't want to spend too much time. When it's possible, of course. There are situations where you need to hook up invocation calls to update the metrics throughout your code. But in this case, it makes sense to be something observable. And then the last hidden secret I would like to discuss with you today is something that it is quite useful in my opinion, right? Because here's the context, right? Let me set you the context for when to use this feature over here, right? Let's say you want to start your OpenTelemetry implementation, but you still don't have a proper backend implementation. You're still deciding if you want to use Elastic APM, for example, or Jaeger or Zipkin or whatever observable platform your company wants to use, right? You don't necessarily have to wait, right, until you have an observability platform to start actually seeing what OpenTelemetry produces in terms of, specifically in terms of traces, for example. One common approach that I started to use, and a lot of people kind of use, is using what we call a console appender, right? So as the name implies, everything that is a span processor that every span that's created, you can flush to a console, and then you can kind of associate to a log file, and then you can tail minus after log file, and you can see it from there. Works, but not necessarily very handy, right? There is this extension called JFR events. As you can see here, it's part of the SDK extension. So by default, keep that in mind, it's not part of the OpenTelemetry project. But if you associate with your application, right, you can start a flight. You have to use a JVM that supports flight recording, right? Hotspot or whatever other JVM supports flight recording. So you can start a flight recording of your JVM while it's being executed. And then all the traces that will be generated here will be kind of compatible with JMC. So you can simply, after you finish the recording, you can open up JMC, open the JFR file, and all the traces will be there. So you can visually not only see the traces, but their dependencies, like in a more hierarchical diagram. It's very handy to kind of see how the application is behaving, and more importantly, to observe the performance of the application and how much overhead the traces are introducing into your application, right? So keep that in mind. The JFR events span processor is pretty cool, and it works perfectly. With that said, thank you very much for all of you that spend this time today in the session about OpenTelemetry. I really appreciate your time. And for the organizers, for the Jnation conference, thank you one more time for bringing me in. And I'm looking forward to further discussions with you about this team in Slack, or if you want to hear right now. So thank you.
Thanks very much, Ricardo. Unfortunately, we have no time at all for any questions or anything. I had one for you. So if there was an easy way to integrate old open tracing code with the new OpenTelemetry one, but well, I think we have to chat offline.
Yes, no, I will respond this question offline in the Slack, but there's kind of a way, right? Just to give a TLDR.
Thanks very much. I really enjoyed it.
I appreciate it, Bruno. Enjoy your day. Thank you.
Bye.
Bye.
Olá, eu sou o Paulo Martins, sou um dos cofundadores da Present e atualmente o CEO da empresa.
Olá, eu sou o Vítor Batista, sou um dos cofundadores da Present Technologies e atualmente desempenho também a função de CEO da empresa. Portanto, a Present Technologies é uma software house, a nossa sede está aqui em Coimbra, no Instituto Pedro Nunes, e temos também escritórios no Porto e na Sertã. Portanto, a nossa área de atividade desenrola-se ao longo de diferentes mercados verticais. Os nossos clientes são maioritariamente internacionais, principalmente Europa, e é nisso que estamos focados atualmente, que é crescer além fronteiras. Bem, 2020 foi no mínimo um ano diferente. Portanto, o mundo mudou radicalmente de um dia para o outro e nós também passámos por isso. Portanto, no início da pandemia sentimos muito nervosismo no mercado. Alguns dos nossos clientes colocaram projetos em pausa. Outros, pelo contrário, decidiram acelerar os projetos para chegar mais rapidamente ao mercado. E foi também um ano com novos desafios. Para terem uma ideia, nós passámos toda a equipa para trabalho remoto em 24 horas e que fizemos com sucesso. Portanto, continuámos a nossa senda de crescimento, principalmente além fronteiras, como era o nosso objetivo. Claro que isto não teria sido possível sem a nossa equipa fantástica, que trabalhou arduamente, foi resiliente, sem nunca virar a cara à luta, e só isto nos levou a chegar a um ano do qual nos orgulhamos. A pandemia trouxe também novas oportunidades, principalmente de projetos inovadores. Portanto, vamos falar de dois desses projetos que desenvolvemos aqui na Present. Portanto, um deles consiste em levar o conceito das aplicações de contact tracing que diferentes países fizeram para um contexto em que as pessoas possam não ter telemóvel, como por exemplo os lares de idosos, e que permite também levar estes conceitos para o mundo empresarial. Por exemplo, para uma empresa em que conseguimos gerir ou definir que uma pessoa só tem acesso a determinadas salas, a determinados espaços, ou que não temos mais do que um determinado número de pessoas numa sala.
Outro projeto foi o CEF Mobile, uma aplicação móvel para controle de fronteiras, que tem permitido aos inspectores do CEF efetuar o controle das nossas fronteiras terrestres de uma forma segura e eficiente. Este controle é feito sem a necessidade de existir contacto físico com os documentos, permitindo apenas através da câmara ou da tecnologia NFC recolher um conjunto de dados, que é depois utilizado para a pesquisa num conjunto de bases de dados nacionais e internacionais e assim dando a informação ao inspetor para poder decidir se deve ou não deixar entrar a pessoa no nosso território.
Ora, para este ano e para o próximo, pretendemos continuar o nosso ciclo de crescimento, já vem há uns anos esta parte, e consiste em crescer acima de 20% em cada um destes anos. Portanto, à data de agora, este ano, 2021, está a correr muito bem, estamos acima dos nossos objetivos, e não só através do reforço nos clientes atuais, como crescer em novos clientes e novos mercados. Para terem uma ideia, o nosso maior desafio à data atual é conseguir fazer crescer a equipa para dar resposta a todas estas oportunidades.
Eu diria que seriam pessoas com garra, com brio, com espírito inovador, com muita vontade de aprender, mas também de ensinar, e acima de tudo que se sintam bem num ambiente informal, mas responsável e profissional que nos caracteriza. Na Present damos muito valor às relações interpessoais, ao equilíbrio entre a vida pessoal e a vida profissional, ter uma equipa feliz, e isso por si só é um garante do sucesso da empresa. Neste momento estamos à procura de reforçar a equipa em praticamente todas as áreas de engenharia, desde a parte web, à mobile, mas também à parte back-end. Por isso, se estiverem interessados, aceder ao nosso site, presenttechnologies.com, e candidatarem-se a uma das vagas em aberto.
Façam parte da equipa Present
e venham conhecer a nossa mascote, o Technology.
Hi, everyone. New track, this time with Grace Jensen. She comes from IBM, and she's going to talk to us about thriving in the cloud and going beyond the 12 factors. Hi, Grace. Hi, Grace. How are you doing?
Hi, I'm good, thank you. Thanks so much for inviting me back again. It's great to join you all.
It's great to have you here as well. So go for it. We'll talk soon for the questions.
Fantastic. Thanks so much. So yeah, as I've been introduced already, so thank you for that. But I'm Grace Jansen. I live in the UK. I'm a developer advocate at IBM, and I focus primarily most of my time on sort of, I guess, more Java-related technologies, the JVM, reactive technologies, and cloud technologies. So today I'm going to be running through sort of how we go beyond the original 12 factors to not just enable our applications to survive in the cloud, but to thrive in the cloud. So really making the most of that cloud infrastructure and designing our applications to be cloud native and to really thrive, like I said. If you've got any questions, please feel free to put them in the chat and I will do my best to get round to them at the end. So without further ado, I'll get started. So how did we get to this stage of designing these applications that are utilizing this cloud infrastructure? Why are we excited by the cloud? So we had this gradual evolution process where it sort of started with our underlying infrastructure evolving. So we used to have sort of more single core units. We're now able to take advantage of multiple cores, and with that, multiple threading. We're also able to take advantage of things like virtualization and containerization. And by enabling all of this infrastructure, we were then able to evolve our applications to benefit from that new, modern, improved infrastructure. So we then had this evolution in our architecture where we moved away from sort of more bulky, monolithic style applications, and we started breaking them down more, whether that's into microservices or perhaps more modular monoliths or macroservices, or even down into functions. By breaking apart the sections of our applications, we were able to create easier deployments in terms of getting them up and into the cloud. We were able to sort of maximize the usage of the resources by enabling those resources to be associated with certain services, depending on the load to our system. We could easier find bugs. We could replace certain parts of our application without having to bring down and bring back up the entire application. So great benefits that we gained from being able to evolve our applications because of this underlying infrastructure. And this led to sort of this trend of, ooh, the cloud. So if you've ever seen Toy Story, you might get this reference. If you haven't, please go and watch Toy Story. So ooh, the cloud is just my way of showing our excitement towards this trend of creating applications that really take advantage of this and offer clients and stakeholders and customers all of the sort of benefits that the cloud offers. And what are those benefits? Well, there's various different ones. There's a huge range of benefits and advantages that you can gain from creating a really truly cloud native application and taking advantage of that modern infrastructure. One of those is cost. So the fact that you're able to utilize this shared infrastructure that's managed by a cloud provider means that they're essentially providing that infrastructure at economies of scale. So because they're doing it at economies of scale, they're able to cost save and thus pass some of that cost saving on to you as the customer or the client. You're also able to be much more cost effective in terms of the resources that you're paying for. So you can scale your resources up and down depending on the load to your system. So you don't need to pay for the maximum amount of resources you have to sort of account for that maximum amount of load. You can shrink it back down when your load decreases, which makes it much more cost effective. There's also speed. So being able to rapidly provision new resources, for example, if your application load increases, and being able to spin up new versions of your application really rapidly in that cloud infrastructure. And that sort of ties into scalability, being able to scale up the number of resources elastically, so scaling them up and back down again at speed. And that leads to resiliency. So resiliency is another benefit because, if one particular part of your application goes down, you can spin up another instance of it fairly quickly because the infrastructure is already there ready for you to use. If, for example, a data center were to go down, by using that shared infrastructure, you could move it to a different server or a different data center or even a different country, depending on your cloud provider. And this means that you have this increased resiliency just in case something like that were to happen. It allows flexibility because you can move it about. You can also move it across different cloud providers because there's this sort of shared infrastructure layer that's utilized. And it also enables our applications to take advantage of this fashion to move to cloud. You might not think of software development as a fashion industry, but actually it can be. We follow trends, we follow fashions, we follow innovation that occurs within our industry in order to offer that innovation to our clients and customers and provide that difference or that differentiating factor from our competitors. So enabling sort of building applications for cloud native and enabling them to use that underlying cloud infrastructure enables us to offer all of these benefits and to really gain from them. So what does it mean to actually build a cloud native application? Because that's essentially what we're trying to do here. We're trying to build applications that thrive in the cloud, that are designed for the cloud. So I took a look at a few different various definitions, and this was one of the best ones I came across, which was by the CNCF. So clues kind of in their name. They're pretty good at cloud native. So they sort of defined cloud native as technologies that empower organizations to build and run scalable applications in modern dynamic environments, including public, private, and hybrid clouds. So this is what we're aiming to do. We're aiming to enable our applications to be built, to be scalable, to be dynamic environments, utilizing this underlying infrastructure. So how do we go about actually building that? Well, the original methodology that was often jumped to was the 12 factors. If you've not come across the 12 factors before, this is a methodology that was defined a few years back now by developers at Heroku, and it was designed as sort of a map, I guess, or a list of characteristics and things you should think about for building cloud native applications. So trying to match that description we just saw. And it was based on 12 factors, as the name suggests. And it was designed to be able to be applied to any application. So it's technology, platform, and language agnostic. It doesn't specify or have opinions as to which ones you should utilize, which means that it's very highly applicable in terms of utilizing it in any application. So the original 12 factors are as follows. So you had code base, dependencies, configuration, backing services, build, release, run, processes, port binding, concurrency, disposability, dev prod parity, logs, and admin processes. These factors, I would say, served as a really excellent introduction to sort of this discipline, I would say, of building and deploying applications in the cloud. But not only that, but also preparing teams for sort of the rigor needed to be able to build a production pipeline to enable these cloud native applications. So it wasn't just about sort of the code base itself and the logic within that application. It also introduced organizations and development teams to the sort of organizational and business process side of things in terms of enabling their organization to encourage and enable those characteristics and those that code logic to be cloud native. And as I said, this served as a really great introduction. However, we've evolved since this 12 factors was created. We've evolved in terms of our infrastructure, in terms of our application architecture, and in terms of the tools and technologies that are available for us to make the most of when we're building cloud native apps. And so sort of evolving this, just like our infrastructure evolved and our application architecture evolved, we've evolved this methodology to extend it and add on to those original 12 factors to take advantage of this innovation. So now we have this revised 15 factors. So we're going beyond those original 12 factors to now do 15. And this is it's still loosely based around those original 12 factors, but there are some revisions to some of those originals, and there are also 3 additional factors that are added here. Now, this was originally sort of documented in an ebook you can find online, and I put the link there. The ebook is called Beyond the 12 Factors, and it's by Kevin Hoffman. So this is his revised 15 factors that we're taking a look at today. So the 3 that were added in addition to the original 12 were API first, telemetry, and authentication and authorization. And we'll have a look at each of these factors, because as I said, some of the originals have been revised and sort of added to as well as these additional 3 factors that he's added. So we'll take a look at them in closer detail, and we'll have a look at sort of how we can enable these factors through sort of processes, through technologies and open source tools that they can utilize. So in terms of these three additionals, if you've not come across them before, API first is all about really enabling teams to essentially work against each other's public contracts without having to interfere with sort of internal development processes. This is particularly important in cloud native applications because it's really highly likely that any service you build is going to be deployed as part of an application, and it's going to have to interact with other services in this sort of larger ecosystem of services that make up your application. So this is why it's particularly well suited to cloud development, because it really allows sort of rapid prototyping and support of service of that sort of service ecosystem. Then telemetry. So telemetry, actually, we just had a session on telemetry. So if you were in this track before, you probably caught that. For those who weren't, telemetry is critical for cloud native applications. We're now having this huge amount of different services involved. They're distributed across potentially multiple different clouds, different data centers, and it becomes building cloud native applications sort of inherently comes with more complexity. And so it's important that we're able to use telemetry to be able to monitor and sort of, just monitor your application and monitoring its performance, monitoring its health and key metrics in this sort of really complicated and highly distributed environment. So that's why telemetry has been added here as well. And then we have authentication and authorization. So authentication and authorization, essentially, this is referring to security. So if you'll notice in the original 12 factors, security wasn't really mentioned anywhere. But actually, security is a really vital part of any application, not just cloud native, but any application. But I would say especially for those deployed in cloud environments. Deploying in a cloud environment means that your applications are essentially being transported across loads of different data centers across the globe and executed within multiple different containers and accessed by almost an unlimited number of customers. So it's really vital that your security isn't just an afterthought for cloud native applications. It's a really important factor to be considering when you're designing and building your application sort of right from the very start. So that's again why we've come to realize that there are additional factors that are important when we're designing cloud native applications. So let's take a look at each one of these in greater detail and see just how we can enable them to be able to really thrive in this environment and not just survive. So the first factor that we took a look at was one code base, one application. So you'll see at the bottom here, if it's a red or sort of orangey color, that means that I've linked it to one of the original 12 factors. If you see a bluey color, that means it's one of the new factors that's been introduced in the 15 factors. So here, one code base, one application essentially links back to the original first factor in those 12 factors, which was just code base. So cloud native applications in this factor is all about cloud native applications consisting of a single code base that's tracked in a version control system, just like the first factor in the 12 factor app methodology. A code base is essentially a source code repository or a set of repositories that sort of share this common root, and they're used to provide any number of immutable releases. So not only that, but in this particular sort of revision of the original factor, we delve into the fact that it's also one application. So it's about the fact that we have this one-to-one relationship between the application and the code base, but we have a one-to-many relationship between the code base and the deploys. So it's all about having a single application that is stored in a single code base, but that can be deployed to various different environments. So that includes deploying to production, staging, QA, DevSecOps, developer, and any other development environment or any other environment you might need. And the reason for this is that it helps by having this single code base, we enable greater collaboration between development and various other teams. We also enable proper versioning, which is really important if you need to roll back for any reason, if there's bugs, for example, or if you're trying to audit your application. Being able to enable versioning correctly is really important, and having this single application and this single code base enables us to do that. And it also enables us to have faster time to market because everything's in one place. How do we achieve this? Well, we can utilize Git repositories. So you might already be using GitHub or perhaps GitHub Enterprise or even GitLab. And then there are other alternatives, like, for example, Bitbucket, SourceForge. You might be using a specific cloud provider's version. So there are examples like Google Cloud Source Repositories or even AWS Code Commit. So there's various different sort of Git repositories you can utilize or code bases you can utilize. These are just some of the most common ones that you often see. So we looked at the first one. It's fairly similar to the original 12 factors, but it's also focusing on that single application, that one-to-one relationship as well. Then you've got API first. So in regards to these factors, this is one of the new ones. And what you'll notice as we go through these various factors is that some are really specific about sort of specific physical requirements or technologies or sort of methodologies utilized when you're actually coding, whereas others are more around sort of encouraging specific habits or processes of the people and the organizations, as opposed to necessarily imposing a physical requirement or a requirement on the code. So this is an example of that. So API first, what do I mean by that? API first really means that you're building, what you're building is an API that's going to be consumed by client applications and services. So it's all about having this sort of API first approach. You're thinking about the API before you do anything else. This gives teams the ability to work against each other's public contracts without having to interfere with the internal development process. So essentially what you're doing here is you're enabling by getting together and doing this sort of design phase where you're looking at, okay, what APIs are we going to be producing? Because essentially that's what my service is going to be. My application is going to be consumed in some way as an API, whether that's as a website and your customer is consuming that as a website, that's still kind of an API because they're still consuming it in some way, or whether that's another backend service is going to be consuming from that API. It's about stopping before you write any of the code and thinking about what exactly are you providing to your customers or to the other services that are going to be utilizing your service or application, and how are you enabling them to get access to that information or access to those services through the APIs that you're going to be offering. And why we want to include this factor is essentially to help avoid integration failures and to really formally recognize our API as a first-class artifact of the development process. It's important. It helps to enable greater collaboration with stakeholders. So you're designing what they need for each API or service, and you're able to create greater documentation from that and mock up the API first, which means that you have this opportunity to test or to vet your direction or your plans before you invest too much into supporting a specific or a given API, enabling much greater flexibility if, for example, you needed to change that or add in an API or edit it in some way. So how do you achieve this? Well, you need to be sort of willing to be participants in this ecosystem. And to do that, you need to be able to provide these public contracts. And you can utilize tools or technologies like, for example, OpenAPI, the OpenAPI initiative, or other ones like API Blueprint. You can also utilize specific tools that then implement these specifications, like, for example, MicroProfile OpenAPI. If you've not come across MicroProfile before, it's a fantastic open source sort of community specification that really enables Java EE and Jakarta EE, so enterprise Java developers, to make the most of this open source development and to be able to utilize it to create cloud native microservice-based applications. So it's a set of APIs, one of which includes this MicroProfile OpenAPI that you can make use of. You could also utilize sort of proprietary products like Apiary or even IBM's API Connect tools. If you've not come across some of these specifications before, I definitely recommend checking them out. They can be really interesting to take a look at. So here you can see by really putting the API first, we can enable our applications to be cloud native because they're in this ecosystem of services that are all interacting. Before we put all this effort into code, we can make sure we're going down the right direction first. So that's why API first is a really important new factor we've introduced. The third factor is dependency management. Again, this links back to another factor in the 12 factors, the originals, and that's just dependencies. So in sort of classic enterprise environments, we're sort of used to this concept of sort of the mummy server, which you've probably come across before. This is essentially a server that provides everything that our application needs and takes care of their every desire, from sort of satisfying the application's dependencies to also providing a server in which to host the application. Whereas in the cloud provides this sort of maturation or maturity of the classic enterprise model. So because of that, we need to make sure that our applications also grow up to take advantage of the cloud. We can't assume anymore that a server or an application container will have everything that our application possibly needs, like the original Mummy server. Instead, we now need to bring our dependencies with us when we're deploying our applications. So migrating to the cloud basically means that we need to mature our development practices and sort of wean our organizations off this need for a Mummy server. So now we need to be explicitly declaring and isolating our application dependencies. And we can do this by sort of utilizing a declaration manifest, and that might be stored within the code base itself, or using dependency isolation tools during application execution. So why are we doing this? Well, as I said, we can't make the assumption that within our application container or within the cloud, we're going to have all of the dependencies that we possibly need, all the versions of those dependencies that we need. So by explicitly declaring and isolating them, we can provide consistency between the various different environments that we're deploying our application to, whether that's development, production, testing, QA, whatever. We can also simplify setup for developers who might be new to the application. And it enables us to support portability between different cloud platforms, giving us much greater flexibility in terms of where we can deploy our applications and ensuring that it's going to be sort of consistent across all of those cloud providers and across all of those platforms and environments. And this really enables greater developer productivity at the end of the day. We're not having to go into each individual sort of class, looking for each of those dependencies. If we need to change cloud provider or environment or whatever platform, we're able to have it all within one specific manifest and easily change that if we need to increase the version, for example, or edit it in some way. So how do we achieve this? Well, instead of packaging the third-party libraries inside your microservice itself, we need to specify those dependencies in an external file of some kind. So you might be utilizing something like Maven or perhaps Gradle, and it can be really useful to be utilizing things like the Maven pom.xml or the Gradle settings.gradle file, because this enables us to, as I said, freely move up the versions and separate it from our original code base. So it doesn't matter where we're deploying to. So dependency management here, we've just sort of taken it one step further from the dependencies and talked about sort of, it's not just about sort of defining and stating your dependencies themselves, it's also about managing them in a way that's effective for cloud native. The fourth one is design, build, release, and run. Now you'll notice this is almost identical to the original factor. In this time, we've sort of switched the order a little bit. So now it's number 4, it was previously number 5, but in the original one, they didn't have this design phase. So we've added this design phase in. And that's because essentially a single code base is taken through this build process. Essentially, this design stage is important, and it was missed the first time round. And since we've started moving to this cloud native type architecture, I think we've realized more and more how important it is to stop and think about the design before we actually rush in and start building our applications. And this design stage isn't about, we need to design the entire application end to end like we did in waterfall development. No, we want to stay agile, but it's still important that we design even the smaller features that get released. It's about having high level design that's used to inform everything we do, but we also have to bear in mind that that design might change. We might need just small amounts of design in every part of the iteration process rather than it being done entirely up front. So it's about sort of understanding that we need to have this higher level design to follow as we create our applications and build them, but we do need to understand that they might change as we go. And then the other sort of stages, so build, release, and run, are essentially, as you'd expect. Build stage is all about, having a code repository and where that's converted into this sort of version binary artifact. It's during this stage that dependencies are declared, and we're able to fetch them and bundle them into the build artifact. So in the Java world, you'd probably have a war or a jar file. Then the release stage, again, as the name suggests, this is essentially where you create your release. So the release is typically done when you push your application to your cloud environment. The output of this stage is essentially combining your environment and app-specific configuration with sort of the information that you need to produce this immutable artifact, which is a release. These releases are usually unique, and they're identified with sort of a unique ID so that we can then, again, know which version we're utilizing. Then you've got the run stage. So run, again, it's sort of typically done in a cloud provider. The details vary among providers, but the general pattern is that your application is sort of placed within some kind of container. That might be Docker, Garden Warden, and then a process is essentially started to launch your application. So this factor here is essentially, we have added the addition in this 15 factor of design, but the whole point of this one is that we are strictly separating out the various different build sections or stages that we have. And this is important because it allows us to prevent sort of changes to the code or configuration at runtime, which enables us to lower the number of unexpected failures. It also enables more effective release management, and it enables maximum delivery speed while still keeping our confidence high that, through our automated testing, we've been able to make sure that there won't be any unexpected failures. This is sort of more of a methodology thing. So again, I talked about the fact that it might not necessarily link specifically back to a process. It can be just more about process within the organization and the people. But it can be sort of worth considering for this stage, utilizing a CI/CD pipeline, which can help you to be able to automate the process going through these various build stages. And a tool that might be useful to do that is Tekton. So if you've not come across Tekton before, I've got some links at the end of this slide that can help you run through sort of how you can utilize Tekton for that CI/CD pipeline. So the next factor is configuration, credentials, and code. So again, this links back to the original configuration factor, but in the original, it only stated that you should store configuration in the environment. But in this updated one, we're trying to be a bit more explicit. So when I say configuration, I'm referring to sort of any value that can vary across deployments. That might be URLs or other information about backing services. It might be information located to sort of how you locate and connect to databases. It might be credentials, that's also included, mentioned in the title here, or it might be information that normally is bundled into properties files or configuration files. Credentials, in this case, are extremely sensitive information, and they have absolutely no business being in a code base for obvious reasons. You do not want any Tom, Dick, or Harry being able to access those credentials freely just by looking at your application code, if they're able to get hold of that. It's obvious that we don't want that within our code base. So it's important that we're able to sort of utilize this factor of externalizing our configuration to be able to sort of make sure we're not leaking any credentials like that. This factor relates to sort of the golden rule of cloud native applications. And that's the fact that they should be able to be written once but configured everywhere. So they should be able to run anywhere. And that's why it's important that we utilize sort of environment variables to be able to externalize this configuration outside of our application logic. So this factor is all about ensuring really strict separation between code and configuration, and that configuration includes credentials. It's about storing that configuration in environment variables, which is sort of nowadays considered best practice for externalizing that configuration. It enables us to be able to modify our application behavior without making any changes to our code logic. It helps to simplify deployment to multiple environments. It enables us to reduce the risk of potentially leaking those credentials and passwords, and it enables even more effective release management. So it's all about, the how of this is just by extracting all of your application config and making them external or environment variables. And we can utilize things like microprofile config. So again, this is another of the microprofile APIs. So this microprofile config enables us to place that configuration in properties files that can then be easily updated without having to recompile your microservices. And on top of that, we could also make use of another microprofile API called CDI to be able to inject those properties back into our application. If you're interested, I put on a couple of these slides where it relates to it, some links to some of our Open Liberty guides. So if you're interested in getting hands-on with some of these specific technologies or specific factors or behaviors, then check out the links I put on each slide. And I've got some additional links at the end of the presentation. So the next one, logs. So again, this links back to an original. We've changed the order this time, though. It's now number 6 instead of number 11. So this is pretty similar to the original one. Essentially, what this factor is all about is treating logs as event streams. So only utilizing std_out and std_er to be able to log our logs. And essentially, the point of this factor is that unlike sort of traditional applications that might have run on premise, a truly cloud native application should never concern itself with the routing or the storage of its output stream. And this is because essentially we're trying to improve our flexibility for introspecting behavior over time and enable real-time metrics to be collected and analyzed without having to write that into our application logic. So we are making logging a platform concern and not a developer concern here. So how do we enable this? Well, we should only be using std_out and std_er to be able to log our logs. We need to be treating them as event streams, so essentially as events that are occurring over time and that we can look back on and retrospect and analyze. And we need to consider the aggregation process. So the fact that we're aggregating, processing, and storing logs, we need to think about sort of the fact that it will grow over time. So we also need to bear that in mind. We can utilize tools, though. There are many tools out there that are specifically designed for collecting logs and enabling you to display those to be able to analyze them and see what's going on in real time in your system. So we can utilize things like the ELK stack. So that's made up of Elasticsearch, Logstash, and Kibana. We could also utilize tools like FluentD, Splunk, or any number of other tools that essentially enables you to capture and then analyze your log emissions. But essentially, this factor is all about, it shouldn't be a developer concern, it's now a platform concern. So treat them as event streams and utilize tools available to be able to automate that process. Okay, so the next one is disposability. So this is factor number 7 in our new 15-factor app methodology. Originally, it was number 9. So disposability is all about enabling really robust, sort of maximizing the robustness of your application by enabling really fast startup and graceful shutdown. An application can't scale, though, or deploy, release, and recover rapidly if you can't sort of rapidly shut down gracefully as well. So we need to be able to build applications that embrace and take full advantage of the platform to be able to create fault-tolerant microservices that are able to be easily deployed, easily released, easily scaled, but also easily and gracefully shut down. So it sort of relates, I've got a very vague image here on my screen. So this sort of relates to pets versus cattle. So originally, our applications were more like pets traditionally. They were, unique. We gave them names, we cared for them, we had this emotional attachment because we'd worked for so many years to create them, and they were unique and lovingly cared for. When they got ill, we'd nurse them back to health, just like a pet, like Grace the cat here. However, we don't want to be creating pets because our microservices in this cloud native environment need to be easily disposed of, need to be easily replaced, easily scaled, easily deployed, but easily shut down as well. And that's why we want to move more towards this sort of cattle way of thinking. In cattle, they're not given names. This is a generalization here. They're not given names, they're given numbers instead. When they're ill, you just replace them with another generally. You don't nurse them back to health. And they're almost identical to the other cattle that you might have. So we want to go sort of brutally more around this cattle model because we need to be able to be resilient to unexpected occurrences and be able to increase our load by following this pattern of being able to shut down unhealthy microservices, bring up healthy ones, replace it with an identical version, just like in cattle. And this disposability really enables us to be very fast and very elastic in terms of our scaling. It allows us to have really rapid deployment of new code or configuration changes because we can bring down a microservice really quickly with the old config and bring up a new one really rapidly. And it enables robustness in production deployments. And it really enables this sort of concept of auto scaling without us having to manually deal with that. So how do we do this? Well, we need to minimize work on startup, so don't depend on any shutdown hooks. And we also need to maximize robustness with fast startup and enabling that through automatic scaling. We can utilize things like microprofile fault tolerance for this, which enables us to, again, make sure that our applications have fallback behavior, for example, if something were to go wrong. So what should be spun up again? What should happen? What are the actions that need to be taken? And if you're interested in checking out more about fault tolerance, check out the link that I provided there. So it's important that we're able to dispose of our applications and have this disposability factor in our cloud native apps, following more of the Cathal model. The next factor is backing services. So backing services here are any service on which your application relies for its functionality. So it's a really broad definition and it's a really wide scope intentionally. Some of the most common types of backing services includes data storage, messaging systems, caching systems, basically any number of other services that perform sort of line of business functionality or security. And in this factor, we're basically looking at the fact that there should never be a line of code in your application that tightly couples that application to a specific backing service, because we can't guarantee that that backing service is necessarily up and running, is healthy, is available. So we need to make sure that we're creating sort of bounded resources here. So what I mean by a bounded resource is essentially just a means of connecting your application to a backing service. So a resource binding for a database might include a username and a password and a URL that essentially allows that application to consume that resource. But we need to make sure that we're treating everything as a backing service that we need to, including things like databases, and treating them as this bounded or attached resource. There should also be no distinction between local and third-party services, and we need to attach resources via URLs stored in an application's config. Why are we doing this? Why does this factor get included? Well, it helps to really enable us to keep that concept of loose coupling, to make sure that we're not tightly coupling the various aspects of our applications, because that could potentially lead to sort of synchronicity, and you're essentially getting the worst of both worlds there, because you've got sort of the tight coupling of a more monolithic style application, but you've distributed loads of microservices and you're having to manage them all. So it's important that we don't have that coupling. So by enabling this sort of concept of treating everything as a loosely or bounded attached resource as a backing service, we can enable that loose coupling between service and deployment. It also means that we don't need any code changes if we need to update or change our backing services. And it allows our operators to sort of swap out services as and when they see fit. This really enables and sort of cements the idea of increased resiliency and agility, being able to attach and detach bound resources at will. So how we do this is essentially just a process thing. So it's about really taking the time to understand, okay, what does my application rely on? Can it be treated as a backing service? Should it be treated as a backing service? And we can utilize things like my profile config to help with this again. The next one is environmental parity. So while some organizations have managed to achieve this, many of us have often worked in an environment like the following. So we have shared development environments that have a different scaling and reliability profile to our QA environment, which is also different to our production environment. Usually the database drivers used in development and QA are different to production. We have different security files, firewalls, and other environmental configuration settings. And it basically means that on top of this, we also generally, a lot of the time, have some people have the ability to deploy to some environments, but not to others. And essentially what happens is people fear deploying because they have little to no confidence that if the product was to work in one environment, it would actually work in the other. So it becomes this huge mess of, the developers aren't confident, the code doesn't work, you're coming across unexpected failures as you move between the different environments. This factor here is all about negating those unexpected failures. It's trying to make every other environment that you have, whether that's development, QA, DevSecOps, production, for example, as similar as possible. And that's to be able to lower that risk of unexpected errors and support that continuous deployment model. It really enables us to have greater reliability in our code, knowing that if it works on one environment, it will work on the other because they're as similar as possible. Excuse me. So how do we enable this? So we need to ensure that we have the same backing services that are used for all deployments in all of them. We need to ensure we have this solid, continuous integration pipeline. We need to be able to deploy to production as often as possible to ensure that we have, confidence in what we're producing. And automated CI/CD pipelines can help with this, like we mentioned before with Tecton. We can also utilize container tools, for example, like Docker, because that can really help us to enable this more prod-like environment and more accessible to developer workstations. And building off that, we can utilize testing frameworks like microshed testing. Microshed testing is all about utilizing containers to be able to accurately test our applications in production-like environments, so mimicking that production environment for our testing. So again, check out the guide here if you'd like to take out more info about microshed testing. Then we've got administrative processes. So this is all about running admin or management tasks as sort of one-off processes. And sort of that might include things like one-off debug tasks. This is more about sort of enabling safe debugging or admin of production applications, and enables, again, greater reliability. We can utilize things like Kubernetes tasks to be able to take care of this for us. Or alternatively, you could use things like AWS Lambdas if you wanted to. Then we've got port binding. So port binding here, again, links to that original one in the 12 factors, port binding again. So the principle of port binding essentially asserts that a service or an application is identifiable to the network by its port number, not by its domain name. So your cloud provider in this case should be managing the port assignment for you, because it's likely also managing things like routing, scaling, high availability and fault tolerance, all of which require the cloud provider to manage certain aspects of the network. So an application developed with exported port binding in mind really supports the environment-specific port binding without having to change any of your code. So this really enables greater ops efficiency and enables us to sort of assign these associated IP addresses, for example, and domain names on the fly, and having this automated service discovery mechanisms. How do we achieve this? Well, we can export services via port bindings. We can utilize things like microprofile config again. So microprofile config can basically enable us to utilize things like Kubernetes config map, where we can specify the new port, and microprofile config can then automatically pick up the new value to give the correct information to the deployed microservices. We can also utilize things like microprofile REST client, which can help us with sort of creating client code to connect from one microservice to another. So again, utilizing things like Kubernetes config maps and microprofile can be really helpful in this factor. The next one is stateless processes. So this links into processes. Again, in this updated factor, we've tried to be a bit more explicit, a bit more specific. So essentially, this is all about the fact that microservices should be stateless. This is all about executing the app as either one or more stateless processes. In actually the 15-factor book, it's argued that it should only be one process, but it could be more. It's basically ensuring that all of your stateful data is stored in a backing service. So all long-lasting state must be stored external to the application, and you do that by providing these backing services. So this enables us to sort of reduce our deployment complexity, reduce operational complexity, and allow for much simpler scaling. Excuse me. And it enables that cloud compatibility. How do we achieve this? Well, don't store any stateful data without storing it in a backing service. So make sure you've got those backing services available. Please don't use sticky sessions or the local file system. You shouldn't be using any in-memory caches. Storing in-memory caches that your application thinks are always available can really bloat your application and essentially make each of your instances take up far more RAM than is necessary. So try, if you need to cache anything, use third-party caching products like, for example, Geode or Redis, or there are many other examples. Try using those instead, like Jcache, as they're designed to act as backing services for the caching that you need in your application. So really utilize these tools. Again, you can utilize things like microprofile, Geode, and Redis. Then we've got concurrency. So concurrency again relates to the original. In the original, it sort of advised us that cloud native applications should scale out using the process model. So there was originally a time when if an application reached sort of the limit of its capacity, the solution was just to increase its size. Whereas if an application could only handle some number of requests per minute, then what was considered the perfect solution was to just simply make the whole application bigger. But adding CPUs, RAM, and other resources to a single monolithic application is essentially vertical scaling. And this behavior nowadays is typically frowned upon. What we want is the much more modern approach of sort of horizontally scaling. So being able to elastically scale the specific resources we need. So rather than making a single big process even larger, we create multiple processes and then distribute the load of your application among those processes. So this is linking back to the previous factor, which is again why they're in this order. So having this process-driven style, or this process-driven model, and utilizing that to enable us to be able to dynamically and elastically scale them up and down depending on our workload. So why do we do this? Well, it enables us to easily and horizontally scale them instead of vertically scaling them. And that enables us to be much more efficient with the resources that we're utilizing to deal with that increase in load to our application. And we can utilize things like auto scaling. So how do we achieve it? Well, we need to split out our app into separate runnable processes, just like in factor number 12, and then scale those independently. We can use tools like Kubernetes Autoscaler to be able to help with that. Then telemetry. So this is another new factor. So telemetry is sort of linking back to Ricardo's session, who's before mine, is all about sort of building applications on cloud native that we're able to monitor in real time. So we might be monitoring the performance or domain specific telemetry or even health and system logs. This is important because sort of modern applications are much more complex. We have added complexity when we introduce them into sort of this cloud native environment. So it's important that we're able to monitor them in real time to be able to check that they're healthy and they're working okay. So here are some guides that you can check out. We can utilize for this microprofile metrics and health to be able to help with this. And then the final factor is authentication and authorization. Again, a new factor. So this is all about enabling security, which is vitally important to our applications. And this is all about enabling that through RBAC, so role-based access control, authenticating and then making sure that each user is authorized to be able to access the specific parts of our application, increasing our application security. So we can utilize tools, for example, to enable this, like OAuth, for example, OpenID Connect. And again, linking back to microprofile, we can make use of things like JWT, JSON Web Tokens, to be able to authenticate, authorize, and verify users. Again, there's a guide there if you'd like to check it out. All of these together enable us to have these important characteristics that we want when we're trying to create applications that thrive in the cloud. So this is why they're all important. They link back to these important sort of characteristics or behaviors that we need for the cloud. If you want to get hands-on, I've shown you some of the guides throughout. We've also made them interactive. So if you don't want to do it locally on your own machine, you can go to our online environment and you can access those there with all of the different technologies that I've mentioned and the tools throughout this presentation. They're based on our guides that I've linked to throughout. In summary, essentially, hopefully I've shown you that the 12-factor applications are a great start, but in order to thrive in the cloud, we have to look beyond that. And there's no excuses. There's loads of open source tools and technologies to be able to help you on this journey. So my action, hopefully for you guys today, is to evaluate your own applications against these 15 factors and consider what you could do to enable them to truly thrive in the cloud. Could you take any that you maybe haven't implemented before and implement them in your own application? As I said, some useful resources going forward, if I haven't given you enough links already. So some useful resources here for sort of general and some linking to the specific factors that I mentioned. And I'll put these slides up online so you can access those. Thanks very much for listening. Hopefully I'll get to some questions. And if not, feel free to ping me on Twitter. My Twitter handle's there.
Thanks very much, Grace. I'm afraid we don't have any questions both on Slack and on YouTube. But well, we are almost out of time, so we can move on. Will you put the links for the presentation on Slack?
Yes, yeah, I can put them on. Sure, yeah, absolutely.
Okay, thanks.
That makes it a bit easier for people, and I'll share the slides online as well, which will make it a bit easier.
Thanks for that. So Grace, thanks very much for being here another year. Hopefully at some point we will be able to be on a live conference here at Coimbra in Portugal. Okay, thanks very much and see you soon.
Thanks very much.
We're pulling into the party and we're shaking off the dust. It's been a damn long week and all we wanna be is way too drunk. Wanna feel a warm body, wanna dance until we're numb. We're drowning out the world tonight with plastic bottle rum. All pretending we know what we're doing, but we know that we're still just young. Love, heartbreak, kids acting like we somehow got a clue. We're catching 22, tired to wait, caught up in the twilight of our youth. We're catching 22. We're catching 22. It's running past midnight and our blood is running hot. Barely old enough to be as sober as we're not. There's a little hazy and the smoke got to our heads. We're breathing in the nights we tell ourselves you won't forget. All pretending we know what we're doing, but we know that we're still just young. Love, heartbreak, kids acting like we somehow got.
O facto da Tamana ter nascido no seio ou no meio da pandemia, não conseguimos comparar o efeito da pandemia per se, portanto nós já vivemos com essa realidade. E mesmo após a pandemia passar, todos esperamos que assim aconteça, certamente que não vamos voltar àquilo que era o normal antes da pandemia. Portanto, é muito difícil para nós medirmos o impacto da pandemia porque nós nascemos dentro dessa realidade. Portanto, a nova realidade é a realidade que todos nós conhecemos e que vamos ver daqui para a frente a acontecer. A preocupação com o desempenho é das preocupações que nós temos, especialmente numa situação como a Tamana, que está a ser criada, não é uma empresa que está em criação. A preocupação com a performance e com a eficiência é apenas um dos detalhes do lançamento de uma nova empresa. Temos algumas preocupações, como é óbvio, e temos algumas considerações de desenho. Estamos ainda a implementar algumas delas. Mas claramente temos preocupações com Kubernetes para escalamento horizontal e também algum server-side rendering para aumentar a performance dos sites. Como disse, é um dos ângulos de preocupação da Tamana, não é o único ângulo, tendo em conta que estamos a criar a empresa neste momento. Nós vemos os influencers como mais um canal de entrada para os nossos clientes, verem os nossos produtos e os produtos estão a ser vendidos através do nosso ecossistema. Digamos que os influencers são aquilo que nós no passado diríamos que é o passa-palavra, o word of mouth em inglês, e claramente que há muitas pessoas que influenciam e conduzem muito do negócio através das redes sociais. Portanto, vemos como apenas mais um canal. Eu digo apenas mais um porque já temos todos os canais tradicionais e este é um canal que tem crescido bastante nos últimos tempos e claramente durante a fase da pandemia mostrou-se ainda mais relevante e nas novas gerações mais novas claramente que é um dos canais mais importantes. É o estabelecimento do produto e da marca. Nós estamos agora em lançamento no Kuwait. Vamos continuar o lançamento para outros países, a estratégia está por ser definida ainda, mas vamos claramente crescer para outras geografias. Temos que cimentar o nosso produto e depois evoluímos para novas geografias por esse mundo fora. De estarmos à procura de muito talento e Portugal é uma pool de talento por excelência na Europa e nesse aspecto temos muito interesse em desenvolver a nossa marca aqui e atrair talento que nos possa ajudar na nossa missão. A missão é bastante ambiciosa, começa, como disse, como um país, mas o objetivo é alargar para outras geografias. Vamos ter um ênfase muito grande no Médio Oriente, que é um bocadinho diferente, talvez, até de algumas empresas que operam no espaço nacional, Portanto, apelamos a essa diferenciação e o espírito de desafio de criar alguma coisa de raiz e novo, como é o caso da Taman. Numa palavra, tudo, mas claramente precisamos de muito esforço de back-end, de front-end, de mobile, claro. A empresa é mobile first, portanto temos que nos focar nesse ângulo e depois todas as áreas que auxiliam o desenvolvimento de uma empresa como tecnológica como a Taman.
Hi, everyone. We have here Charlotte Mack. Did I say it right?
Sort of. Charlotte,
Okay.
the German one is Charlotte Mach, and then if you go for the English one, it's Charlotte, and then just leave out the last name because it doesn't do English well.
No worries. So Charlotte is an engineering manager at Container Solutions, and she's going to talk to us about Kubernetes operators for Java developers. It's going to be a shorter talk, so please be posted and post any questions at our Slack and YouTube channels. So Charlotte, go for it.
Awesome. Thank you, Bruno. Hi, everybody. My name is Charlotte. I'm going to be talking about Kubernetes operators for a bit. And if you heard about Kubernetes operators, you probably might have heard that most of them are written in Go. So the question is, why did I focus on the part of looking at Kubernetes operators in Java? Well, for one, I don't know any Go, and I didn't want to learn it specifically for this. But I've been using Kubernetes extensively and also different operators. And the topic of writing your own without Go kind of came up. And that's where this talk came from. Operators are a great thing to get started automating your applications on Kubernetes. The first time I heard about operators was when we were working on a client project and we were running into issues integrating Istio and Prometheus. And every single time I asked for help on the Prometheus configuration, people came back to me with the exactly same answer. They don't know, they were using a Prometheus operator, they didn't do this manually, and why aren't we doing that? And that was a really good question because the Prometheus operator, it's one of the earlier and more popular operators, and it does quite a lot for you. We'll go a little bit more into what an operator is, how it works, and what it does in this talk, and also how to get started in Java. And while this might seem like a great endorsement for operators, it's not always the best idea. So sometimes it's great to automate all the things, but for other reasons, there can also be use cases where you don't want to maintain another piece of software on top of your application where there might be already an operator for this out there. So there's a huge amount already written, especially for third-party applications that you might be using, especially anything that uses data storage. And this talk doesn't cover all the topics and the reasons why you don't want to do that, but there's a huge amount of YouTube videos on scaring people why to avoid writing your own operator in Java. This one is more for the other side to encourage you to try it out, figure it out, and then see that sometimes it's a good idea, sometimes it's not a great idea. But let's start with the basics. What exactly is a Kubernetes operator? You can see a few definitions on the slide, and that's great if you know a little bit on the internals of Kubernetes. So hearing about custom resources and the Kubernetes API acting as a controller, and then the way of managing your applications. For me, it's fairly simple. Custom controllers for custom resources are what make up an operator. So you're trying to extend the Kubernetes API with something that knows something about your application. So basically, instead of adding a separate piece of software somewhere that takes care of your application, or even having it done manually, you add something to Kubernetes itself that can take care of it. And to understand what extending the Kubernetes API actually means, we have to take a look at the components behind it and what actually happens in the Kubernetes control plane. And to be fair, this is a little bit deeper than what most people need in their day-to-day work, especially when they're just using Kubernetes for fun. But it is also kind of interesting to see. This is looking slightly complex, but it's already a simplified version of what Kubernetes looks like under the hood. So you have the control plane up top, which in my case, I only added the API server, the controller manager, and the scheduler. So you can see the 3 pieces here, the big ones. There's a few more pieces that I've left out because they're not relevant for our case. And also the API server itself doesn't actually keep the resources. There's a data store etcd behind it. But for our case, let's just have it as one big thing. So the API server basically takes care of managing and keeping all your resources and knowing what you have on your cluster. So when you run a command via kubectl, you send an API request to the server. In our case, let's say we run a kubectl command to create a deployment. So we create a deployment resource. At this point, you don't have anything real yet. This is basically just a line in a data store saying you have a deployment resource, which in itself is cool, but we all know this is not what happens. When you create a deployment, you get a few pods. The way how we get there is the API server sends out events. So once the deployment resource is created, the API server sends out events, and the controller manager, specifically the deployment controller, is listening. If it gets an event that a deployment has been created, it does its own thing. And what the deployment controller does is create a resource, which is called a replica set, to that's basically it from the deployment controller. So that's all it does. It listens to the events, and then it creates another resource. The same thing happens again when the API server gets the replica set created. So once that resource shows up, another event is sent out. And the replica set controller, a different piece, is listening as well and creates a pod. This is not an actual pod as you might know it. It is the resource inside the API. So you don't actually have containers yet. The next step is then the scheduler actually decides with its algorithm where to place the pod, so which node to assign to it, assigns the node, and only then does the kubelet, the piece on the node, get the event that there has been a pod that's been scheduled. And this is the first time when we actually create a container. So your container runtime then receives the command from the kubelet that something has been created. So this is a lot of effort to basically create a few containers, but we all know Kubernetes does a lot more than that. So this is the way it goes. And the important piece that we want to focus on, because we're looking at custom controllers and custom resources, the custom controllers are similar to the existing controllers. And if we say controller, what do we actually mean? We mean a piece of software that looks at 2 different things. It looks at the current state and the desired state. The desired state is what you define in your Kubernetes resources under spec. So this is what you want. And the current state is what shows up under status. What the controller does is adjust the current state to the desired state and observe to see what is actually happening. So we have a Kubernetes pattern that's called a control loop, which is basically what a controller does. It takes care of the control loop to make sure that what we want is actually what we get. This is not just triggered by kubectl commands, so you can also have recurring loops or other causes for this. For example, specific regular intervals. You might see this when you delete a pod and your replica set or your deployment didn't or is not aware of it, then it gets recreated. So this is what a control loop also does for you. Recreate the state that you want from the actual state that you have. And as I mentioned, by extending the API, we want to extend those controllers, so the deployment controller and the replica set controller that we've seen, with our own versions. So we want our own control loops that can take care of making our applications that are running conform to this control loop to make the state from the current state to the desired state. The thing is that the built-in ones are fairly limited, which makes sense because they're made for Kubernetes. So they are going for Kubernetes resources. So all the built-in Kubernetes resources are managed, or not all of them, but a lot of them are managed with those different controllers. And what we want to do is add application-specific knowledge. So for example, if you want to back up your database that you're, for some reason, running on Kubernetes, you need to know how to do that. And you don't want the people using it to have to know that. So the controller, you want to feed the controller that information so that controller can do it for you. And all the user has to do is, for example, change something in a different resource that I haven't mentioned yet. So we'll get back to that, while still keeping the Kubernetes features, right? So the idea of not having a separate piece of software is that you still can use Kubernetes validation and defaults and versioning, and it just stays inside Kubernetes. The different resource that I mentioned. So we have the custom controllers now. How does a custom controller know what it wants and where it wants to go? So custom resources are Kubernetes' way of allowing you to extend its resources by basically defining your own custom resource definition. Think of it as a blueprint for your own custom resource. So on the left side, you can see the custom resource definition. That's the way of defining what you want. And on the right, you can see an instance of it. It's a fairly simple one, literally just defining the name, but let's start from the top. So we define the different names for our resource. So when you normally run a kubectl get pods, the pod part is the resource. So in our case, if we apply this one, we can use kubectl get Tomcat, and then we will get our Tomcat instances. And those are used for Kubernetes as well. So as soon as you have a custom resource definition, Kubernetes is aware that this thing exists and treats it just as it would its own resources. That only applies as long as the custom resource definition exists. As soon as you delete that one, Kubernetes is no longer aware of it and doesn't care anymore. The second part is the schema, which is where you can use, for example, the validation that I mentioned. So in our case, the type as a so here the var is a string and the version is an integer. So that one, if you do change something in your actual instance and, for example, put a string here, Kubernetes actually checks that for you if it does conform to your schema. This is a very simple version. There are more complex ways of defining a schema. And the last part is basically just saying that you can have different versions. As with most APIs, you have the ability to basically retire older versions, only serve the newest ones. And you can also decide if you want your resources to be cluster-wide or if you want them namespaced. In our case, it makes sense to have a Tomcat, which will just be a pod, be a namespace. So that's what we have. And that is it for custom resources. So if you look at the custom controllers again, so we've seen what the controllers look like. And now the question is, how can you actually create such a custom controller? So how do you feed that controller the information that it needs? These four that I have on the slide right now are just a few examples. The operator SDK is the most well-known one. That's the one that does actually do Go. So I think that's the one most people are also familiar with. Kudo is a Kubernetes Universal Declarative Operator, mostly done using YAML, the Java operator SDK. Without spoilering too much, I think you know which one I'm going to be talking about. And then there's also the RESTful APIs directly. So if you are feeling adventurous, you can go and write your own operator talking to the Kubernetes API directly. There are API client libraries for various languages from Go, Java, Python, JavaScript, .NET, Haskell, and there's a few community ones, Clojure, Lisp, Node, Perl, PHP, Rust, Ruby, Scala, and I haven't checked that list in a while, so I'm assuming they've written at least 3 more in the meantime. Cool. Some people, when you talk about writing an operator in Java, ask why. For me, it's more of a why not. Java has a huge community, especially if you compare it to Go. Not that Go has a small community, but if you look at GitHub repos, Java has about 9 million active repos versus Go having like 700,000. So it's catching up, but it's not quite there yet. A lot of people know it. A lot of people use it and like it. So this is for me a good reason to actually use a language. Some people might also come up with Java not being ideal with memory consumption and startup time, but there have been moves into more of a cloud native lifestyle with Java, with Graal VM, Quarkus. We have a Quarkus, so there's a Quarkus extension as well on the Java operator SDK. So if you want a more lightweight Java application, that would work there too. But I know literally next to nothing about Quarkus, so I'm not going to be showing an example there, but just to put it out there that it exists. Cool. So if you want to get started with the Java operator SDK, basically there's a few steps that you need to do first. Have a cluster somewhere. In my case, I'm using Docker for Desktop. That's locally. Not actually necessary for running it, or for testing, but it does make it easier for testing. It's not actually necessary up to the point where you want to deploy it. You need to create your custom resource definition and custom resource, as we've seen on the slides. So basically have an idea of what your application is supposed to know about and what it's supposed to do and what you want users to see. So the custom resource definition, custom resource part is basically what most people who write operators want to show to their users. So if I edit something in a custom resource, that's the extent of what a user should be doing. And everything on the operator side is the person providing the operator giving out the information that they need from the user being put into the operator itself. Next step is a Maven dependency, just add it to the Java project. You can check out the examples. That's something that I usually like to do to get started with something. You take a sample, you edit what you need and keep going. And then once you've done that, you basically start writing your own controller. There's two important methods that you need, the create or update and the delete one. As we've talked about events before, so those are the two, there's more, but those are the two important kind of events. So you get an event if a resource is created and if a resource is deleted. So if somebody, a user, creates a custom resource, then you need to decide in your controller, what does that actually need to do? And this is a very simple example of what such a controller can look like. So we do have the first piece where we register the custom resource definition and the class itself here. And the custom resource is really just a definition of fields in the custom resource. For the first one, the create or update one, again, this is what is supposed to happen when an event comes in. It can be anything from, for example, creating a deployment, creating a pod, but it can also be something outside of your Kubernetes cluster. So if you want to manage resources outside, we've seen people, for example, create Jenkins instances outside of their cluster and manage them with operators. It can be something underlying to your cluster. So I've been working with OpenShift a lot recently, and I'm sorry, that was not intentional. And there's a lot of operators that can help you manage the nodes themselves. So basically, if you want to edit the network interfaces or MTUs or something, it's easily done inside Kubernetes and with things outside. Also seen people do cloud resources. So if you want to use an operator on Kubernetes to manage an S3 bucket or put something somewhere, I mean, there's no point in limiting this, right? Because it's code, you can write whatever. Same thing for delete. You could theoretically also write whatever, but usually it's undoing whatever happened in create or update, because this is cleaning up after yourself. So if your operator realizes that somebody deletes the custom resource, you usually want whatever the custom resource was supposed to manage gone afterwards. Cool. So after writing those two methods, you can package your operator into a Kubernetes deployment. That's as simple as packing the jar into a container and running it as a deployment on Kubernetes itself. You can see how we're getting into the circular version where you're then running a deployment with something that you might also want to be operating, but let's not go into this. I think there was a talk on operating the operators at some point. Cool. Then let's try this. Wish me luck with the demo. Let's take a look first at the operator itself. So this is a very simple version of an operator. We don't only have a Tomcat in this case, but also a web app controller. So two different controllers that are also in two different files. We register both to the operator. This is to show that an operator does not mean one operator equals one controller, but you can also have multiple controllers inside the same operator. Not the best example, got to be honest. So you usually don't want to, run a Tomcat as a pod and then upload your web app, but think of this as an example for what you could be doing with a custom application that actually makes sense as a demo. If we take a look at the Tomcat controller itself, you can see the creator up the resource method, which is basically just creating a deployment, so a Kubernetes deployment and a service. There are other methods, but we're talking to the Kubernetes API and creating two different resources. And for the delete resource, we are just deleting those resources again. If we now go to our cluster, you can see there's pretty much nothing running at the moment except for resources locally. If I start a watch up here on what do we actually have, you can see it's complaining if I do kubectl get Tomcat because it doesn't have a Tomcat yet, because it does not have the custom resource definition yet. Let's stop that for a second and actually create the custom resource definition. So we created two now, one for the Tomcats and one for the web apps. And if we take a look at them, so you can see them here, Tomcat, if we look at it, that was not open, edit. There's a lot of stuff that you don't need to care about. And then here you can see the names that we saw earlier. And if we go up a little bit, you can see the schema here. So in our case, we're only doing the replicas and the version on the Tomcat, and the var is on the web app. So basically it's the same as on the slides, but split up into two different controllers. Okay, so at this point, the only thing changed is we don't get an error anymore on the Tomcat. It just doesn't give us anything because we didn't create any resources yet. So what we do next is actually build and run our operator. There's a really nice Maven extension that you can, or a plugin that you can use to build a Docker file out of your Java code. So that's what it's doing right now. This might take a little bit. And then you can also see a nice bug that I have with Docker. I don't know if it's on my Mac or something with the build, but if we take a look at the build, you can see it's a little older than it should be, but I guarantee it is built just now. Okay, that's what we do. And then we take a look at our operator itself. In my case, I really just put it into a deployment, use the local image that I just built and deploy it on the cluster. So kubectl apply for the operator. And I have a separate namespace for it. I have a separate service account and two cluster role bindings, one cluster role binding or a cluster role, which is important because your operator actually needs to talk to the Kubernetes API and have more rights than you would normally have. It makes sense to kind of narrow that down to what your operator actually needs to be doing instead of doing the lazy version with cluster admin, because you don't generally want an operator, if it does get compromised, to be, almighty, especially if it's doing changes to your Kubernetes cluster. Okay, let's see if that one has come up happily. Yes, that looks to be running and ready. That's good. So what we can do now is take a look at our custom resource. It's very simple. It's a Tomcat. It's in Tomcat. Do I actually have that namespace? I do, that's good. And then I create that custom resource, which should just be creating a Tomcat 9 with 2 pods. I'm watching pods on the left, and you can see pods are coming up. It's great. Let's give them a little. In the meantime, let's check out if our service came up. Yes, we do have a service, which is just an output because I'm on my laptop. And go back to the pods. Yes, 2 test Tomcats came up. If we're going back and see if we can actually see our Tomcat. Moment of truth, yes. There's nothing on it yet, so you can see there's a Tomcat 9. And that's it for the Tomcat so far. If we do create the web app now, that's been applied. If we want to look at the web app, we can use it just like I've done with the pods and the services as now a resource of Kubernetes. And I can actually take a look at that one as well. Also lots of stuff that we don't care about. And then here, the important parts, adding a specific var file into a specific part and into the Tomcat that we defined just now. Okay. We take a look. That actually did something. Oh, we have our first sample application. Cool. And so there's been a bit mix of the operation side and the actual user side. If we're looking at the user side again, so what you want your users to be doing is not edit anything with the pods, not anything with the operator, but you just want them to go to their custom resource, edit that custom resource, and let's say they don't like that file. So we give them a different var file. We give it a few seconds. And second moment of truth. Should be on the right screen to refresh. Yes, we changed our app. This is kind of where my comment from earlier comes in, that this is not a perfect demo because you wouldn't actually live load a var file, you would just replace the pods. But this is also something we can do, right? So we can, for example, change the underlying Tomcat. Let's say we don't want the version 9 anymore, but actually this might be a nice thing to see. As I mentioned, the validation. So let's say we don't add an integer, but instead we do a string, we save it, and then we get an error message, invalid value. So this is basically what you get from the schema. You get instant validation from Kubernetes admission controllers. Okay, let's go back to, let's say 10. That works. And then we can actually see new pods being created. And because I created this as a deployment, it's cycling through. So it's creating a new one and then only deleting the old ones. So this is going to take a few seconds before the new ones are actually up and running. And once that is happening, we can check out if we actually updated our Tomcat. And we do that by looking at a 404 page. Yes, now we do have a 10. Cool. Deletion works exactly the same way. Instead of worrying about whatever has been created, you delete your web app. And after that, you delete your Tomcat and everything goes away for you. Taking a little long, doesn't matter. Here. And now you can see they're going into terminating. Cool. That was pretty much it for the demo. Going back to the slides. What we did here is the orange part. So we added our own custom version of another line before the Kubernetes parts. We basically added our own custom resource definition, then the custom resources as resources inside the API server. The custom resource definition is also a resource, so it gets a little, basically everything is a resource, but the definition is there, the custom resource is there, and the operator, which by the way also counts as a resource, is down here, but would also show up in here. So same thing, as soon as the custom resource gets created, the API server sends out the events. And what our operator does is listen to the events from our custom resource definition. And in our case, only the deployment and the servers. And you might now be saying, okay, cool, I can create deployments and services with a Helm chart. I don't need an operator. What is this? And then you'd be absolutely right. If you just want to use this for deploying, you do not need an operator. But what the operator framework does is give you an idea of how many levels and layers there are for capabilities for the operator. So it starts with the first one, what we've basically seen is installation. So you can install other resources or create other resources. The next thing that's happening is seamless upgrades. We've seen a little touch of that with the versioning of the Tomcat, but this is a little bit more than that, right? It's supposed to ensure that a user doesn't need to make sure the application stays up, but instead the operator does that for you. The operator makes sure that you have highly available versions, that you have access to both of them, that any kind of changes are continued over. After the upgrades, it basically is the full life cycle, right? It's not just upgrades, it's backups, it's storing any kind of data. Especially important because a lot of Kubernetes relies on stateless applications. So what operators can do for you is take care of all the storage parts that you don't want to take care of. The insights come afterwards. So as soon as you've managed everything and are taking care of things automatically, you get a lot of metrics, you get a lot of information. And those you can then use to go to full autopilot, or as one of the operator books refers to it as a tiny software SRE inside your cluster, which I found super adorable. And that's what you get if you have like a full-sized, super advanced operator that basically does everything of the application for you, from possibly auto-improving and auto-fixing small errors that you get from insights to taking care of the lifecycle and the application itself. Oh, if anybody's curious, there's a lot more info on the capabilities and how they decide which operator falls into what in this link. And there's a few more links out there. There's the CoreOS blog talking about introducing operators for the first time. It's a very interesting read. The Kubernetes documentation is great for anybody getting started with it. Honestly, it's probably better than most documentation out there, and they're also very happy about feedback and improvements. The book that I talked about is Kubernetes Operators, mostly focused on the Go version, but still an interesting read to learn about the different pieces. And as I also mentioned, you don't necessarily have to write your own operators. It's a good learning tool. It's interesting to see, and it might be necessary for some things, but don't forget to first check out if it's already out there, right? Because there are a lot of companies doing this, writing operators for existing applications and existing tools. So there's quite a lot already. So contributing might be better than writing your own version. And the frameworks that I talked about earlier are also linked here. That was it. I ran through this now a little faster than originally planned, but that was it. How are we looking at
Thanks,
questions?
Charlotte.
Thank you.
So we have a question. So random guy asks, what is a pod and a replica set? So he wants an introduction on those Kubernetes concepts.
Okay, so replica set is basically what a deployment actually manages. A replica set is a grouping of pods. So basically you have a deployment to select a replica set and a replica set to select the pods. and the pods are groupings of containers. So think of the replica set, the versioning of pods. Think of replica set as the versioning of pods, and pods as a grouping of containers. Did that make the random person happy?
I hope so. Let's see if he gives some feedback on that. I also have a question, which is, you mentioned that with the operators, you could fix small bugs or
It's like having a pod kicked out of something with an out of memory reason, for example, right? So your application might see that, and the operator might realize, oh, I need to make sure to have proper limits or something. Or to, this is again, the smart side is on the operator side, right? This is the idealization of software being able to learn and actually improve. Or if you have an application that gets a lot of load. So if you watch the metrics on your pods and see you get a lot more incoming than you would normally want or normally have, and your pods are having trouble dealing with that, you can have your operator automatically scale up.
Okay, you can customize the way you scale. Okay.
It's just an example, right? Could also be that if you have a regular bug coming up on the application and you can't figure out how to fix it, instead of doing it inside the application, you do it with the operator. I'm not saying this is good practice or anything, but could happen.
So we have yet another question. So Gunardi Sutanto is asking us, what's the best practices for the stateful set?
Best practices for stateful set. That's a fairly generic question. You use it when you have some sort of statefulness in your application, right? The idea is that the statefulness, so if you have an application that actually relies on, for example, specific persistent volumes, and those need to be coming up in the same order, that's pretty much what a stateful set gives you, right? It gives you the ordering of the pods, and it gives you the ordering of things that are attached to the pods. If you have an application that relies on that, it makes sense to use a stateful set. Best practices beats me. I would say check out the Kubernetes documentation. I'm sure they have a great design doc somewhere.
Okay. So Charles, I think we are done with the questions. Thanks very much for being here at Jnation. I hope we can have you again in the future in person here in Coimbra, Portugal. So thanks very much and see you soon.
Thank you.
Bye-bye.
Bye.
This is a box. This is our box. Some think in 2 dimensions, but we understand depth. Being a groundbreaker is a mindset. We are a fun, dynamic, creative, and a united tribe. At WIT, you have the pieces to build your own story. Are you a groundbreaker? If the answer is yes, join us.
Olá, eu sou Paulo Sousa, sou CTO na WIT Software. Nós somos uma empresa com 20 anos, começamos na área de telecomunicações móveis, a fazer software para operadores móveis, mas entretanto nestes 20 anos temos feito imensas coisas, desde fintech até saúde, até segurança e televisão, passamos por uma história muito grande. Olha, nós em 2020, nós, tal como o resto do país, sofremos com as alterações devido à pandemia. Sofreram especialmente as famílias das pessoas que trabalham connosco, e nós tivemos que aprender a digerir isso e a trabalhar com isso e reagir da melhor forma. Alguns foram afetados de forma diferente de outros. No entanto, aquilo que nós reparamos foi que muitas das coisas que nós tínhamos vindo a estar a trabalhar e que continuamos a trabalhar durante 2020 começaram a ser cada vez mais utilizadas. Eu disse que nós trabalhamos em software para operadores de telecomunicação, e os operadores de telecomunicação e muito do software que nós fazemos foi absolutamente essencial nesta resposta à pandemia em 2020, especialmente no que diz respeito a comunicações móveis, a comunicações em conferência, e foi muito interessante ver algumas das soluções que nós fazemos a serem usadas no mundo real, a serem usadas e terem grande adoção. Isto exigiu imenso de nós, exigiu imenso das pessoas que trabalham connosco, das suas famílias, mas nós gerimos isso da melhor forma e saímos disto vitoriosos e saímos disto com uma sensação de dever cumprido. Depois deste ano difícil que foi 2020, veio o ano de 2021, onde tivemos novos desafios, houve a recuperação da economia, surgiram novos projetos, surgiu a necessidade de recrutar pessoas, de as acolher na nossa empresa, e esse foi talvez o maior desafio, aquilo que nos consumiu mais energias. Darmos uma resposta que seja profissional, que seja bastante motivadora ao acolher novas pessoas, ao garantir que elas fazem parte da nossa cultura e garantir que tudo o que nós fazemos é com a melhor qualidade no meio deste processo de expansão. Na WIT nós somos groundbreakers. As pessoas que trabalham connosco gostam de ver desafios e de os superar. Gostam de ver uma dificuldade, trabalhar com os seus colegas e, enquanto equipa, perceber que conseguem entregar soluções. Ao mesmo tempo que nós somos ambiciosos, gostamos de servir os outros. Gostamos de ver uma dificuldade e, ao mesmo tempo, ver a luz ao fundo do túnel. Aplicamos o nosso know-how, aquilo que aprendemos, aquilo que são as tecnologias com que trabalhamos para resolver problemas reais e ver mesmo isso a aplicar-se no dia-a-dia das pessoas. E isso é isso que me motiva a trabalhar com todas as pessoas que estão aqui ao nosso lado, com quem interagimos no dia-a-dia. É esta sensação de superar desafios, entregar valor e criar coisas novas. E se quiserem pertencer a este clube, podem ir ao nosso site em witsoftware.com. Tem toda a informação sobre o que fazemos. Neste momento estamos a desenvolver imensas aplicações móveis, quer nativo, Android, iOS, cross-platform. Estamos a desenvolver aplicações em back-end. Estamos a fazer imensas coisas com DevOps. E podem fazer parte de toda esta inovação que nós continuamos a criar. Nós fazemos muitas aplicações móveis, estamos muito orientados para isso, especialmente por termos vindo do mundo dos operadores de telecomunicação, de software para telecomunicações. No que diz respeito a aplicações móveis, estamos cada vez mais a utilizar cross-platform, nomeadamente React Native, nomeadamente Flutter, ainda muito Kotlin. Agora, olhando mais para o back-end, em 2021 nós começamos a adotar cada vez mais a implementação, especialmente em novos projetos de serverless, de Node.js, em que, dependente da utilização, temos que fazer projetos que têm que escalar muito mais rapidamente, isso tem-nos ajudado. Agora, não especificamente sobre as linguagens e as frameworks, mas sobre a maneira como nós estamos organizados, estamos cada vez a ser mais ágeis. Adotamos metodologias, nomeadamente Scaled Agile, onde aplicamos tecnologias ágeis não só ao desenvolvimento do dia-a-dia, mas a todo o ciclo end-to-end, a toda a organização. Em todos os novos projetos que estamos a aplicar, estamos a incluir ciclos de CI/CD, DevSecOps, em que todo o desenvolvimento é o mais contínuo possível. Todas as soluções que criamos estão cada vez mais depressa em live, cada vez mais depressa a receber analítica, a receber dados de feedback e reagimos cada vez mais próximo a esse feedback. Portanto, tudo isto se coordena para que tudo o que nós fazemos e aquilo que nós temos vindo a fazer nos últimos anos e a culminar agora em 2021 é cada vez mais ágil, cada vez mais rápido e vemos o resultado daquilo que fazemos imediatamente nas mãos das pessoas que usam o nosso software.
Hi, everyone. Here we are for a new session on the Almedina track. So right now we have Alex Siovic. I'm going to say it wrong for sure. So please correct me afterwards. And Dmitry Alexandrov. So these fine folks come from Oracle. Alex is also the Cohen's architect over there. And they are going to talk to us about building scalable microservice for Java using Helidon and coherence. So guys, go for it. We'll see you later for the questions.
Okay, so probably I should start. So Alex Selvich, yes, and Dmitry Alexandrov. Okay, so lovely to be at least online with you this evening. Hopefully next year in Portugal. I've really never been there, and I really would like to be there. And today we're going to make a very intense session about how to build scalable microservices for Java with the product I'm working on in Oracle Helidon and another great product, Coherence Community Edition, which is presented by Alex Selvich. So we're going to be like not two parts, but two main baselines, two main streams of talk, and I hope you will like it. So safe harbor statement. This will be fast, but anytime you do business decision, please check once again. So let's start. So Helidon. What is Project Helidon? So we call ourselves a set of libraries for writing microservices. You can find more information on our official site, helidon.io, but actually you would probably ask yourself what Helidon is. And in Greek, it means swallow. It's a very fast, nice, maneuverable, awesome bird. which lives in like flocks, and every time it like flies in this flocks, it reminds us of microservices and all this microservices world. And I believe the name was chosen really cool because well, it simply reminds us what a microservice should be: really fast, really maneuverable, really still oriented in this well, maybe canonical world, but still like with its own rules. So Swallow is a perfect word for such a project. So, and the best part of it, I would say, so first of all, it's awesome, but even better, it makes it that it's Apache 2.0 license, like one of the first Oracle products which is under this license. That means that the code is there, the issues are there, we accept PRs. It's a community project. That means that it's not only us working on that project, it means that there is a community working on that project. And that means it really makes it community driven. And that's why it developed so nicely. So the main idea that is built on top of Netty, which is makes it really asynchronous and very, very fast. And once again, we are cloud native ready. That means that whenever you run your microservices, it doesn't mean that you just go to some REST endpoints and you have them. From the box, you have health, tracing, metrics, everything you need to run your microservices in cloud environments. And one of the best things, of course, is that like many other frameworks are just getting to native image support, and we are supporting it like from almost very beginning. That means that our support for VM native image is like approaching 100%, and everything we do is Growl native image aware, and at the end it comes like really native image compliant. So we are really working on that hard on that. And one other thing what makes this really cool is that we don't have any legacy with Java 8 world. So we are Java 11 plus world. That means that we enjoy all the benefits which came to us to, well, beginning from Java post 9 world. That means we are modular. We are enjoying many new technologies that came there. And our main goal is not to keep the version low. So our main goal is exactly the opposite, to keep the version really high. That means that we try to get rid of everything which is legacy, and we try to put only new stuff. So now as Java 17 comes, believe me, there's big work we're doing to adopt everything from there and you to enjoy the best, all the benefits that Java 17 brings you. So let us take a look at high level of the architecture, what Helidon actually is. So as I said, we are built on top of Netty. It is asynchronous, and all the services around it are wrapped in so-called reactive layer of Helidon SE. We'll come a little bit later there. But to serve you well, to make it really, really standard and portable, because standard means much to us, we are into standards. That means that we are doing everything possible to comply to the standards, and we are like, we try to do the best to be standard. That means that we are portable. That means that you can migrate easily to us. So then comes the microprofile layer. That means that all the microprofile specifications are implemented there, and we are like microprofile based framework. So this is like on the top, and this is like something which solves 80% of your demands. So let us actually jump in a little bit for people who actually don't know what microprofile is. Just two slides. It's an open source community specification for enterprise Java microservices. That means that it's not implementation. It's just a specification that you have to implement. It is now hosted under Eclipse Foundation. It was born mainly on our eyes because it's like 4 years old, when several participants like Oracle, IBM, Red Hat, Atomic Tribe, and even Microsoft sat together and said, we need a specification for microservices to make them portable, to make them standard, and to make them like, exactly industry standard. And with high cadence of 4 years per year, so several specifications are released, and these specifications actually, now there are it already started with 3 specifications like CDI, JSONP, and JOX-RS. Now there are 12 main specifications. You see, each of them evolves at its own speed. So there's open tracing for tracing coefficient 2.0, and health, for example, which is 3.0. It evolves a little bit faster. That means that this 12 specification actually fill most of the demands that are for running microservices and the clouds, and make them really useful. That means that you have fault tolerance, but you've got these configurations, so even the configuration is portable. We care for the health checks, for metrics, for telemetry, for delivering it to you. And this is actually, those 12 specifications are the core, and we do implement it. Actually, what we do implement is that we implement some micro profile specifications, as you will probably see from this side. We are for the delivery for this Helidon, which you actually get as a product. We also implement several specifications, like from Jakarta, as you probably see here. So there's like annotations, transaction persistence. We also do this, so get out of the box. And since we have some great demand of course in gRPC, we still deliver it to you. And now there is micro profile specification like GraphQL and several other specifications like long running actions that are not part of this 12 specifications I showed you, but this one is also delivered to you. So we are really proud of the fact that we fully support CDI, even in native environment. That means that it's not like a semi-support or not a partial support. We have full CDI support both in Java world and both in native image world, so which makes this really cool. Just a few words about Helidon SE. If you remember this layer, which is like intermediate layer, we decided actually not to hide it from our users, but to give you a so-called backstage pass. So you don't need to have to code in microprofile to get all the same functionality that you have there. So you have still config security, health check, tracing metrics, everything, but you are able to do this in pure Java, and you still receive even more benefits, like reactive stream, reactive messaging, and DB client, which is also we're proud of it because it makes your synchronous drivers work asynchronously with some magic that we provide, and you still are able to do this in pure Java. What does that mean? That means that like MP style on your right is done with annotations, and on your left you get the same result, but without any magic, without any additional managing stuff. You get in pure Java, and it works like way faster. So just an interesting time. This is all you need to know for Helidon right now, and I will give the word to Alex. Alex, go ahead.
Well, thank you. For those of you not familiar with coherence, I'll just go briefly over what coherence is and why you would want to use it, and then we'll get to the demo, which I think is the most interesting part of the presentation. So, a number of years ago, somebody said that coherence is the world's most expensive hash map. And it was funny because it was partially true at the time. It was a hash map and it was fairly expensive. But the good news is that it's now free. I mean, we open source Coherence Community Edition last year in June. So we're going to be releasing our 2106 update this year. We're doing releases every 6 months. So we are about to come out with a new release. And that's kind of what we are showing. Some of the features that we'll show in the presentation are going to be available in the next few weeks. Next slide, please. So what is coherence? Coherence is the first in-memory data grid. It created a space back in 2001, so it's about 20 years old now. But even though it's 20 years old, it is very well suited for modern cloud applications. One of the reasons for that is that coherence was always designed to scale out. It was always designed to build distributed systems. And that's kind of what modern cloud applications are. They are distributed systems, and coherence helps you build those types of applications. It is also a Java library, so it's very different. I mean, it is a data management technology. You can compare it to Mongo or to Redis or to any database if you wish. But it's, on the other hand, it's the way you use it, it's more similar to an embedded database, something like H2 or Apache Derby or something like that, right? So you can embed it into your application, but it's not limited to tests and some simple examples that where you would run an embedded database, because it allows you to scale out across many servers, many processes. It will cluster together. It is fault tolerant because any of the components can fail and your data is still safe, et cetera, et cetera. But from the usage perspective, it is just a library. You embed it into the application and you use it. It is also easy to deploy and scale in Kubernetes using Coherence Operator, which is something we'll be showing in a demo in a few minutes. And we have built-in support for monitoring with Prometheus, Grafana, and Jaeger. So you can use open tracing to see how your requests are being processed. You can look at the coherence metrics in the Grafana, et cetera. And as I said, we've had open sourced edition since June of last year. Next slide, please. So in many situations, people say, I want to use Coherence for caching. And yes, Coherence is distributed cache. That's how it started. That's what it was designed to do initially, but it's actually a lot more than that. At the basic level, it is scalable, fast, persistent, general purpose KV data store. Cache implies that you can lose data. Coherence can certainly be configured to work that way, but it can also be configured not to lose data. It stores data in memory for fast access, but it also optionally persists it to disk for durability. So if you want to have persistent data, you can easily accomplish that. It's basically just a flag that you switch. It partitions data across many cluster members to improve both system capacity and throughput. Obviously, the more members you have, the more data you can store and the more requests you can process in parallel, because we'll do everything we can to parallelize requests across the cluster. It creates backups of your primary data copy as far away as possible from the primary data, which is very important in the cloud, because you don't want to lose data if something fails. So at the basic level, Coherence is aware of topology of the cluster, so it will always create backup copy in a different JVM. But those JVMs may live in containers, and those containers may live on VMs, and those VMs are on some physical servers, which are in some data center, some availability domain in the cloud. And Coherence is aware of all of that. So you can configure it to back up as far away as possible, which means that for any primary copy of the data, if you have multi-AD deployment in the cloud, we can actually ensure that the backup is created in a different AD. So if your availability domain fails, your data is still safe. So you can, you have that degree of fault tolerance that is, somewhat driven by the product itself. Some things need configuration. The good news is if you're running in the cloud, our Coherence Kubernetes operator will configure everything for you, so you're safe, even if the whole availability domain fails. And then from a functional standpoint, it's not just gets and puts. We also support queries, aggregations, in-place processing of the data, and we'll show some of those features in a demo in a minute. Next slide, please. It is also an event streaming platform, and there are a couple pieces to it. I mean, we've always had server-side and client-side event listeners, so you can actually react to data changes in any shape or form. So you can, when a new object, when a new entry is inserted into Coherence, you can react to that when it's updated, deleted, and you can do it both on the server side, which means that the code that you want to execute will execute only on the member that basically owns that piece of data, that owns the primary copy of the data, or you can do it on the client side. So anybody who is interested in the change can react to it. And that's typically used by customers to update UIs in their desktop applications. Like if you're looking at a stock portfolio and you want to update positions as they change on the server side, you can actually do that very easily using client-side events. And then more recently, we've also added topics which allow you to do pub-sub messaging. So you can basically have publishers and subscribers publish messages to topics, receive messages from topics, et cetera, et cetera. So it's all built on existing Coherence primitives. So it's a new feature, but it's built on something that's been around for a very long time. So and has been tried and true in production. Next slide. And finally, yes, we can do caching as well. I mean, a lot of the caching options that you may be familiar with kind of were invented to some degree by people working on coherence. You can do partition or replicated caches, time or size limited. Obviously, this wasn't invented by coherence. This has been around for a long time. But then there are some things like read through, write through, which allow you to integrate your caches with backend data stores and to automatically update data stores or insert data into the cache transparently. So you don't have to do lookup. You don't have to look up in a cache, and then on a cache miss, you go to the data store and then you put the thing in a cache. You can basically have the cache do that for you. So on a miss, we'll automatically go to the database and get the data, for example. We can also do client-side caching. So you can bring data closer to the client to optimize your read performance by using continuous query caches and near caches. So those caches will be kept in sync with the backend cache using events. So as the data in the backend changes, the caches will be invalidated or updated depending on which type of the front cache you're using. And live materialized views are basically what I mentioned. You can define a query that says, okay, I want to have subset of the data. I want to have all the positions for this stock symbol, for example. I want to have them in my front cache, and as they change on the back end, that live view that's in your local process will be automatically updated. Next slide, please. So it's time. That's pretty much all I had for coherence. So let's talk about the demo that we are going to show you. So this is a simple to-do list application. I mean, the functionality is very trivial, but at the same time, it allows us to show a number of features. And I think it's good to start with a simple demo and go from there. The code for the demo is available on GitHub. You have the link at the bottom. And there is also a series of articles. We'll provide a link to our blog at the end of the presentation, but there is a series of articles on Coherence community blog that basically walks you through building this application, building the backend, building the front end, running it in Kubernetes, deploying it, managing it, et cetera, et cetera. So, you can always refer to that for more details, because we can't possibly cover everything in a 50-minute talk. So with that, I'll hand it off back to Dimitri to get us started.
Oh, it looks awesome. By the way, if I remember, there's like Java magazine articles as well, series.
Yes, I mean the copies of those are on the blog.
Lovely.
On blog, so
yeah. A lot of read. It's nice. You should try it. And okay, let us actually create this thing. We will do like semi-live creation of this awesome software. So Helidon may be like the foundation for your microservices. So whenever you need to serve this data via REST and other protocols, it is the way to do the best. So how to start with Helidon? So we're Maven oriented people. That means that the only thing you need is just to generate an archetype, which is here, and then just to include one dependency, and you are ready to start working with Helidon. You may also use the microprofile starter page, which is you just choose the microprofile version, and just choose the right the right framework, and it will generate you the POM file, and you're ready to go. But for our how I say not clients, I would say for the programmers who actually prefer Helidon, we care much, and that's why we created a special CLI application where you can receive even more functionality and some code generation to not only initialize your application, but for all the cycle that you develop this application. But let us actually see it in our demo. So we have a console, and to start a project of Helidon, so you just get a brew, get it from the link I sent on the slide. Just get the application, and you just type Helidon in it. So it is available for all platforms like Linux, Mac OS, and even Windows now. So Helidon, I got Helidon in it, and like in our it looks for the latest version, so it's very cool. And that means that if you remember your childhood, you just answer a few questions to the console. So this was the first application I always wrote. and it will get you something useful. So as you probably see, we have two flavors, which is SEMP. We'll create the micro profile version of it. And we will use like a quick starter, which we will then transform to the application. So you just enter project name, group ID, artifacts ID, versions, package name. So we'll keep defaulted in the interest of time. And the last question is like start development loop. What is it? I will show you a bit later. So, and we are actually done. So we will use our favorite IDE to actually start it. So I hope it will be like fast right now. So it usually, well, when you stream something, it is always like a little bit slower than usual because, you know, Zoom takes a lot of your resources. So this is an application which was generated for you, and you see it always starts with a very nice README. So you will be able to see how it works and what you should have. Well, let us jump into it and see what we have. So we have only two classes, and this is absolutely sufficient to run your resources. It's like a greeting application. It will greet you. And what we have, so first of all, we have a greeting provider, something like, you know, sends you greetings, like getting the greeting messages, which we will then inject into our greeting resource. And as you may probably see, this is a very familiar annotations. These are very familiar annotations for everybody who codes in micro profile way. That means that we are standard. That means you can easily migrate your application to Helidon because it's standard. Okay, so we will create, so it actually created us a greeting resource, which is request scoped. It injected us our, you know, greeting provider. So full CDI support, as I say, and there are a few messages like default, etc. But once again, this is not so interesting. We don't need it right now. We need to create task applications. And we will just delete everything we have here. And let me jump into it. I have, just in the interest of time, I have created like an initial service that we're going to implement. So first of all, task is the core. Task is something which is, you know, which we are going to manage with our management application. And it is like a POJO, a usual POJO, which has like 4 fields. And so the next thing, we are going to do a service who manages this. It's like an abstract service because we are going to serve this, this data in 3 ways. We're going to make it in REST, gRPC, and GraphQL way. And you will see how easy it is. So once again, we have, for now, it returns nothing because Alex will then take over and you know, fill in those methods with right usage of coherence. So we will create a task. We will like get all the tasks. We find task, we delete task, we delete completed, we update description. So this is enough functionality, which is we are going to implement. As I said, we want to serve it in several ways. So the first and the most usual way of serving this data is just a REST endpoint. You see, as you probably saw from the quick start, we have a set of annotations, which is a micro profile annotation. We say path, we say application scope. We are constructing this object, and then we have several methods like get, post, you know, delete, where we actually reuse the service, the to-do list service, and connect to it, which we simply inject here. So we just inject it with CDI. Absolutely nothing special, we just use it. So as you probably see, regular set of annotation, but as I said, we want to do it not only in REST, we want to do it in for example, gRPC way. So there's another class, which the only thing you actually need to do is to annotate it as a gRPC source, make it application scope, for example. The same way, inject the to-do list service, and then with some different set of annotations, you do almost the same. So you have a memory task which creates a task for you. We'll get, so if you want many tasks, there will be like streaming service with tasks. The other applications are just unary. That means that we delete updates and you know, create tasks. But as I said, we want even more. We want to serve it in GraphQL way, because GraphQL is awesome and it's very popular. You just create another class, you just annotate it with GraphQL, and you actually use the GraphQL specific annotations, which are like, for example, if we do something which is create, we do a mutation. If we just query those tasks, it's just a query with some description. Whenever we change something, it's a mutation. Whenever we query something, it is just a query. So once again, you get all the annotations and you see the reuse of this class is just awesome. Once again, the only thing you actually need to do is as I said, we are very modular. So you just add the annotation for microprofile, for GraphQL, for gRPC, and you are done. So I believe now as we have the skeleton of all of this stuff, it's now a great idea to fill it in with some caching and persistence. For that, we have coherence. And Alex, please take over and show us how to do this. I will stop sharing and we will continue.
Thank you. All right. So let me just clear my screen a bit. Okay, so as Dimitri has shown you, basically have this to-do list service, which is the meat of our service implementation, and then those three facades, REST facade, gRPC facade, and GraphQL facade all delegate to. So let's see what we need to do to implement this. There are actually a couple things we need to make, a couple changes we need to make to what Dimitri has shown to make classes suitable to work with coherence. For example, task needs to be serializable, but we're not, so we could make it serializable and use Java serialization to store it in coherence, but we're going to do something different, and we're going to make it the portable type, which is a coherence proprietary serialization format that is much more efficient than Java serialization, allows us to actually access this class in its serialized form from different platforms, from .NET, from C++, etc. Right? So we're going to annotate the class with that portable type. We're going to annotate the fields that we want to serialize with at portable. And that's pretty much it. We're done with the data serialization requirements. Second thing we're going to do is implement our data access layer. And for that, we're actually going to we're going to define a task repository class. If you're familiar with domain-driven design, this is, or Martin Fowler's enterprise architecture patterns, repository is a typical way to access some entities. In this case, we want to have repository of tasks. And coherence provide us with a convenient abstract repository class that we can extend in this case. And we only need to provide a couple things. We need to inject the named map, which is coherence named map that we're going to use to store the tasks. And we need to implement these three methods. Get map returns task, get ID tells us how to return identifier, entity ID from a given entity, from a task in this case. And then we need to know, the repository needs to know what the entity type is. So that's really all we need to do on the repository front. And then we can use that repository to implement our service, right? So we inject the repository into our to-do list service. And then when we call create task, it is as simple as saying task saves, new task, task save, new task with a description. To get tasks, we use coherence query functionality. So we can define a filter. If Boolean flag is specified, if we are querying for completed tasks or for active tasks, this flag will be specified. If it's null, then we want to see all the tasks. So if the completed is null, we'll return always filter, which will give us all the values, all the tasks back. Otherwise, it will return an equal filter where task get completed is equal to completed flag that's passed in. So notice that we are using, these methods always in equals, they're static methods on the filters DSL class. And the way you construct a task is by basically providing a property that you want to query on. In this case, task get completed using Java method references. So it gives you a type safe way to actually define these queries. And then we call task get all order by. We pass the filter that we want to query on, and we pass the attribute to order by, and that's the creation time. So this will give us back a collection of tasks display on the screen or to return to the client, right? Find task with a given ID. We'll attempt to find a task with an ID if it, by calling task get. If it finds it, it will return it. Otherwise, we throw not found exception, so it can be handled properly by the REST API, and it will return 404 error code, etc. Right? Similar thing with delete task. We'll call task remove by ID and return the old task because that's what our API defines. So it will return the remove task. If the task is not found, it will throw 404 not found exception. Then we have remove all, which is again with a filter. So if get completed is true, we'll remove all the tasks with that attribute. And then to update the description, we can call, this is actually where things get interesting. Unlike many data stores where your typical pattern would be read, modify, write, Coherence actually allows you to send the update to the node that owns the primary copy of the data. So in this case, we want to update description for a task with this ID. So instead of fetching that task, updating it and sending it back, which is both inefficient and introduces some concurrency issues, we can simply say that tasks update with this given ID by calling this method with this argument. So what will happen here is this whole function will actually be sent and executed on the server. So we will execute set description by passing this parameter to it on the node that actually owns the task with this ID. So instead of bringing data to the client and moving data around, we're actually sending function to the data and executing it locally where the data lives. And it's the same with a completion status. So we update completion status by calling set completed on the task somewhere inside of the cluster. So that's pretty much it. I mean, that's our implementation. It's fairly trivial. It's fairly easy API to use. I mean, there's a lot more functionality on the abstract repository than I'm showing here. So you can see there are a bunch of there are aggregation methods, there are stream methods, things like that. So it's a fairly rich API that allows you to do most things you would ever want to do with the data access repository class. So there are a couple additional things I wanted to show you. I said earlier that you can use Coherence events to update clients. And that's exactly what we're going to do in this case. We're going to have 3 clients. We're going to have JavaFX client that uses gRPC API. We're going to have REST client, React application that uses our REST API. And we're going to have GraphQL client. So whenever something changes in the cluster, in Coherence, whenever data changes, we want all of those clients to be in sync. And to do that, we are using events. So in this case, we are, again, injecting task repository, and then we are adding listener to it. And we create a listener that will basically, whenever task is inserted, it will broadcast it to the SSE broadcaster. So for REST API, we're using server sent events to notify the client. And so we notify client whenever task is inserted, updated, or removed. For gRPC API, we do something similar but slightly different because, again, gRPC doesn't have SSE, but it has the ability to stream data back. So we implement server streaming methods in gRPC that, again, registers listener that will send task inserted, task updated, or task removed event to the client. So now that we have all that, I actually have the application running. So again, I have 3 APIs. The first one is React application. It's actually served by the same server that is running Helidon and Coherence at the moment. The second one is my JavaFX application. It uses gRPC API. And the third one is GraphQL client, which is GraphQL. It's just a basic generic GraphQL client. So if I enter a task in any client here, you can see that both, GraphQL doesn't have support for events, but both React client and JavaFX client are kept in sync whenever I change something. And then I can also query the data in my GraphQL API, and I can see that I'm getting back task 1 and task 2. I can also create data from my GraphQL API, and it should show up. Yep, it took a little bit. So it should show up in the other 2 events. And again, if I modify it somewhere, it should be modified everywhere. So that's basically how it works. You can see, you saw the application. It's fairly simple to implement. The data access API is pretty much trivial. What Helidon gives you, is very easy way to support all these different methods, right? You want to do REST, you want to do GraphQL, you want to do gRPC. It's easy to do any of them or all of them, as in this case. So, but that's only part of the puzzle, right? So we have right now the way this works. I basically have a single server and a single client running locally on my laptop. But that's not how you would deploy this application, right? One of the premises of this talk is how do we build scalable applications for the cloud, right? So having a single process is not what's going to get us there. So one thing that we can do now is, remember, because coherence is just a library, Helidon is just a library. It's all Java. It's all fairly lightweight. So we just need to add a couple dependencies to make this work, right? So Dimitri showed you, you added GraphQL server and Helidon and gRPC server. We need to add a couple of coherence dependencies. We need to add coherence CDI server, which provides integration of coherence with Helidon and allows Helidon to bootstrap coherence via CDI. We also need to add coherence gRPC proxy. Well, we don't in this case, but it's a leftover. And then we also add support for MP config, microprofile config, and microprofile metrics, which will allow us to, allow coherence to use Helidon microprofile configuration, and it will actually send send coherence metrics to Helidon so they can be scraped by Prometheus. And finally, what we have configured here is a way to create a Docker image from this application. In this case, we're using Jib Maven plugin, and we are using distroless Java 11 image as our base image. We let Jib package everything up into a Docker image. We have the Docker image uploaded to GitHub Docker repository. And once we have all of that, once that executes, everything gets uploaded, we can actually use coherence operator to deploy this whole Helidon coherence application into Kubernetes clusters. So this is the deployment descriptor that we use. So coherence operator introduces a custom resource type, custom resource definition. And in this case, we are calling it, we're calling this to-do list deployment, where we say that we want to start with one replica. We want to create, we want to use this image, which is what we push to GHCR.io. We specify, for demo purposes, we want to sample everything. So it just this configures Jaeger to basically trace every single operation. And then coherence operator also has special support for Helidon applications because it effectively changes. By default, coherence operator will use coherence default main class. But when we say that the application type is Helidon, then it will use Helidon main class and let Helidon bootstrap coherence internally. And then finally, we also enable persistence. So in this case, when we run this in the cloud, we don't want our tasks to be lost if the cluster goes down. So we want everything to be persisted. So we turn persistence mode to active, and we configure persistence volume claim, in this case to use OCI BV because we're deploying it to OKE cluster in OCI cloud with a 50 gigabyte per block volume. And then we have some JVM settings, just heap size and ports that we want to expose, gRPC on 1408, HTTP on 7001, and we want to enable Prometheus service monitor. So that's pretty much all you need on the Kubernetes side, which brings us to, what do we have? I actually have this already deployed in the interest of time. And right now I have 3 replicas. And you can see that and there are 3 pods, they're backed by a stateful set. And basically every every pod has a PVC attached to it. So that's fine. And if we look in, oops, and this application is running. I mean, it's here. One. So this is actually running application in the cloud. This is not on my laptop. This is actually accessing this 3-node cluster in the cloud. And if we see our Grafana dashboard, you can see that we have 3 cluster members running. But again, 3 cluster members is really not a lot. But it is kind of important to understand. And then when we say that these are stateful applications now, so each of these pods here, to-do list 0, 1, 2, each of these 3 pods is both storing data and processing your HTTP, gRPC, GraphQL request, right? It has both Helidon and Coherence bundled together in a single JVM. It runs that, it exposes the ports so you can access your APIs, and it manages the data for you. And it is as easy to scale. Like you would typically, if you want to scale stateless application, all you need to do is scale this deployment in Kubernetes. And that's exactly what we can do here, right? So get to it. So we can go from 3 to 100, right? And I don't know how many resources I have here, but hopefully this works. But it will take some time. So if we look at the Coherence deployment now, you can see that we have 100 replicas, 3 already, and we are in the process of scaling. And if I look at the PVCs now, first, you'll see that a bunch of PVCs are pending. They're being provisioned in the cloud. And same thing for the pod. Pods are actually waiting for the PVCs to be provisioned so they can be initialized and started. But you can see that we went from 3 to 100 nodes. And it will take a few minutes for this to shake out, for PVCs to be allocated for the pods to initialize, for the application to start and join the cluster. But in the end, we will have a 100-node application cluster that runs your GraphQL, gRPC APIs and stores the data for you. And by scaling it from 3, because if you look at here, we have 6 gigabytes of capacity here because I'm running 2 gigabytes per node. By going to 100 nodes, we'll basically have 200 gigabytes capacity in the cluster for as far as data storage goes. So again, I hope this shows you how easy it can be to scale stateful applications and how easy it can be to write them. And I believe with that, I think we're pretty much at the end. And let me close with these slides, and then we can open it for questioning. So Dimitri, do you want to talk about Helidon resources that are available?
Yes, of course. Yes. So thank you very much for the demo. Once again, this is because of, we are like spread in the world. Usually it scales very fast because Helidon and Coherence are both very fast. Each start is like a fraction of a second. So it's just because of we are away. But if you want to learn more about Helidon, so go to helidon.io. And for the people who like to read, a few of them this way, but this time. But in Medium, we have some long reads and very cool articles which we write about using the technology. Once again, the code is all available on GitHub, so just go there. Whenever you don't like to read and take too much into code, there's a YouTube channel where we prepared a good set of videos for you to demonstrate the usage of each of these modules, technologies, etc., etc. So they're constantly filling it with new content. And whenever you have questions, so helidon.slack.io is your resource to do this. We are answering questions very fast. So Helidon is cool. We accept PRs once again. Thank you.
All right, and for Coherence, our main community site is at coherence.community. So you can find more details about the product and links to documentation, and links to pretty much everything else on this slide there. So if you remember one link, that's the one to remember. Our Medium blog has articles on many things Coherence related, including series of articles that was published in Java Magazine initially, with more details on how to build this particular application that we just showed. Coherence is on GitHub as well. github.com/oracle/coherence. We have our YouTube channel as well with many old and new videos, mostly old, but we're adding content as we go. And then you can reach us if you need to talk to us. The best way to reach us is via public Oracle Coherence Slack. And with that, we'll like to thank you and open for questions if we have any questions.
I hope I wrote it correctly. Please, is this correct in Portuguese?
That's great. Muito obrigado.
Thank you so much.
So I think someone is typing a question. Let's see. Well, I think not, but I have questions, plenty. But let's not. So, is there a version of Coherence, the community edition, on cloud providers, on I don't know, Google, AWS, or
you can
Azure?
I mean, is there a managed service?
Yes, a managed hosted solution.
Hosted solution, no. I mean, and it's kind of we are thinking about it. We are working on it, and there will likely be one at some point. I can't say when. I can't say where. Definitely in Oracle Cloud if it shows up, right? But ideally, we would like to have it everywhere as well. But the other point is, it is just a library, right? So if you know how to run Kubernetes application, you can easily run Coherence Kubernetes application, right? The operator does a lot of things for you to make it more manageable, but ultimately it's not really that difficult to run. Now, yes, I mean, there are obviously all these systems at scale become more difficult to manage, and it's easy to show a simple demo, and things get complicated fast, right? But the functionality, the features that you need to actually run this in production, they're already there, and they're all open source. So operator is completely open source. You don't, like many of our competitors, they will give you some stuff free, and then when you want to use it, you really need to pay for anything that you need for production. That's not the case here. I mean, you can use everything that we showed here in the demo. Operator, Coherence Community Edition, persistence included, all of that stuff is in the Community Edition. We're not showing any commercial features here.
That's great. Great to see that.
Yeah, but we are hoping to have a service someday, and then you can just build application this way and let us run it for you.
Okay, so Alex, Dimitri, thanks very much for being here at Jnation. Hope we can see you here in future editions in person in Coimbra, Portugal.
That'll be awesome.
So thanks very much, and see you soon.
Thank you.
Thank you so much. Thank you.
Bye,
it was
everybody.
a pleasure. Bye-bye.
You know all the places you've been. It's the unknown that drives you. The search for something new, for what's next. We followed the unfamiliar and started unraveling new paths. We are leading the way into the future, and the journey has been amazing. We are on the road of disruption towards success, never settling down. Volkswagen Digital Solutions, exploring new roads.
Volkswagen in 2021, it was one of the most important years for our company. We have been growing in a really fast rhythm. And one of the biggest achievements as a team, it was for sure the confirmation of the really good job and awesome delivery that our team is doing here in Portugal. We have really good professionals delivering top quality projects for the Volkswagen Group. And this confirmation of trust and continuous of growth has been one of our biggest achievements as a team. We already have a big spectrum and variety of projects, from support to development from scratch, and we aim to continue to grow even more. So wish us luck. Profiles that Volkswagen Digital Solutions is hiring. We basically want people with curiosity to learn. Of course, we have some limitations in terms of tech stacks, depending on the team, depending on the tech unit, depending on the department that the person will work for. But basically, we want people that are a match regarding our culture and that is eager to learn and develop itself to go to the next level. So we are quite open, and we have a really fun culture to be with. And we are proud of the people we have, and for sure we know that the people we will hire in the future will match our expectations. For a recruitment process, we basically adapt depending on the department, depending on the team. So you can have a challenge, you can have an activity to do if you are applying for designer position, for a software development position. And we believe that like this, we can have a more suitable and customized experience for us and for the candidate. The Group has been investing in the last couple of years in the digitalization of the company, in the several brands of the group, and not only in Germany, but also outside of Germany. Of course, Portugal was being evaluated, and in the end become one of the place to invest and to grow a team. And it's not only Volkswagen, but Portugal has a really good lifestyle and culture. It's easy to convince managers or engineering managers to move to Portugal to start and ramp up companies. We have a really international mindset. We have skilled people from junior talent to more senior. We have a really diverse IT community. We are economically attractive as a company, of course, and our geography, our location as a country is also really interesting. So all of these characteristics as a whole made us a good place to invest. And since 2019, the year we officially opened the Volkswagen Digital Solutions in Portugal, it has been proving all over the time that it has been a good place to be. Volkswagen Digital Solutions looks really promising. Like I said, our partners have been really happy with the work we have been developing in Portugal. When I say partners, Volkswagen Group. And we already have 26 teams developing projects in Portugal. And we have the confirmation, recently we even came out on the news about it, that this investment will continue to grow. We already have a really big challenge of growing 100 people in 2021. So looks promising, looks really challenging, but we are up to the challenge and we want this. So I'm sure we're going to double the number of projects in the next few years, and it will be fun.
You can write the best code in the world. You can run the most complex systems. But things get really complicated when you have dozens of different technologies and hundreds of processes. Fortunately, it's JFrog to the rescue. Firstly, you need universal tools that can integrate seamlessly with all the build technologies in your CI/CD stack and all major cloud platforms, so you can start speeding up software releases without delay. Second, you need to automate every part of your DevOps pipeline, end to end. This will eliminate repetitive, manual steps while letting you enjoy much faster feedback loops so you can get higher quality releases to customers faster. Next, you need a proven way of catching potential vulnerabilities and license compliance issues, wherever they may be hiding in the DevOps cycle, so you can stay out of the latest security disaster headlines. And of course, you need the flexibility of a cloud on-prem hybrid solution that offers high availability, disaster recovery, and is easily scalable and enterprise grade, from code right through to production. The good news is that you don't have to look very far to find this. JFrog offers you an end-to-end DevOps platform for creating, managing, and distributing trusted software releases fast to anywhere in the world. It's why 5 million developers already count on our universal DevOps tools to do their job better, faster, and more securely. So wherever you are in your DevOps journey, let JFrog smooth the ride, automating your software delivery process. Learn more or get started right away by visiting us at jfrog.com.
Hi, everyone. Welcome to another session of the Almedina track here at Jnation. For this session, we will have Elder Moraes. He comes from Red Hat, and he's going to present us your Java application cloud native ready, a live experience. So it's going to be live coding. Is it, Elder?
Yeah, a lot of live coding. Looking forward to it.
Okay, so I hope you have sacrificed some lines of code to the gods of the live demos, so it goes well.
Yeah, otherwise we're gonna have some fun about me, so that's fine.
Sure. So go for it. I'll see you for the questions later.
Okay, so thank you, Bruno, and thank you everyone who are attending to this amazing event, Jnation. I'm very happy to be here. Unfortunately, not yet at physical presence, but we are still doing what we can here. I hope you are all safe and sound. Okay, guys, so let me share my screen with you. As Bruno said, let's talk about Java code at cloud native age. Okay, so how can we make Java work at the cloud native approach? All right, so to get started here, to warm up our engines, I would like to run a quick demo with you guys. Okay, and for that, I kindly ask you to go to this website here, demo.eldermoraes.com, or please you can also scan with your cell phone or just go to the URL. And if you can do both, it's interesting as well, because at some point of the demo, our application will behave differently if you are using a mobile phone or a browser. So it will be fun here. All right, so I will give you like 10 more seconds to access this application here, demo.eldermoraes.com, or please scan our QR code. Okay. 5 more seconds, and then we are good to go. All right. So welcome everyone again, if you are just coming here right now. And probably if you are accessing this application, you are seeing something like this. Okay. This, let me refresh here. Okay, so this is our application. It should be changing. It's not changing. So Bruno, it's all right. I should have offered some sacrifices before. Let me check here. Okay, now it's great. Okay, so maybe if everything is working on your side, you are seeing an application that sometimes is green, sometimes is blue, sometimes is green, sometimes is blue. What we are working here is what we call a blue-green deployment. Okay, so actually I have here two different applications. One application is green, one application is blue. And this is a Java application, of course, a very simple Java application. But this application is built and deployed following a lot of cloud native approach. So basically here I have a service mesh, I have I'm deployed, this application is deployed on a cluster that is orchestrated. So I have a lot of good practice, best practice that it's recommended for cloud native applications, okay? So what I'm gonna do right now is to deploy another version of this application. It's another application actually, but I will put this new application on the same load balancing, okay? So I have one blue, I have one green, I will have now a yellow or a canary deployment, okay? So let me go just and do this. Okay, for the sake of the time, I will not get in too much details because the details are reserved for the demo part, okay? So for the live coding part. Now I have the canary. So if the gods are happy right now, maybe we will have a yellow application appearing sometime here right now. Okay, now we have the yellow. Okay, so why not? Right now I have 3 applications: blue application, green application, yellow application, and all of them balanced in this gateway here. Okay, so one thing that I could do, for example, I can make all the requests, and let me just check my scripts here. Okay, 7 blue. Okay, so just go here, for example, and change to blue. So once this script it's done here, I can make all the requests going to the blue application only. Okay, and if you notice, I can change the way that my application behave without changing its code, because the way that it was built, that's the fun part and the smart part here. I can also change for green application. Okay, so now everyone it's going to the green version. And finally, I can also change to the yellow application or the canary application. Okay, so now everyone going to canary application. All right, now here comes the fun. I can, for example, do this. I will change everyone using Firefox to the canary version, and other users will stick with the green version. So let's just apply the script here. Okay, this is a Chrome, okay, a Google Chrome, as you can see here. Let me get my Firefox here. I will open my Firefox here on demo.eldermoraes.com. Oh, I have some issue, whatever it is. Let me get a private window, demo.eldermoraes.com. Okay, some cache, no worries. Okay, so the Firefox, it's stick with the canary version. All right, so right now I will make another change here. I will move everyone that's using Android. So if you use your cell phone and you are using an Android, right now you will just see the canary version, and everyone else will stick with the green version. So let me change here. Okay, so Firefox using the green, and okay, and let me go to Chrome. Okay, Chrome here, it's on green. Now everyone using an iPhone, it will stick with the yellow. So if you are using right now an iPhone, you will see the yellow, and everyone else, as for example here, it's in Chrome using a green. And finally, everyone using a mobile will stick with the yellow or the canary, and everyone else is still using the green. Okay, just a quick demo, guys. I will, because the service mesh part especially is very huge. So just would like to give you a final experience of an application using some approach that I will show you right now. Okay, so thank you for the help with the demo. And right now, let me go back to my slides here. Actually, I almost don't have any slides, okay? So I will just open in a second. Okay, demo. Okay, and that's the demo that I just showed you. And just to introduce me very quickly, my name is Elder Moraes. I work at Red Hat as a developer advocate. I'm based here in Brazil, São Paulo, and I'm running the Red Hat Developers Program for Latin America. I'm a Java champion. I'm a developer advocate. I'm a board member at SoulJava, one of the biggest Java user groups in the world. I published the Jakarta EE cookbook. If you are working with Jakarta EE, maybe my book is interesting for you. And my mission here and as a professional is to help Java developers to build and deliver awesome applications. All right. So no more slides. Let's go back to the code. All right, guys. So what I'm going to do right now is this. I will build an application using microservice approach, using containers, and using REST clients, and adding some health checks, some well, a lot of stuff that I'm going to build right now. To gain some time here, I built some code before starting this session, and right now I have an application running here. So let me show you some stuff. I will make it bigger. And this one also bigger. Okay, so here I will just make one change. I will change to, because I'm connected to a Kubernetes, okay? My Kubernetes is running on AWS because we will work with Kubernetes also today. Okay, guys, I have here an application that is managing some fruits, all right? So I will just show you very quickly how this application works. So basically, let me get here a, what did the other guy, this guy here, okay. Okay, right. So basically, for example, oh, I have an error here. Let me stop here. Okay, so the gods, them are not happy today. Okay, let's launch the application. Okay, good. Let's go again. Okay, okay. So, okay, so I have an application that is managing fruits. So if I get this very same URL here and go to my browser, and I have these fruits here. Okay, mango and strawberry, and both of them are from Spring. Let's see this code just to show you what is happening here. Basically, I will close these guys here. Okay, I have an entity. It's a fruit. It has a name, it has a season, and this is a panache entity. And I have here a custom method, a custom finder, find by season, where I pass any season and I get the results. And I have also a fruit resource, is a REST endpoint, okay, just easy peasy. And I have here a list of fruits. If I pass a season, I will return, find by season. If not, I will just list my entire entity. And I have here another method to create new fruits, okay? Just to, and all my lists of fruits are coming from this insert here, just to have some more data. Okay, guys, so let's start making this application here more fun for cloud native reality. First thing that I would like to do right now is to get this application and deploy on my Kubernetes, okay? And if you ever worked with Kubernetes, you know that it's not exactly something easy when we think about building all those YAML files, okay? So yes, Kubernetes is powerful. It will make your life easier, but to get your application up and running, sometimes will get you some more enforcement to build, especially the YAML files, okay? But if you are using Quarkus, if you are using the best practice for Java with Cloud Native, your life will be easier. And as this application is using Quarkus, I can add all the features that I need. I can add these features using extensions. So first extension I'm gonna add right now is the Quarkus Kubernetes and the Quarkus Container Image Jib. What those extensions will make for me? The Quarkus Container Image Jib will help me to build an image for this application without needing to create a Docker file or maintaining a Docker file, okay? And this other extension here, Quarkus Kubernetes, will help me to get this application and deploy on Kubernetes without need to build an YAML file. I will have an YAML file, but I don't need to build this YAML file, okay? So what I'm gonna do right now is to, okay, I added those extensions. Right now, I need to add some properties to my application properties file. So basically, those properties. So I will connect to the Docker Hub. I will connect to my account on Docker Hub. I will deploy this image from this application I'm using right now. This is the version. And when I deploy this application to Kubernetes, I will create a load balancer. So it will create a service of a type of service of a load balancer. And this is just for certificates because I will not using SSL here. Okay. All right. So let's just here connect to my Docker Hub and hope it will work because another day Docker Hub was out of work. Okay, right now it's working. And simply this way, I will use Maven to package my application, but I will use this option here, Kubernetes deploy equals true. If everything is fine here, it will compile my classes, it will package my application, then it will create a container image, it will push to my account on Docker Hub, and then it will run a deployment, my deployment on my Kubernetes using this image, and then we have this application running on my Kubernetes, okay? 20 seconds, not bad. Let me check if my application it's already running on Kubernetes. Okay, 16 seconds, it was created. So if I have the pods, probably I have the service. Okay, I have the service. Usually this external IP, this DNS here, takes around 1 minute, 2 minutes to be available, but let's try. Sometimes I'm luckier. So hello. Yes, it's not working. So we'll keep it running here while we go forward. I will leave .3. Done. Okay, so around 1 minute, 2 minutes, it will be available. All right, while I try to reach my application that is already available on my Kubernetes, I will make my keep my live coding moving forward here. All right, guys. So let's do another stuff. I have here an application that's managing fruits. So at my laptop here, I have a small database with the season of a fruit and a name of a fruit. Now I would like to have more data about each fruit. And I discovered that there is a service, a remote service somewhere. I have an URL for this service. And if I pass the name of my fruit, it will return me more data about these fruits. Okay, so I like this service and I'm gonna do, oh, now it's returning here. Hello, rest easy. Okay, it's the reload of my application. Okay, if I tried the fruit, of course, it will be empty. Okay, but yeah, so it's available. Okay, so I have my application running on my Kubernetes right now. Oh, and before keep trying to create this REST client, let me show you how this application was deployed on Kubernetes, because this is the most interesting part of this session here. When I use it, that option to deploy my application on Kubernetes, just because I have this extension on my application, when I try to package this application, I have this file here, code target Kubernetes YAML. Okay, let me open. This file was created by the plugin, in the process of packaging this application. So if you notice here, if you ever worked with YAML files, this is a usual YAML file for deploying an application on Kubernetes. But the best part is I didn't have to create this YAML file because the plugin made it for me. So I have here the service, I have here the name, I have here the port, I have here the name, the kind of service, it's a load balancer, here the deployment, and the name of the container specification, so the image that was created. So everything that I need to deploy an application inside a Kubernetes it was made by the plugin, so that I didn't need to touch on this file here. And each time that I add something to my application that needed to be known by the Kubernetes, it will change this YAML file here accordingly, so I don't need to maintain this file. So it's very, very useful. Okay, guys, so as I was saying right now, I will just create a REST client here to have more data on my application. Okay, so no, this is not the case. Let me get here. Okay, so I will add a extension of REST client. This is from microprofile. Okay, so just using plain microprofile here for creating a REST client. And right now, I will use an external service called FruitVice. And for that, I need to create some new classes on my application, okay? Guys, I will not get into too much details of what I'm doing here because it would take much more time. And I don't want to show a lot of details instead of show you what can you really do, okay? But let's go. I will just create a Pojo here. And then I will create my interface that will be my REST client. So let's create this guy here, FruitVice service. And this is my interface. So this is actually our REST client. So, okay, so just a simple microprofile REST client. I will register this interface. This is the method that I'm going to use. And right now, I just need to inform the URL of this service. So I will open here this guy. And okay, here. So if you can check later, this is fruitvice.com, and then you will see how you can use it. All right, but don't worry right now. Of course, I need a DTO to make the transformation of the data that I will get from this service. So let's create this guy here. And finally, I will change my REST endpoint to FruitVice, fruit resource. Okay. Because right now, okay. Now I have here my REST client injected on this endpoint, and here I'm using it. So just this guy here. So here I'm passing a fruit name, and I will get more data for this little application here. Okay. If everything is working and I didn't mess up, so let's try to access this application again. I will make it a little bigger and a little bigger. Okay. All right, so let's try to access. So right now it takes a few more seconds because I'm accessing a remote application, but I have here. So I have the name of the fruit. I have the season of the fruit. And now I have also carbohydrates and calories from this remote service. Okay, so this is a way of two microservices, for example, to communicate to each other by using REST in the client. And the best part is you are just using whatever you already know, okay? Because it's also it's not something new to Java. It's all something that we're using a lot. Okay. So right now, let's move to fault tolerance. So let's add some features related to fault tolerance here. And for fault tolerance, I will also add a new extension. And this is the fault tolerance API from microprofile as well. Okay, most of stuff here, it's based on microprofile APIs. All right, so what I'm gonna do right now is to make some changes to my my REST client here, the interface that we created for this REST client. So basically, I will make the one test here. I may add this feature, retry. What is retry? If this application, if this service specifically have some issue, some problem to access some stuff, I don't know, some error, instead of just return the issue, return the error, return the message, it will try again. How much times? At max 3 times, and wait 1 second for each try. Okay. And for make this really have some issue, I will change this URL here for blah blah blah.com. Okay. So let's try to access again. Okay, too fast. So let's just okay. Ooh. Okay, restart the developer mode and then we call it again. All right, so this application is taking too long to bootstrap, like 3 seconds, 4 seconds. Okay, so yeah, 4.67 seconds. Okay, let's try again to call the fruits. Okay, now I have, because it tried once, 1 second, tried once, 1 second, and tried twice, a third time, 1 second again. And right now I have here unknown host exception, blah, blah, blah.com. Okay. Okay, so I have one improvement here because I didn't return the issue at the first try, but it's not good as it's not yet good because return this kind of error to your client is not something that you should know, you should do. So what you're gonna do right now is to add a fallback feature here. So let's change this REST client again. And right now we have the retry, but also we have the fallback. So the fallback here, I'm creating a class. I could use a method, but I'm using a class. So this class will implement a fallback handler, okay, of a fruit device. And basically, if I have some issue, I would just return a fruit device that is empty, okay? So no data on the data that was expected, okay? Good, so let's try again. I will call this application. So you try 3 times, and then in the end, we just return a empty fruit device. All right, so, okay. Come on. Yeah, I have a lot of stuff running here on my machine, so sometimes it takes too long. Okay, so I have name, season, and carbohydrates and calories are 0 because I couldn't reach that service. And for this demo, I decided that if I can't reach that service, I will just return an empty entity, okay? Of course, for your business purpose, you will treat different, okay? If I just return this guy here to the correct URL and call again, hopefully I will get the data. Okay, so right now I have my data here. All right, good. Let's go forward. Okay, guys, what I'm gonna do right now is to work with Health Check, okay? And for doing that, I will, of course, add a new extension. And the extension that I'm gonna add right now is health, also from microprofile, okay? So let's just add it here. And one interesting stuff about the Health Check, the Health API is this. Let me show you. I didn't have to create this endpoint here, but just by adding this extension to my project, it's already available. Okay, so this is a default endpoint for this API that's supposed to give the information about the health check of my application. But of course, this is not actually useful, but so let's just create our own probes. Basically, when we are talking about orchestrated environment, we have 2 kinds of probes. And I will change here to my camera to explain to you. We have 2 kinds of probes. We have the liveness probe and we have the readiness probe. What's the difference between them? The liveness probe will tell to the orchestrator if your application is live or is not, okay? And the readiness probe will tell to your orchestrator if your application is ready or not. What's the difference? Now, suppose that I am a service, okay? So I'm here working, and then the orchestrator asked me, hey, are you alive? And I say, yes, I'm alive. Okay, are you ready? Oh, let me check. I need to access a database. Oh, the database is not available, so I'm not ready. Okay, for example. So if I'm live but not ready, the orchestrator will not send requests to you or to your service, of course. Okay, but at the other hand, suppose that I'm a service, and then the orchestrator asking me, hey, are you alive? And I don't respond because I'm not alive, okay? What happens in this case is that the orchestrator will kill this process. In the case of Kubernetes, will kill the pod, and then we'll create another one, okay? In the other case, if you are alive but not ready, the orchestrator will just wait. And then in a few seconds or minutes, I don't know, it will just ask again, okay? And if you are ready, and then you are, if you are live and ready, then you are ready to receive requests, okay? Just to explain to you. And then let's add our probes here. So we'll create a liveness probe. This is the liveness probe. The liveness probe, it's the easiest because or you are alive or you are not alive. So, but just to understand the structure of a health check probe, you implement the health check interface. You will also be using the liveness annotation, and then you implement this method here. And for liveness, usually you just return, hey, I'm alive, okay? But the readiness, as I just said, is where you are gonna maybe put some some kind of business rules or something like this. Okay, so just readiness probe, and it could be, for example, if I try to access this service that I'm, it's wrong here. You are here, and you are here. Okay, good. Basically, for example, this service that I'm accessing to bring data about my fruits, I could, for example, check if this service is available, if I can get data from it, so something like this, okay? So here for this demo, we are just making some simulation of accessing a database, okay? Just for demo purpose. Let's refresh here. So right now I have the return of my liveness probe, and here the return of my readiness probe. All right, so now we have, and the interesting part, let's make some stuff here. MVN clean package, just a regular clean package, okay? We'll package this application. As I have this extension of health check, and I have my health checks defined here. If I try to access again my Kubernetes YAML, right now I have here, I have my liveness probe, and here the endpoint, and I have here my readiness probe, and here the endpoint. So it's amazing that I don't need to put it to maintain it manually. All right. Right now, let me check the time. Okay. Let's work with metrics. Okay, so I will add, guess what, the extension. We use the micrometer here. I will add this extension of micrometer. I will make a little change on my POM file. Where is, okay. Later, okay. whatever. Oops. Okay, so for this one, I will create a new resource just to isolate the metrics here to make it easier to check. So time resource, and then this is the code of our time resource. So basically, here I created for this method, I created this metric. So it's a counted metric. What is a counted metric? Is a metric where each time that you call this method here, it will count 1, 2, 3, 4, 5 for each time that is called. Okay, easy peasy as well. I will call this endpoint here a few times to have data. So okay, it's not yet available. Sometimes you need to reload the developer mode. It's not common, but sometimes you need, especially while I'm adding a lot of new extensions here. But it takes like 4 seconds, 5 seconds, so it's not a problem. Okay, 1, 2, 3, 4, 5. Okay, so should be 25 times. And right now, I would just call, as I have a default endpoint for Health Check, I have also a default endpoint for metrics. It's called, guess what, metrics. And then here, if I just try to find here, I have my metric created here. Time now total, and I have here 25 times. Here my package. Okay, so I can check. Of course, you're not gonna using a browser to control your metrics. It's just for demo purpose. Okay, so here is how you can add, create, and realize that I'm adding stuff that you should be using when working with application using cloud native approach. So I have here communication between service. I have fault tolerance features. I have health check features as well. You also need some metrics to work with observability and stuff. And right now, I will add some reactive features for our application, okay? And I will use 2 approaches to do that. The first one is I will add the API that Quarkus uses for working with reactive is the Mutiny. So I will create another application inside this project right now. We've been working with fruits so far. Now we will work with beer, okay? So if you like beer, put on the chat hashtag beer, okay? I can't see the chat, so you just do that. Okay, so let's create a beer Pojo here. Where are you? You are here, okay. Of course, again, I will not get into much details about all the data from this Pojo because we need to finish with more information as possible. So I will create another REST client here. Okay, so again, we have a REST client. I have here a list. I have here a beer and so on. And we will again connect to a remote service. But what's the difference between this service and the last service? This service that we will use to bring my beers to my application right now, this service will not return data synchronously. It will use pages structure to return this data. So I will listen to this return and use a reactive way to get it to my application. So let's just be a resource. Okay. So I have some difference here. I have again my REST client. Okay, so no news here. But the return here is the Muti, is the return used by the Muti API that I'm using right now here. Okay, and of course I will iterate to this return until it is empty. Okay, and I will just return those beers who have the alcoholic level of beyond 15. Okay, so really, really alcoholic beers. Okay, if I didn't mess up, right now, I can have my beers working here. So, okay, it's supposed to reload it, and let's just wait. Okay, so I have here this beer here, the end of story, tagline, the world's strongest beer. 55, wow, it's really, really alcoholic. And other beers here, a lot of good beers, I hope so. Okay, so this is one way of working with reactive. But of course, there are a lot of interest right now about reactive streams using Kafka. So let's do this. And this is the last part of my presentation right now. I will, of course, add a new extension here. Okay, it's done. Good. Let's go. We will start working with fruits, then we move to beer. Now we are going to work with wine. So if you like wine, just put in the chat hashtag wine. And I will create a Pojo as well. And this Pojo is a little more complex because I have two entities here, one entity for the wine, the other entity for the prices. So the priced wine, this will make sense in a little bit. So let me just create the Pojo. I will have a what we call a wine generator here to keep sending data to my topic on Kafka. Okay, just create this wine generator here. It will randomly create a list of wines and prices of these wines. I will, of course, have a resource. This is my endpoint. So I will create this guy here. Wine resource.java. And okay, so here it will use this channel on Kafka, okay, priced wine, to bring the priced wine, and it will just return here to this. Also here I'm using the same API, the Mutiny, but here integrated with Kafka. Okay, so I will create some properties again. So, oops, okay. So here, basically how I will work with the Kafka. I will not get into much details because we are 5 minutes to go. And right now, of course, I will not create a Kafka on my machine here, but I will use, it's a Kafka, okay? I will just use Docker to build a Kafka broker here. So cd git live tutorial, I will create a Docker compose file, compose YAML. Oops, sorry. No. Wow, don't say, okay. My bad. Okay. Clear code Docker compose. Okay. Now we are talking. Then I get, oops. Okay. Whoosh. Okay. Okay, so basically I will just run a Zookeeper and a Kafka to make it run. Docker compose up. If I didn't mess up again. Okay, yes, should be. It will download some stuff from Docker. Okay, let's just wait to be ready. So they are connected and then creating data here. Okay, it's connected, it's connected. We'll reload this guy here. Hope the application and our Kafka are connected to each other. Okay, yeah. Okay, sounds like they are they are talking. So right now, I will invoke this new endpoint and hope that we get some wines. Okay, we get wines. Okay, so we have here our Kafka broker connected to my application and bringing some beautiful wines to our list here. All right. Well, 3 minutes to go. Let me just go back to my slides to show one last stuff here. That is our developers.redhat.com, where you can find a lot of content about Java, containers, microservice, Kubernetes, Linux, and everything focused on developers. If you would like, you can register on this website so you can receive our newsletter, notice about events, especially from Jnation. I have here my my image of Jnation. Let me here my Jnation. So a lot of events that we running on Jnation right now. Bruno, I don't know if you have time for questions, and if we have.
We have a small time for questions.
I
have one of for myself. So
okay.
So microprofile health check. So we have the liveness and the readiness checks. So the liveness usually for, well, I'm here, the service is live, and then the readiness to check if all the things that the service needs are up and running and if it can start receiving load. But there are kind of checks that you only run on startup that are a bit dubious. Are they liveness? Are they readiness? For example, how would you label a check that just verifies if you can, well, if your passwords are correct and if you can connect to some place, and you don't need that afterwards?
Yeah, it's like a business check. It's not really a architecture check, I believe, maybe. But if this is, for example, on your, you could put this kind of check on your readiness. So, well, you didn't pass a correct password for me, so I'm not ready. I can receive.
Yes,
so
yes.
Could be some, for
but
example,
it's the kind of thing that you would need to tweak in order, for example, not to run all the time.
Yeah. You can, if you have time here, I can share my what is my Kubernetes? You can define the time, how the period when you run your for here, for example, this one will run on each 30 seconds. So for example, you can put on, I don't know, 300, 5 minutes, 1 minute to 1 hour, I don't know. So you can change this guy here to make it, or on each 1 second, I don't know, the kind of application. So you can tweak this to make it to run for your purpose.
Okay, so we need to wrap up. Elder, thanks very much. It was great to have you here, and I hope we can see each other live on a future edition of Jnation.
Yeah, I hope to be in Portugal next year. So see you.
See you. Bye-bye.
See you, man. Thank you very much. Thank you, everyone. Bye-bye.
Bye.
Grupo Bosch é um fornecedor global de tecnologia e serviços. Nós temos atualmente cerca de 395 mil colaboradores em todo o mundo, sendo que são cerca de 73 mil em investigação e desenvolvimento. Nós fomos fundados há mais de 130 anos e, atualmente, aquilo que nós oferecemos aos nossos colaboradores é a oportunidade de moldar o futuro com inovações que vão tanto melhorar a qualidade de vida das pessoas como proteger o ambiente. E onde é que nós trabalhamos? Basicamente, são 4 áreas de negócio: soluções de mobilidade, tecnologia industrial, bens de consumo e tecnologias de edifícios. E de referir também que em 2020 nós fomos a primeira empresa industrial em todo o mundo a atingir a neutralidade climática, o que para nós foi um grande achievement. Foi um ano atípico para todos, e para a Bosch, assim como para outras empresas também. E cá em Portugal, nós acabamos por ter um resultado que foi melhor do que o esperado na altura da pandemia. Nós tivemos uma faturação de 1,6 mil milhões de euros, 10% abaixo do ano anterior, mas ainda assim melhor do que nós achávamos que ia correr. Como nós estamos cá muito dependentes do mercado automóvel, e o mercado automóvel está a sofrer com a escassez de chips, comprometeu um bocadinho, mas só para saber, só para ter uma noção, nós tivemos recorde de vendas numa das nossas unidades cá em Portugal, mesmo em ano de pandemia, por isso correu bastante bem, considerando o contexto. A maior novidade foi uma integração de 2 conceitos, que é o conceito da internet das coisas com a inteligência artificial. Nós queremos combinar os dois para melhorar continuamente os nossos produtos e serviços, e chamamos isso do AIoT. Como diz o nosso CEO, é conectar as coisas que vai conduzir ao conhecimento sobre como as coisas são utilizadas. E isso, de alguma forma, vai nos permitir melhorar continuamente os nossos produtos. Nós, por exemplo, o ano passado tivemos um grande aumento das vendas na área dos bens de consumo, dos produtos para o lar, seja nas ferramentas elétricas, seja nos eletrodomésticos, e porque eles estão a ser habilitados para conectividade, ou seja, temos essa ligação com o AIoT, nós prevemos que vai haver uma duplicação das vendas esse ano ainda. E mesmo no campo da videovigilância, que é uma área que nós trabalhamos cá em Portugal, a análise de vídeo, por exemplo, com base em redes neurais, traz novas possibilidades para a Bosch. Esse aqui é só um exemplo do que nós estamos a fazer, mas a Bosch está a integrar em detectores de incêndio, por exemplo, novas câmaras e essas câmaras podem ser conectadas com dispositivos de inteligência artificial. Outro exemplo é um detector de tráfego, que inicialmente seria capaz de detectar e localizar só os veículos, mas que neste momento faz com precisão essa detecção em situações de tráfego intenso, mesmo em condições de iluminação mais complicada, por exemplo, durante a noite. Por isso, a utilização da inteligência artificial combinada com a internet das coisas é que é a nossa grande novidade, é a nossa grande aposta para os próximos anos. Nós pretendemos que 2022 seja um ano de regresso àquilo que era a nossa normalidade em termos de faturação, mas vai ser um ano de continuidade em termos de recrutamento em Portugal. Nós temos apostado muito fortemente na área da investigação e desenvolvimento, seja com parcerias de inovação, que nós estamos a reforçar com as principais universidades, alguma das principais universidades de Portugal, Aveiro, Minho e Porto. Estamos a reforçar, temos novos projetos com eles no âmbito das cidades e casas de inteligências e também no âmbito da mobilidade. E se hoje nós já chegamos aos 1.000 colaboradores dentro da área de investigação e desenvolvimento, nós, até o final do ano 2021, pretendemos chegar aos 1.100 e para o próximo ano continuar a recrutar nessa área, tanto para as localizações de Aveiro, como Braga, como também para Ovar. Ou seja, seria um ano de continuidade em termos do trabalho que já está a ser feito cá em Portugal, de consolidação através da investigação e desenvolvimento, de reforço das parcerias de inovação e de regresso à normalidade dentro da nossa expectativa de faturação. Por isso, eu diria que 2022 vai ser um ano positivo para a Bosch em Portugal. Que nos se apaixone pelo nosso propósito, porque a Bosch é uma empresa peculiar, porque é detida por uma fundação beneficente. Então, tudo aquilo que nós fazemos é realmente com o propósito de ajudar a melhorar a vida das pessoas e de trazer uma proteção adicional para o meio ambiente. Quem se apaixona por esse propósito, se apaixona pelas tecnologias que estamos a desenvolver, por exemplo, essas de monitorização, como eu disse, ou então da condução autônoma, ou tantas outras nas áreas nas quais nós estamos a trabalhar, certamente é uma pessoa que vai se enquadrar bem nas nossas vagas e nas nossas equipas. A Bosch, apesar de ter quase 6.000 pessoas em Portugal, é uma família, é uma grande família. E nós nos preocupamos com os colaboradores, queremos que eles se apaixonem pelos projetos, queremos que eles estejam bem e tenham esse equilíbrio do pessoal com o profissional. Se é isso que as pessoas estão à procura, de certeza que vão estar bem conosco. E podem visitar a nossa página de carreiras, o bosch.pt, e procurar as nossas vagas e serão muito bem-vindos na nossa empresa.
Go. I will make.
Hi everyone. So we are here for the last session of the Almedina track here at Jnation. It's almost a wrap. So for this last session here on the track, we have Tom Granite. He works at Lightrun, and he calls us from Israel. And he's going to talk about getting back to sleep as soon as possible for the on-call developers. So you are going to tell us an horror story of someone that will wake at the middle of the night and has to solve an unsolvable problem almost. Let's see how it's going to go.
Excellent. Thank you.
Go for it. I will talk to you for the questions later.
Excellent. So hi, and thank you everyone for the warm introduction. I'm so happy to be here at Jnation, albeit online, hopefully soon, not so much online, but also in person. This talk is a personal favorite of mine. I love it. It tells a story and then does also technical stuff during the way, which is always fun and games for everybody involved. A bit about myself before we hit the road. My name is Tom. I'm a solution engineer here at Lightrun. We build real-time observability tooling for developers by developers. If you want to reach out to me, you can do so over Twitter, best preferred medium. You can also do it via GitHub, I guess via a GitHub issue, but that would be very non-ergonomic. So maybe just use Twitter instead. You can also find me on my email, tomj@lightrun.com, or visit the website, lightrun.com, and play around with the product. We have a free tier. So jumping right in, I want to tell you a little story about Oasis. Oasis is an enterprise system. It is a piece of software built by an enterprise to be used by an enterprise in order to do enterprisey stuff. It has a management console. It has many different services. It does a bunch of stuff. Most of them not very interesting. Some of them really not interesting. But still, it makes a lot of money for the company that built it. They can charge a lot of money from the customers. The customers are happy because they have a management console with many enterprise things that the enterprise likes. And everybody's happy, including the developers building the software and getting paid to do so. Being a big enterprise worldwide system, Oasis is active 24/7. It's always live. And because of that, we need people in order to support it while it's live. And this, in most modern organization, kind of splits apart into a few different groups. So you usually have a developer who is on call, maybe one, maybe more, who are in charge of actually dealing with application logic. So something is really, really wrong with the application. They would figure it out, debug it, and push it back into action. In addition, because of the amount of complexity in most modern applications, you also have a DevOps engineer or in addition, usually a few support engineers that man the front line and and basically debug various application level problems that let's say can be codified in a runbook. They will talk to the customer and try and push buttons and twist knobs in order to do different things in the application. The DevOps person is usually in charge of infrastructure beneath. So things like the Kubernetes cluster the application is running on, maybe EKS if you're running on AWS, maybe bare metal servers, or if you're running on an on-prem data center, then they will also deal with that too. And in addition, that varies. Not all organizations have it, but a lot of them have NOC teams. And NOC teams are people who sit in front of screens and basically make sure to monitor the metrics of the applications, the services, and notify when something goes wrong. So this is how Oasis looks like. A developer on call, a DevOps person, and a couple of support engineers manning the stations, in addition to the NOC team. Now, I want to talk a little bit about the system itself, because we are going to go through a bit of a scene here. Basically, we're going to see exactly what happens during some random on-call night. And I want to talk about how the system is built, because you have not built Oasis and you don't know Oasis because it is an enterprise system that nobody out of the enterprise knows. So I want to tell you a little bit about how it's built in the inside. So first and foremost, it's a microservices-based system. It's written in Java using JHipster, Spring, common Java technologies for enterprise applications, for applications in general. Oasis is comprised of different types of services that do a bunch of different things. There's a gateway up front that directs traffic around. You have an inventory service that's in charge of keeping track of inventory. You have a transaction service that is in charge of making transactions between different parts of the application. Basically, a user will ask a request, and then a transaction will be created, usually billing of a credit card or something of that sort. And there's also a credit service, which is an external service that is in charge of swiping credit cards, basically, gathering payment information, collecting it, and then charging the cards. There's a fraud checking system and a billing system, a bunch of different things that happen in the system. And to monitor it all, there's a very standard ELK stack. I think it's called the Elastic Stack now. And that stack is in charge of basically ensuring that the DevOps team, the developer, the on-call people, everybody can have a great grasp on what is going on inside the production setting. Now, in real life, on-call is a pretty bad situation. A lot of the times things happen and you really, even the most prepared teams sometimes face things that are completely unexpected. And I like this little picture of a bunny because it depicts something that happens during the bad on-call sessions. You're working and everything's fine. Maybe you mitigate a small problem, and then out of nowhere, there's a huge storm coming in over some random thing that went wrong and then cascaded throughout the system, which you have to debug in production live via the application, throughout the shift in order to basically fix it on the fly. Now, in real life, there's a big separation of concerns between the different types of people who do different types of things in the on-call situation. So first of all, the DevOps engineers, they know system. They're infra people. They're sysadmins at heart. And they know how to tell when the application is misbehaving on the infrastructure level, i.e. the infrastructure is failing beneath the application. And they know what to do in order to fix it. And many DevOps engineers today are actually programmers. And they also know how to deal with infrastructure as code things that are relevant to your application. So they will actually know a pretty significant portion of the infrastructure that runs your application, but they will still be limited outside of the context of application logic most of the time. Usually they deal with things that are, let's say, on a lower level of the stack than the developers writing the applications. Support engineers are, again, it varies between organizations, but a generalization would be that support engineers follow playbooks either written by them, following incidents in the past, or playbooks that were written by developers who wrote the system in order to, again, push button and turn knobs in order to fix various things in the application. This can be something like restarting a specific service or sending a specific API call, maybe clicking some button in the management console. Each system has its own type of support and support engineer privileges orientation. And it is really important that these people are very technically savvy, and a lot of the times they know how to solve most of the problems themselves. But again, they're segmented to, let's say, the front part of the application. They have their buttons and knobs, but they're siloed in a way. The environment itself is super duper noisy. Lots of noise coming out, and not just from the systems themselves, the logs, the metrics, the notifications in Slack or whatever it is that you're using. Maybe you have a PagerDuty connected to your phone that's ringing off the hook. But generally speaking, you would note that when something happens, a lot of functions in the company get involved. So if an account director or an account executive whose customer is complaining of a problem will usually hop on the phone and yell at you to fix it while the customer is complaining. Or maybe the person on the other end of the line is actually the customer himself, and you're talking to them, trying to debug the problem as you're listening to them on the phone, trying to understand what's going on, if you have a few major clients and not, a lot of small ones. And this means that whenever there's a remotely complex application logic problem that cannot be solved by any of the people, that I mentioned before, in addition to the fact that the environment is kind of super noisy, it's kind of hard to understand what's going on, there is a switch you can press in order to rescue the situation. And that's basically calling the developers. You tell them, come in, your application is crashing, please help, everything is messy, we don't know what to do, come in and help. And that's what the developer on call is expected to do in an on-call situation. Now, I want to introduce you to Jamie. Jamie is your common enterprise Java developer. Jamie has about 5 years of experience or so, or something like that. And Jamie specifically works on the service that is in charge of transactions. We talked about the services before. He works on the transaction system and is in charge of writing the service and obviously being on call for it when something bad happens. Now, assume that Jamie is currently on call. There's a shift going on, you're inside of it, and a transaction is failing for some reason. The support engineers are looking at the transaction from their own perspective, from the management console, and try to understand exactly what they can do in order to fix it. They try and they fail. They can't make it work. So if they fail and they can't make it work, there are other functions that are getting involved in the process now. You have the DevOps team that are saying, okay, let's look at the metrics of the infrastructure beneath the application in order to understand what's going on. So they go in, they see nothing in the monitoring systems as well. And because, again, whenever there's an issue with supposedly a remotely complex application logic, who you're going to call? You're going to call Jamie. Now, before we dive into the actual demonstrations part of this discussion, I want to talk a little bit about the concept of observability. This is a buzzword being thrown around a lot lately. And Lightrun, the company I work for, builds things that help with real-time observability. So I think a definition is in order. So the best way to define it is building a system that talks. And talks in a way that gives you the full picture. And specifically, the kind of core definition of it is observability can be defined as the ability to understand how your systems work like on the inside without shipping new code. And the important bit here is the without shipping new code, because we can always add more observability to a system. You add a log line, you deploy, you push to production, you wait for the release to roll, and then your logs will roll in either into the STD out of the application, or maybe your APM or whatever integration you have set up with your monitoring system. Now, this is not obvious. Not everybody are building systems that are observable by default. A lot of people build systems and treat observability, the way the application will talk to you once it's running in production, separately from the development of the application. Log lines are added as an afterthought, metrics are instrumented only when needed, and the observability infrastructure for your application might not be completely off the bat in the first try. It is running in production, the system is working, the tests are written, they pass when you push into production, the actual system is up, the IT metrics say CPU, RAM, say everything is okay, but the logs and the actual kind of full picture of your application is not entirely clear. When something wrong, there's a lot of missing information. And before we kind of dive into what can go wrong, I think it's great that we can talk about what can go right. So the things that our tools do tell us. What is actually happening inside the application that our tools can tell us. So let's do a quick review. First and foremost, logs are an excellent way to understand the state of your application. There's a log. By the name, you can tell that it logs whatever happens in the system. And if you go at it one line by line, you can understand exactly what's going on inside your application. Well, at least the things you wrote in order to understand what's going on inside your application. But it does provide a pretty good picture. Logs solve 50, 60, 70% of major problems. You look at the logs, you understand what's going on, you push a hotfix, go away to sleep. Another set of important information is IT metrics. I'm talking about CPU, RAM usage, how much load is on the machine at any given point of time. Those are infrastructure metrics used by the DevOps people of the world and the sysadmins of the world. And they tell us how the infrastructure the application is living on feels. And this is also a big part of the question, and perhaps solves another big portion of the issues that come on. Maybe some service is crunching RAM. You don't have to fix it at that specific point in time. You just have to know that this is the reason the machine is acting up. There's too much memory being consumed. And then you can, again, by the support engineer or whoever is in charge of this infrastructure at this operation at this given time, do some things, usually prepare for it, in order to fix when that happens. Perhaps there's some auto-scaling feature at play. Depends on the organization. I don't want to get into it too much because this is not a DevOps discussion. In addition, there's this little subset of metrics that is called differently in different places. Some places call it a service metric, some call it a business metric. I'm basically talking about things like how much your APIs, how fast your APIs are responding, how much failure rates they get. Things that will most likely be written inside the SLA, the service level agreement between you and your customers. And these are things that are very telling of the way your customer views the application. And again, we are getting paid for what customers are experiencing, a big gap sometimes between what we as developers think and the real world. But the eventual thing is that the thing that matters, the thing that brings our company money and keeps us on the payroll, is how our customers feel the application is behaving. And service metrics is one way of measuring these things. Another type of tooling that is very common, it's actually not a new concept, but it's become very popular with the whole cloud native movement that we've seen lately, is tracers. And I'm talking about things that allow you to trace how much time it took specific parts of the code to run. And you have a bunch of them. I think the most popular one are maybe Zipkin and Jaeger these days, I guess since not sure when Zipkin was released, but these are kind of the more popular known open source ones used in many different companies. And they, again, really help you in understanding how an API endpoint is behaving at any given point in time. Like what's actually taking too long to run? Is there some other downstream method that is causing the downstream API call that is causing the problem? Is something wrong with this service that cascades down to that service? It's a great way of understanding what's going on. In addition, you have profilers, and profilers are notoriously expensive to run in production. It's things that you don't, maybe you have a sampling profiler or something like this, but it's just an expensive performance-wise piece of tooling to run continuously. A lot of people still do, and it's a great way to understand what's going on with the state of the application. But again, they have their limitations. They do tell us in many ways, I'm thinking about tools like Visual VM, for instance, tell us how a specific portion of the application is feeling in depth. It will tell you exactly what is happening inside the context of the application at any given point. But again, they're expensive to run, and sometimes they don't provide the full picture because they do sampling and not full profiling. One extra piece of tooling that is obviously a crowd favorite is debuggers. Debuggers are usually not used in production. You have remote debuggers, obviously, that you can attach to a machine. Many companies completely forbid connecting remote debuggers to production machines because of obvious security considerations. It's a production machine. You don't want to stop it from running while you're debugging. And the concept of remote debugging a lot of the time applies also when you're trying to fix the problem locally. So what I'm getting at is you will reproduce the problem you see in production locally, and then maybe use the debugger to step by step kind of run through the application in order to understand what's going on. Step in, step out, step over, and understand what's going on inside the application. One extra bit of tooling that is, again, not new, but has a lot of value in many organizations today is exception monitoring tools. And I'm talking about things like Sentry, for example. And these are things that allow you to aggregate all the information about errors and exceptions that happen in your application, and then understand kind of what's going on whenever they happen application-wide. And these are great for understanding what's happening when something goes wrong. They don't often tell you what is going on while things are going right, but kinda. So when things are not absolutely terrible, they are not really helpful. Or when an exception or an error is not being thrown, they might prove not to be as helpful. Now, I'd like to take a moment to kind of re-examine observability. So in my definition, the definition I gave you before, observability was defined as the ability to understand how your systems work on the inside without shipping new code. What I'm saying is that we need a better definition for that. I'm not going to go into it just yet, but I'm going to tell you that we are going to define it later on in a way that's a bit more applicable to real-time debugging, what we do kind of as a professional side gig when we're on call. And I really want to focus in order to explain why this matters and why building the systems in ways that are observable matters. I want to tell you about the gaps, the things our tools don't tell us. So first and foremost, GASP, programmers makes mistakes, and you can end up with incorrect application state at different parts of your application. This is not straightforward, but sometimes the state of the application is corrupt. You got to a point where things are not as they were expected to be. That might be the test that this code was the tests that were written for this code might pass and everything work, but the eventual way the application is presented to the user is not what the user expected it to be. The state of the application is incorrect, either from the user's perspective or because we hit some barrier inside the application that we did not expect. And this is very common, again, due to programmer errors, but sometimes you're totally working in accordance to what product has told you. No bugs are actually apparent in the application. The application itself looks okay, but from the perspective of the customer, something is wrong. Maybe a button that is supposed to appear is not appearing. Maybe the load on the machine is very high, and it is causing the machine to create some sort of weird state. Basically, anything has to do with bad application logic. But speaking of performance issues, I want to step into something that's a bit nuanced. So we talked about tracers and how they allow you to look at methods and understand exactly what's going on, sometimes on the method level, sometimes on the API endpoint level. But the bottom line is that there's a whole set of metrics that we instrument a lot of the time inside our code. Think about things like the sizes of data structures in memory, for example. It's not always obvious to understand how much values are in that object. How much does it weigh? How much things are in this array at any given point in time. And these are things that, how much time it took a few lines of code to run, how much time did we reach a specific line of code in the relevant flow. These are all quantitative type information that is really interesting to understand, but we don't always have instrumented beforehand. So we kind of have a black box there. I want to add a new code level metric, and I really can't because I don't have it instrumented yet. I would have to instrument it, then maybe perhaps even push a new version in order to deploy it, configure it in the APM, and so forth and so forth. One extra thing that's a nice kind of problem that appears a lot, especially in legacy code bases that were written with many different developers working on the same code simultaneously, is swallowed exceptions. That's basically the case where an exception was thrown, but the description was not there. So it was thrown and caught, but nothing actually was emitted into the logs. You would not know that the exception actually happened. If you have exception monitoring tools instrumented, then you might get them, you might not, depending on the tool. But the bottom line is that from the perspective immediately, when you're looking at the application in real time, it's not clear that this happened. An exception was thrown, but you can see it in the visible log of the application. I'm going to go ahead and make an assumption in the next block here, which is you are using outside APIs for your application. And this is a common statement for basically any modern application. We sometimes use APIs that are not ours. And that can be an external billing service. It can be just some geocoding service. It can be basically any type of external service that is more useful to buy than to build. And they sometimes misbehave. And while they have their own kind of I guess, license to operate, do you have an SLA with them? Sometimes they throw back information that is wrong, or you send them something and they give back a response you did not expect for. And this can be maybe because they updated a version. This can be perhaps because something is going on their region of AWS that has nothing to do with you, but you are affected by it directly. It's basically a whole slew of issues that can happen from factors that you cannot test for and you cannot align for because you have not prepared for. It is a third-party API that you have not built yourself. You have no hands in it. You can't understand what's going on inside of it. You just have to deal with the consequences. Now, speaking of consequences, a nice little bug appeared in GitHub a while back. It was a big on Hacker News. I'll drop the link in the Slack Jnation afterwards. Basically, what happened is a user logged into their GitHub account. GitHub is a big VCS. I don't think I need to introduce GitHub. That's a very popular tool. But GitHub had a user sign in. And when they signed in, if I remember correctly, what happened was they saw the organization and the repositories of a completely different user. This had to do with some sort of caching issue. What I believe happened was the credential that was cached was incorrect, and then there was a race condition inside one of their services that sent back the incorrect response to the credential process, to the authorization process, sorry. And then the user ended up in a place they're obviously not expected to be. And this is much more common than we would like to admit. Not logging into different organizations on GitHub, hopefully that is not really common, but finding users that are in a place in the application where we did not expect them to be. This can be perhaps looking at a table that is incorrectly populated. This can be perhaps clicking a link that leads to a different part of the application. The most common one is just, a 404, right? Some bad page, but it's a lot of more nuanced things can happen. For example, you load the state of the full organization for a specific user, and then the user has some sort of components or things on the page that they did not expect to see, maybe in the wrong order. Maybe they set a preference somewhere in the code and you did in the settings and you didn't apply it because of some problem. Basically, it would be very hard to understand how the user is feeling without using tools like in SaaS situations like Hotjar or FullStory to basically understand the full user flow. But from the backend developer's perspective, that's just a black box. The user is obviously experiencing some problems. They will tell you. They are very vocal. But it will not be obvious for you just by looking at the application. One extra thing, speaking of race conditions, is the nature of how we run our software. A lot of the times you will not have multiple resources touching the same thing very, very rapidly at any given time. It happens for some applications, not for all of them. But when they happen, sometimes the resource will send out different responses depending on who got there first. Race conditions is a whole big issue. I'm not going to get into it because it's a full discussion. I want to write a talk about it at some point because it's such an interesting discussion. So if you want to send me some bad race conditions you saw in the past, please do. You know my information. But the bottom line is that they happen so indeterministically that it's really hard to understand what's going on in the application just by looking at it. It's impossible to see, wait, there's a ratio. You always understand it and kind of collect the pieces in order to better to understand that this is actually a race. And one last thing, we're working with the cloud today, and we're working with multiple replicas of the service running on multiple pods or whatever it is you're running or you're orchestrating your software on. And we develop our software in front of a specific machine. We work on our container on our machine or on our project or on our process or whatever. We're working on it on our machine, and we debug and develop it against our own machine. The implications of running the same replicas of the same service across multiple running multiple replicas of the same service at any given point in time are things you don't often account for when you're developing. And this can have weird consequences. Maybe some containers are spinning up and down rapidly, and that causes some sort of weird bug to trigger some edge case in the application logic. Lots of bad things that can happen when you push your application to the limit. And we need to account for it. And again, it's not obvious that the problem is the infrastructure. Sometimes the apparent problem is the application logic, when actually what happens is the infrastructure beneath it is acting up. Now, I do want to stop the chit chat and jump into a quick demo to actually show you what it looks like in practice. And I just want to kind of remind you that this is an on-call situation, which means somebody has called and said, or pinged or whatever, and said there's a problem. This is the ID of the user that is currently having the problem. One of the core problems that any sane developer would say here is that, wait, are you using numeric IDs in your application? Yes, unfortunately so. This is a legacy enterprise application, and the person who architected it did not think to use things that are, to use ID that are not just simple numeric ones. But hey, that's what we have, and we're gonna debug with what we have. So I just wanna remind you about the stack of the application. So we have a bunch of services and an ALK monitoring stack. We're gonna watch it in a bit. Everything is already instrumented, running, and working in production. I just want to understand what is going on with that user. So what do we actually do when we know the ID of the user, but we're not sure exactly where it is in what actually happened to that user? We go to the logs. So as I mentioned, I've instrumented Elastic here, and this is the logs of the application. As you can see, there's a lot of logs going in, a lot of information coming in. I don't actually know exactly what all of these things do at any given point in time. There is too much cognitive overhead here. So what I'm going to try and do is I'm going to try and filter for the specific user ID inside the logs and see what's up. So I'm going to copy and enter. And then I can see that in the past, I guess that was around an hour and something ago, which means I got to the problem pretty slow. But anyways, I'm looking at the application and I can see there was a bunch of information coming in from that code. For that user. And I'm just going to follow all the relevant things that are happening inside the log, just go bit by bit. There's a bunch of services here, and there's a bunch of log lines. And you can see that the first line for that user at 2347, the topmost is it's sorted by by time. It's that it started to process the purchase for the user. Great. So I'm seeing that the logs are actually starting to work. Basically, what I expected to happen actually happened. The purchase has been started to. The purchase was starting to process. And then there was the same service is trying to validate a transaction. That also looks okay. Then a credit check is happening in another service, which implies an HTTP call somewhere in the realm. Then there was a fraud check. Then there was a starting to bill credit card thing. And then they try to actually perform the billing. And then I can see that they actually finished doing all the things. So finished performing billing, finished billing credit card, finished checking for fraud. And basically all of the services that started running have succeeded. Yet the customer implies or basically tells me up front that, hey, I have a problem here. The transaction is not going through. So imagine yourselves in this situation. What can you really do? Unless you know exactly which service has caused the problem. And in this case, specifically, Jamie is working on a transaction service. He knows roughly how all the other services are behaving, but he doesn't know exactly what is happening here. It's kind of hard to understand. So in order to best debug the situation, what we usually do is look at the code, see exactly what happens inside the IDE, inside the source code for the specific application. So I actually have my IDE ready here, IntelliJ, a very popular IDE, and I have actually the first service, the inventory services resource opened up. For those of you who don't know, this is just a controller. It's the standard way you do things in Spring microservices. And I'm going to look at the code and see what's actually going on. And I can see that there's a log info that is similar to what I'm seeing in my own in the Kibana. But there's also a transaction service call here that goes to some HTTP client. The FAN client calls another API to do something. And I'm going to look at the method and see exactly what is going on with that method. And I'm looking here, and it looks like it's doing another call to another service, which is the validate transaction in the transaction resource. Okay, let's move on to the transaction resource. And I can see that the transaction resource unsurprisingly logs and then moves on to another service, the credit service, which checks the credit. The credit service obviously works from the credit resource. I'm going to go into the credit resource. It also logs a bunch of stuff and then checks for fraud. Very simple application logic here. It is just for the sake of demonstration. I'm going to check the fraud, and the fraud resource is what actually does the call. I'm looking at the fraud resource, and for some reason, I'm noticing there's an interesting little method here that actually does the check for fraud. And I'm looking at the method, and voila, there we have our swallowed exception. Now, this is, if you're not familiar, this is an interesting Eclipse thing. This is basically what happens when you auto-generate a try block catch inside Eclipse and then forget to actually add the log statement for the catch block. Now, this is not something that will be actually pushed through a proper code review. But a lot of the times you're in a rush. You need to push a product out, or you need to basically be involved in the kind of organizational effort to promote the things forward. Quality standards go lower. And then you end up with things like this checked into your VCS with nobody actually checking the to-do items down the line. Now, this is a great example of something that is easy to detect in a code review, how to pass over, easy to pass over when you're in a time crunch, but not apparently obvious from the logs. If I look at the logs, you can see that this is actually not evident. I can't tell that this happened, but an exception was swallowed, and I was stuck dealing with the mess at 3 a.m. in the night. So let's conclude. We talked about what bad things can happen in our application, or more precisely, what bad things can happen in application that our tools won't alert us to. I just showed you a demo of the swallowed exception, which is just one example of this thing. And I want to define this new concept of observability. We like to call it continuous observability. So in the same way you have continuous integration, continuous deployment, observability should be a continuous process too. And if observability can be defined as the ability to understand how your systems work like on the inside without shipping new code, continuous observability can be defined as a streamlined process for constantly asking new questions and getting immediate answers. And the key point here is the streamlined process. What happened here was that I had a new question. I did not know what was happening because the logs were not telling me the full story. I had no streamlined process for asking new questions. I had to scroll through my code, file by file, line by line, in order to understand what is going on. And this was a very simple application with a very simple bug. And in most applications, you have hundreds and thousands and tens of thousands of lines of code in each of your places in each of your files and packages in the IDE, which is a nightmare to navigate. And you don't even know where to begin to debug, so you end up doing sort of a binary search, trying to go with, okay, so it's not on that half of the desert, maybe it's in this half of the desert. It's a big old thing. So just a quick shout out. I mentioned Lightrun a few times in this discussion. An observant watcher, or somebody with eyes, will notice that I'm fully swagged at the moment. We have a nice blazer here. The green room guys at Jnation right before the conference made sure to mention that I was the best speaker in Jnation. I'm going to hold the title dearly to my heart and going to apply it to my resume everywhere from now on. So while I'm already swagged up and all dressed up, I think that the best way to kind of talk about my product is after we laugh for a bit, a tiny bit of a shout out. We build real-time observability tooling right inside your IDE. You can add real-time logs, metrics, and traces to your application from your IDE, see exactly what's up. In this case, you would be able to pick a log line somewhere, pick a code line somewhere in the IDE, right-click a button, add the log, have it push directly into production, see the information right in your IDE. Check it out. We have a free tier at lightrun.com. And between my sins, I am a solution engineer. So if you will reach out, open an account, and try to implement it in your company, you will meet me again, which will be awesome. So moving on. What can you do to be better at on-call? And I have about 5 more minutes before I have to drop into the Q&A. So this is an excellent time to wrap up the conversation. So what can you do to win at on-call? On-call sucks. That's fine. You have to choose to love it. It's totally a perfect and normal part of the job for your normal developers. That's just part of life. And instead of being, oh no, I have to wake up and have PagerDuty installed on my phone tonight. Instead, what you should do is you should be happy that your company has such a great product that users are using it 24/7, and you will always have, and you have such a big responsibility for kind of the appearance of the product to the outside world. I know I'm deeply proud of the company I work for, and for me, having a way to contribute in the kind of support sections that I take on from time to time is really great. I really enjoy it. I choose to love it. Extra point, you should be ready. So your laptop should be ready. It should be charged if you're not in front of a charger, connected to Wi-Fi, Slack should be on, VPN connected. Everything you have to do in order to get involved in the process needs to be handled before the session. This really helps. It's kind of like having a bash RC for your on-call procedure. It would be really helpful if you could have some sort of preset configuration on your machine to do that. When I was a site reliability engineer before I joined Lightrun, I was working with an Ubuntu box. I had a nice little Lenovo T490, and we had basically just a text file that we would, it was actually some sort of idempotent script, if I remember correctly. We just kind of, not idempotent, sorry, a dump script that we would kind of enter through and do a bunch of things in order to prepare for the session. It was really nice for the on-call session. I really like this type of tooling, things that make it easier to jump into the process. So gear up. And there's a fallacy that developers believe that this is an edge case that will only happen to me. It will never happen again. No. It will happen again. Document it, write the commands you ran inside the console so the other person next to you who will be in the same position 2 weeks from now will not have to suffer through the same problem. Better yet, tell your support engineers about it. Tell them that there was a problem. Tell them how you fixed it. They're smart folks. They will take this and they will learn better to do their jobs. It really matters, this communication. Speaking of last company I was in, we had these emergency debugging tools, which are basically scripts that you run in order to understand things in your production applications. These are things that kind of instrument metrics on the fly, or add logs, or maybe restart specific containers that are usually acting up. Maybe they swap some sort of file underneath. It really depends on your application, but it's really useful to have them, again, in your bash RC. I can't emphasize enough the importance of postmortems. Every single great response team I know has amazing, detailed, lengthy postmortems. It helps everyone involved, by the way, including your product team, which will be really interested in seeing the weird failures they can expect and then build the next features on top of them. Basically, make sure that the next features are built in a more resilient way. It matters organization-wide, and you should try and promote it as much as possible. And the last thing, generalists, and I pride myself at being a generalist, have a problem. We think we know everything. And this is unfortunately not true. The DevOps person next to you knows more about the infrastructure than you do. If he says or she says something, listen. And when you're not sure exactly what the problem is, hand over things that are outside of your realm of control to the people who are in the context, they're in their own zone. You should make sure to enable them and empower them, even if they're not developers, to do their job properly. And this, I think, out of all the points in this talk, and again, I mentioned at the beginning, I really like this talk. It combines the technical and the storytelling in a way that speaks to me. This point at the end is important. You're part of an organization, and you need to understand that. You need to understand that, to be a great person on call, your job is not to be the smartest person in the room. Your job is to be the best team player. And this, again, matters in the long run. And I hope you take the time to learn how to be one. So this was me. This is also me here in the presentation. Hi. As I mentioned, I'm a solution engineer for Lightrun. You can reach out to me over at my Twitter, Tom Granot. GitHub is also Tom Granot. Email tomg@lightrun.com or sign up for the free tier account on our website. On a personal note, before I move on to the Q&A session, this time with COVID is problematic for everyone. I hope you and yours are safe and sound. And I really, really hope that the next time we see each other will be in front of one another, maybe with a glass of beer in our hands. Thank you. Bruno?
Hey, Tom. So I wonder if you have any observability data on that claim that you were the best speaker ever.
Yes.
At Jnation.
So obviously, right before the session, I added a log to a process called Filippo, and the process called Filippo, who is, by the way, the person running the green room for the organization, for the team here, gave me back information and told me, yes, you are the best speaker in the conference. Just saying, it's a true claim.
That's great. We will be able to assert that later.
Yes.
When we are debugging the conference.
Exactly. You're doing a post-mortem of the conference, which is a great idea.
Oh, that's for sure. That's for sure.
Excellent.
So Tom, so we don't have any last questions.
Okay.
But so I have some questions. So remember that you mentioned that it's really hard to assert the size of big data structures. So in my experience in Java, the only way to do that, it's actually getting a memory dump from the process.
Correct.
Yeah, so my next question would be, so do you have any other way, is there any other tool that could give us a lightweight estimation without having to actually do a memory dump of the whole thing?
So I have to do a plug here. I'm sorry, I have to. But the core of the product that we build is built for this type of scenarios. You have a thing in memory that you want to build, you want to get at, and you can add a log or a metric or a snapshot and look at the object in real time without stopping the process. So basically what you would be able to do is, for example, we have a mechanism called a Lightrun metric. You can add any type of code level metric you would like, for example, the size of an object, or maybe the more useful information would be to see the actual values inside the object, to understand why it's exploding so fast. You can do that with a Lightrun snapshot. But this is not a product pitch, despite my confusing swag. Not what I want to do here.
Yeah, but for example, will those metrics be outputted into only your product, or are they available, for example, following OpenTelemetry, the OpenTelemetry standard?
Excellent question. So, and again, I didn't want this to become a product pitch, but if you're already asking, so the bottom line is that
I'm asking. I'm very curious.
Hey, I'm sold. I'm biased, obviously, but I'm happy you are too. The bottom line is that we actually output the information, the raw textual information, into wherever you'd like. We have an IDE plugin that pipes the information there. We have integrations with Datadog, New Relic, Elasticstack, basically a bunch of different integrations that we can pipe information into. But the simplest form is that we can dump it into a file. And then you can have something like FileBit collect the files and basically push them wherever you want, maybe into some APM collector or whatever. So anywhere you want the data to be, it will be there.
Okay. So I think that's a wrap. Tom, thanks very much. You are the last speaker here. We will be, there are still other talks running in other tracks. And for you guys that are still here, I invite you to switch to the other tracks, because in the end, we'll have 5 minutes to say goodbye, all of us, and for the last thoughts on this conference. So Tom, thanks very much for being here, and I hope we can see in person in the near future here at Coimbra, Portugal, for one of the next Jnations.
I will be very happy to do so. Thank you very much for having me.
Thank you. Bye-bye.
See that the code that it is very, very easy and very, very convenient. And that's been all. This has been all my presentation. I hope you enjoy it. If you have any doubt, or I can help you using test containers, or I can share my little experience, please contact me at my Twitter handle, my email, or check my repositories in GitHub, or even my articles in my blog post. That's it. Thank you very much.
Hey, Jonathan. Yeah, man, great presentation. Thank you so much for bringing this to the Jnation this year. Yeah, so actually, I don't think we have any QA for you, but we do have an interesting comment saying that, yeah, the world needs a test compose functionality, which is quite funny. But other than that, I think we don't have anything else. We have a couple of smiles, so people I think enjoy the talk. So yes, so thank you so much for joining us today.
It's been my pleasure, and being here for the first time, and I hope it's not the last time.
Well, I mean, as I've been saying to everyone through the day, is we have to meet in person next year. So,
Yes.
and especially you because you're super close to us.
Yeah.
So you should definitely come over here if we are able to do these physically.
Yeah. I'm totally into it.
Yeah.
Thank you very much.
So yes, I mean, this was our last presentation for the day. So I'm just gonna ask you to stay for a couple extra minutes. The rest of the team is actually going to join us. I mean, you can stay, you can leave, it's fine. I'm just talking to the audience. I'm just gonna ask the team to join us to say goodbye to everyone. And so you can also appreciate what the rest of the team have done for the entire day. So some of them are the hosts for the other sessions. Some of them were like in the green room that you, Jonathan, joined before coming over here. And also we have our editing and streaming team that have done an amazing job through the day, especially because there were so many hours going on, and they had to like manage like four separate tracks. They had like all this crazy hardware, so it was like a very good job they have done. So I'm really grateful for all of them. So let's wait for the rest of the crew to join. Ricardo, can you hear me? So please let everyone else joining the Zoom if they're trying to join. I think they are. Yeah, so we need to wait, and now I need to tell a couple of jokes or this dance for you so we can entertain you. Well, there you go. Samuel is here. He can probably tell a few jokes.
No, I cannot. Not at this time, at least. Too tired for that. Hi, Jonathan, since like a few minutes ago.
Yeah. Sorry for coming in and out because it was a mess.
It's fine.
No worries.
There's Maria. She also joined.
Hi, hello.
And who are we missing?
We are
Bruno,
still
Felipe,
yes, and Daniel. We have two
Fabio,
talks.
Daniel.
We have two talks going.
Yeah, they're still finishing the other talks. So let's give them a couple of more minutes.
Hi, everyone.
Oh, there's Bruno.
Hi, Bruno.
Bruno is like with a really big smile. So I'm not sure if he's just happy or just happy that everything is done.
No, I'm happy with everything.
Okay.
The last
I guess
session was a great crack. So Tom Granite was super funny. So I'm in a good mood.
Okay. So that means that you were in a bad mood before.
Well, sometimes, but mostly happy.
Okay. Good.
The two other talks are finishing right now.
Yeah, we're waiting for
they are
rest
in
of the
Q&A.
crew. Daniel and Otavio, they'll soon join us as well. So Bruno, you can tell us a joke while we wait.
Oh no. Only if it's an observability joke, because Tom was saying that he was the best speaker ever at Jnation, and I don't know if we have logs about that.
Okay,
Sure.
so in the green room, you was saying that he was the most well dressed of all speakers, but then he saw a guy and he lost because guy had a Viking helmet on his head, and okay, he completely won that competition.
It's hard to win a Viking helmet.
Yeah. And you, Maria João, do you know any jokes?
I'm just hearing my my son screaming for me in the.
Well, just go and pick him up. That's fine. He can also join. Jokes, come on. Well, I guess like people are like, so all of us are super tired. We cannot make much jokes and entertain, but we're mostly happy that everyone had a good time, I believe, and we hope to be here next year. I'm just my brain is just shutting down at this time, so I even have a hard time speaking.
Yeah, we've been hosting the track since 9 o'clock, So everything started at 9:45, but we were here before that. And all these sessions, it's 12 hours, almost nonstop.
Yeah, but last year was worst, right?
Yeah, which was much worse. But because it was only 3 tracks, we could spread the work, the load a bit better. I think being here almost nonstop, it's a lot harsher.
Okay, so Otavio, I saw Otavio joining, but he left.
He might have connection issues.
I think he is having issues with his network right now.
Okay. Let's see if Daniel can join us. Oh, so Maria is back. Did you brought your son?
No, he just wanted me to know that you will eat the soup tomorrow, not today. And he just wants to check YouTube, nothing else.
Okay.
He can check one of our past sessions.
Yeah,
For sure.
I told him, just say hi to the gentleman here. He just said, no, I want to check YouTube.
Okay, I think Daniel is coming, so we're gonna do like the final wrap up. Maybe I can just start and then we'll have Daniel, and Guy is also joining, which is great.
Yep.
So if you haven't noticed, me and Maria are in the same room and I can hear my echo. So Maria, please, you have to turn your mic off when I'm speaking.
Okay.
Then I'll do the same when you speak. Yes, okay, so let's wrap up. Let me grab the last bit of energy that I have. I was trying to wait for the rest of the crew, but they'll joining really quick. Thank you so much for everyone on the attendee side that watched the sessions. I know that it was a long day. I know that sometimes it's hard to take some time off. I hope that some of the companies gave you some time to pick up the sessions. It was also a long day to keep on with us until the very last minute. So you'll be will be terrific, and thank you so much for bearing with us for the entire duration. No worries, all as you're probably being asking around, and everyone already mentioned that, but just to make it clear again, all the sessions are going to be available in the next couple of weeks as single sessions, so you can just catch up with a particular session that you haven't been able to watch. If you want to see them actually earlier, well, the full stream's still going to be available for the next couple of weeks still. So the only pain point is you have to search on the stream for what you're looking for. But I mean, that's not going to be really an issue. Second of all, of course, we want to thank our sponsors. None of these will be possible without the sponsors. And I hope that you have taken some time off to talk to them and see what they have to offer. The only reason why we're able to do this free for you is because the sponsors are actually taking a lot of the burden of us having to expense the conference. So having the conference, having the sponsors to be able to do this for us is actually a blessing, and we're very happy to have them with us. And especially, we started Jnation in 2018 as a physical conference. So this is our 4th year, and we are having these sponsors that have been with us for forever, since the 1st year. So they trusted us even when we haven't done anything before, and they still keep trusting us. So a good shout for all of them. So thank you so much to all the sponsors we have. So Labradut, Critical Software, Weak Software, Present Technologies, Mercedes, Volkswagen, or TBLX, Self-Focus, Bosch, Tamana. So a couple of new ones that we have over there as well. Which is really great. Mindera also being with us since the very start. X Geeks, which been with us, Red Hat as well, Talkdesk, Cleva, Deconion, and JFrog. I think I haven't forgot anyone. I tried to make all of them by memory. So, and finally, really good shout out to the entire team that made also this possible. If you don't know, Jnation has been done as a non-profit organization. So all of us are doing this with all volunteer work and volunteer time. So we don't get anything out of it other than trying to help the community. As you probably heard, I'm not sure if you heard when I did the initial announcement, part of the money that we got from the sponsors is going to institutions to help kids that don't have any homes or having a hard time. So we also try to help into that department. So that's also thanks to all of our viewers and thanks to our sponsors. But in the end, that's pretty much it. So to introduce all of our, I mean, probably heard all of them introduce themselves, but I want to give a really, really big shout out to Bruno. Hey, Bruno.
Hey, hello. I'm very happy today. It has been a tough day, but it's also has been a fun one. We had great sessions. We have no problems with them. We were able to well, no one missed, so all the speakers showed up, and the conference I think went really well in that regard, and I'm very happy for that.
Great. So the next one is Daniel.
Hey guys, really great to have you on board again. As I told on pretty much all of the sessions, I just hope next year we can see each other live and not just on little squares on a meeting platform. So thank you all for joining us, and kudos to you guys for staying there with us until now.
Yeah, so the next one is Samuel.
Hi everyone. I think everyone has already said. Thank you very much for joining us today, and I hope we meet again next year physically.
Yes, and then next is Maria.
So it's always a pleasure to join the team, to be part of this team, mostly on the background, on social media, on my job function here. But it's always a pleasure to see the outcome of it, and hopefully next year we'll be joining again physically. So thank you.
Yeah, and we're missing Octavio and Philippe, also two persons on the team. Unfortunately, they couldn't join. But a great shout out to them as well, because these will not be possible without both the help of Philippe and Otavio. Yes, so final shout out for all the speakers. This will not be possible without you providing the content as well, that you are the stars. We still have a couple of speakers with us, so it's Guy and Jonathan, so you can still say hi. Of course, all of the rest of them have to leave.
I want to see the Viking hat before leaving.
So I guess people will really enjoy Guy's presentation, and he's here with us. At least the beard, he's over there.
I've got the Viking hat. The problem is it doesn't fit over my headphones.
Yeah.
There we go. That's the golden closure right there.
You need to find a Viking helmet with headphones already in them.
Yeah. I'm like a Viking Princess Leia.
Yeah, wonderful. And I know there is one person that I still want to thank. Ricardo, please, if you can come out online. You know, I know you're there, so please show up.
Said
there he is.
Yeah. Yeah, so Ricardo is being he was the person in charge with his team on doing all the streaming, all the crazy stuff that we asked him about. Yeah, please put this video on, I'll put that video off. And he has like a huge amount of work to manage all the streaming sessions, all the Zoom rooms. So it's been a terrific job that he and his team have done. So thank you so much, Ricardo, for
No, thank you. I was
for doing this with us. And yes, I mean, I think I'm out of thanks. So I'm pretty much going to hand up here. So thank you again for everyone that made this year possible. And stay tuned because we'll be doing some announcements pretty soon for next year, hopefully. So
Let's
thank you
do
so much.
a physical event next year, shall we?
Yeah, that's the idea.
That's the idea.
Please let it be on site.
Okay. Bye bye, everyone.
Bye, guys. Bye, lads.
Thank you.